states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the
Micron is where data lives.
Live!
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
Good morning, all. A very good morning to all of you. Today, we have our keynote address by IESA CEO and President, Mr. Krishna. Mr. Krishnamurthy is a veteran in the electronics industry. He's leading our industry body, IESA, Indian Electronics and Semiconductors Association. He's a highly accomplished technologist and management professional with a career spanning of 40 years of global experience in systems, semiconductors, IP products in diverse domains. Krishna has been associated with Rambus India as the Corporate Vice President and Managing Director. So with not much ado, I would request Mr. Krishna to give his opening keynote address for the day.
Hello, good morning to all of you, and
Morning,
a
sir.
hearty welcome to the second day of the second edition of AI Summit of IESA. Within a span of 1 year itself, AI Summit has started acquiring the status of a marquee event of IESA. This year also we are holding it as a virtual event, and I'm sure from next year it will be a physical event with all of us getting together into the conference rooms as it used to be for all the IESA events before the pandemic struck. Now, coming to the summit itself, I don't think I need to elaborate anything more than what has been stated by the experts yesterday as far as the influence and impact of AI is concerned into the daily life of the common man. You had an excellent session of inauguration yesterday where multiple speakers talked about how AI is going to become an all-pervasive activity, I would call it, into our daily life. And that itself says how important or how widespread the impact of AI is going to be. You had the topic on future of computing as the first topic yesterday. The computing itself, though it is now maybe 4 decades old or 5 decades old, close to, the paradigm shift that is happening on the computing per se, as well as specifically on the edge computing, which will be a topic of discussion today, is phenomenal. The way the computers are going to talk, the computers are going to communicate, the computers are going to process data, everything is going to change because a higher level of intelligence is getting applied onto the data, onto the computer programs, and also the way the data files get managed or accessed and processed, and the outputs generated. There's a certain amount of surrealism, if you really think about it, that's taking place in the field of computing. Now, when the moment the computing goes through a paradigm shift, the underlying power or the engine of computing, which is the semiconductors, they are undergoing an equally powerful change to support the AI requirements of the future of computing, right? Now, once the semiconductor changes, the next thing that will automatically, and you saw yesterday in this session, where from Micron and others, the engine, which is the processor, how the memories and also the software and the upper layers of software, each one of them is going to undergo a transformation to support the AI way of doing things. Now, as if this is not enough, the application segments, particularly the one that we have already started experiencing in a big way in India, is the tech. You had an excellent session where Prabhat Sahu of Solar Labs talked about it every day. And there's a perception angle to it, which I wasn't aware of until I listened to that session. And then the more the artificial intelligence is put into computing, the more power the processing chips and the accompanying memories are required to burn. So actually, the low power and ultra low power AI chips come to force, which means the way the processors are designed. And I remember a talk recently given by one of the architects of the next generation AI processor. He was talking about some of the revolutionary ways the computer architecture is undergoing changes. And power consumption is one of the central pieces of that architectural change. And when artificial intelligence starts applying its knowledge, pre-gained knowledge, or what it acquires by a process of training, then there are certain aspects of security, ethics, and values that come into the computing itself, which was unthinkable maybe 10 years back. computers were considered as, okay, here is a program, certain amount of data comes in, certain amount of data goes out, and that's all about computing. But now AI and ML are changing that in a big way. And today, the session itself, after this inaugural talk, is going to start with Ria Cheru from Intel, whose entire thesis and research work and what she's doing today in Intel is all centered around ethics in AI. And I'm sure you are going to enjoy that. And then we have lined up a few verticals. One of them is automotive, which is again seeing revolutionary changes, whether it is coming to driverless cars or semi-automated cars or intelligence, multiple radars and lidars going into it, and how the entire data is used by the onboard computers of the automobiles to provide a safe driving experience. Similarly, the medical devices, that's going to be another session today today morning. And then we come back to edge computing, some of the higher aspects of the edge computing processors, and healthcare, of course. But all this finally require us to think what's going to happen to what that we learned so far about computers and processors and the way the world lived so far and the way the world is going to live henceforth, which also brings to focus the need for generating significant amount of relearning, significant amount of newly skilled or differently skilled talent in the country. So we are going to have a session later in the day today on academics and how academia has to come together to influence this big shift that's happening in the world as applied to all the different world, whether it is fintech, whether it is medical or automotive, every one of them, and edge computing, and of course the way even the servers in the cloud rooms are going to function. I think the topic itself is exciting. The verticals that have been considered by the organizing committees is all the more relevant to what's happening around us today in India. And I'm sure you're going to enjoy this entire day's session with a lot more enthusiasm. You will be able to participate in the discussions that ensue. I wish to once again congratulate the entire team of IESA members in Hyderabad who put together this conference and the two-day conference and all the sessions and selected the speakers so carefully in spite of all the challenges that they have faced before they could really wrap this whole thing up very nicely. My heartiest congratulations to the team led by Venkata and Srinivas Raju and all others. And I wish all of you good luck. Thank you.
Thank you, sir. Thank you so much. Now we have amongst us a young and dynamic data science, I can say, enthusiast, lecturer, practitioner, Ms. Ria Cheru. Ria Cheru is an AI ethics architect in the Intel Network and Edge Engineering Group, leading productization of ethical and explainable AI technologies. She has delivered technical talks for TEDx, DEF CON IoT Village, Women in Tech, Women in Data Science, and other communities to inform on the challenges and solutions in this space. Ria has a master's degree in data science from Harvard University and is an instructor of data science curricula. She is a published poet, children's book author, and neuroscience enthusiast. Welcome, Ria. I really, it's an honor and a privilege to introduce you today to the audience. And I really am amazed at the number of things you do and the accomplishments you have achieved at such a young age. So really humbled by your achievements at this age. Please, the floor is all yours now. We would like to know more about your adventures, your passions rather, not adventures.
Awesome. Thank you so much for the wonderful introduction, Sridevi. I am honored to be here on the IESA stage again for delivering a keynote for the AI Summit, and excited to talk more to some very interesting connections to responsible AI. Happy to highlight a couple of interesting tidbits I learned on my journey as well. But again, very excited to be here in front of you all. Perfect. So let me get started here. Okay, so let's dive into responsible and ethical use of AI, starting with a couple of very fresh examples in this space, important objectives and trends that we can start to analyze and dig deeper into, and some key takeaways that we can use to organize our thinking about the emerging landscape here. So first, if I can narrow this audience's attention to a very specific set of topics that we have the scope to cover today, because responsible AI is an incredibly large field. We constantly see new directions from academic, industry, and a variety of other organizations, including in the governmental space, pop up all the time. So what I would like to introduce right at the get-go as part of this presentation is a framework for thinking about this. I'd like to walk you all through a interesting direction of first, establishing the definition of AI systems, getting our alignment there, and then starting to move on and progress to why do we need AI ethics in the first place, and then how do we implement it and approach it from multiple different angles. Now, that being said, there are a couple of different objectives that I would like to set at the beginning of this talk. The primary one is on informing. As I mentioned, it's a very broad field. There's a lot of different directions and ways where it makes it easy to get overwhelmed with the amount of directions and to keep on track of them. It's also very exciting where we have multiple different teams from these different sectors and verticals very excited to jump in and make a difference for societal impact. So we really want to be able to categorize a lot of these elements and put together how does this lay down as part of a concrete plan, adjacent and also tied very closely together with current AI efforts. I also want to put forth a call to action around being able to drive coordinated innovation for building these types of systems and a couple of proposed next steps. Perfect. So with that being said, let's start first with what are AI systems. Now here, the key definitions that I'd like to draw on are from two regulatory guidelines. The first is one from the ISO/IEC, a technical or TR document around AI being the capability to acquire, process, create, and apply knowledge. And here we are distilling AI systems to the core elements that are composed, that they are composed of, and now being able to identify and apply to all of these different definitions. Again, as this audience might be well aware, the scope and amount or types of AI systems is very broad. You can consider systems that are used for different data modalities and formats, such as images, text, etc. And then you can consider breakdowns of those models further. So the primary attempt with this definition is to be able to cover a lot of these different types of AI models under one generic definition, and then be able to elaborate further as the use case permits. Another great example, I think, of this type of umbrella definition is the definition taken from the EU Commission's communication on AI, where here the definition is put forth that AI systems are systems that display intelligent behavior by analyzing their environment, and they take actions to achieve specific goals. Here, it is very interesting now to start to consider the embodiment of these systems, whether they are software-based, for example, in the very popular use case of voice assistants, or if they are embedded in hardware devices, as we see in the Internet of Things ecosystem. And this really starts to add in a flavor to the type of AI system, its use cases, its value proposition, etc. So now that we've put forth two primary definitions for AI systems, let's now navigate further and start to break down step by step what is really the motivation for responsible AI? What are some of the trends corresponding to this? So here, data is at the core of the AI system execution. As I think noted in the inaugural keynote, it is very excellently specified that it is a very interesting and evolving landscape as part of AI development that is really consisting of a lot of different elements of data. it's very easy to create simplified pipelines of this, but to actually put forth more complex visualizations of real life AI pipelines is very complicated. For the purposes of this talk, I have distilled the core elements down into these two diagrams. The one at the left is a attempt to indicate that normally when we look at an AI pipeline, we really see it as input data, your AI model in the middle, and then the output data. Now, more emerging trends in the responsible AI space are starting to change this. We are starting to see the middle part of the pipeline as well related to model data as a crucial component that does come under the data umbrella as well, whether it be metadata, additional data related to the societal framework and risk management approaches associated with the AI model, and similar elements. And I'll be diving into what this means in a couple of moments as well. But really, data being at the core of this type of execution model, we then transition to looking at a more realistic overview of what an AI platform and workflow might start to look at the right of this slide. And that is really, again, a simplification. It applies for some AI pipelines. There was a point in time where it may apply for most, but that is slowly starting to change with custom use cases and models and deployment options. But here it's really composed of data preparation, model selection, all the way to benchmarking and optimization, and then development, finishing up these stages, and then moving on to deployment and monitoring. So data touching all of these elements and in and of itself being the umbrella for this entire workflow is one of the core trends of AI systems and the foundations of the technology that will continue to grow over time. So what is the impact then here on responsible use? Where does the ethical value really come into play here? And this is where we start to take a step back and think, okay, we're looking at data and how it is directly tied to the core foundations of AI models, problems, and mindsets. But what makes an AI system different? It is a very interesting question to consider from a security and a red teaming perspective, actually. If we were to put our hacker hats on, an interesting question, for example, could be, do the same protections that we apply for typical, workloads and data points also apply just, directly for AI models? Or are there some unique assets to AI that differentiate it from typical data and typical workloads? And I think this is where some very interesting elements start to come into play around, why not look at just responsible technology? Why are we specializing specifically on responsible AI as part of these domains? And how does it connect to the overall bigger picture? The very interesting example that's being put forth in the field, and I like to draw on from an Internet of Things background, is around continual learning. And this is a very fascinating kind of approach towards deploying AI systems. It's starting to become more mainstream. And we are starting to see a lot of problems emerge in taking our common AI pipelines and models, optimizing them, and then just deploying them in these real-world situations. Some of these problems include concept and data drift, where the input data that's getting passed to your model suddenly changes, and you need ways to be able to detect that change so that your model doesn't fail unexpectedly and you're not sure why, or you weren't able to anticipate it. There's also some very interesting phenomenon that academia has done a wonderful job of scoping out, and is, these approaches are now being evaluated seriously by industry around problems such as catastrophic forgetting, where your model may start to forget things that it has previously learned once it has started to learn new tasks or new information. Outside of all of these, if we kind of take a step back and focus, going back to the data drift type of example on uncertainties, you can now start to categorize the types of uncertainties that could take place in your data and include technical mechanisms specifically within your AI model in order to account for them. And some common terminology in this space includes systematic and random uncertainty, as well as esoteric and epistemic uncertainty. Again, trying to categorize, is the uncertainty in my data, these sudden shifts, are they natural? Is it just a property of the data to deviate like this? Or is it something that I could prevent by getting more data? essentially trying to adopt a big data type of mindset or approach, or incorporating some specific mechanisms in my AI models. Again, it's a lot just looking at this specific use case and example. And one of the final ones that really transforms this entirely is composite systems. So now you're not worrying about these elements for just one AI model for your one use case. You're now starting to create pipelines of different AI models running in parallel or running in sequence. And you need to deal with these concerns for all of them. My opinion is that all of these concerns directly come under the responsible AI space, because they're starting to argue for the fact that AI is different from what we see with typical workloads. It's constantly evolving for a particular use case. There are certain changes and certain expectations that are unique to these models that we may not see if we put on a traditional workload or traditional data hat. Now, what exactly are these concerns? Can we distill them into attributes? That is what I see from the technical engineering perspective is the primary motivation for the responsible AI space. There's a societal aspect to that too that directly influences the technology development, and that's what we're going to be looking at next in the next few slides. So a quick overview of AI ethics technical development efforts. AI ethics, as I see it, and is a popular definition in the field that I've now distilled down, is really around a socio-technical lens on the design and impact of AI solutions on our societies. Over on the right, I have a couple of different elements that are documented around transparency, security, fairness, and energy efficiency that really target a lot of the different key areas of ethical AI and distill them into core elements. During the scope of this talk, I'm mentioning them very briefly. They are, again, very large areas in and of themselves that have their own research directions as well as scope and value proposition that I encourage members of the audience to explore further as they see fit to their use case. But really, this entire landscape and all of these elements that are being identified are also tying back to stakeholder expectations related to the AI lifecycle, including business owners, regulators, AI engineers, data scientists, domain experts. The list goes on regarding the relevant stakeholders that are influenced by these principles and practices. Again, myriad types of ethical AI, lots of terms that are being thrown out there: responsible, human-centered, accountable, dependable. And distilling these down to their core definitions is really the key part or motivation of the field as we see it today. There's also here that I'm including as a reference a very great indication from a lot of industry trends, such as the Gartner Hype Cycle, around the different elements of ethical AI, including, as previously mentioned, human-centered AI, and a couple of others around digital ethics and similar that are starting to become in trend. We're seeing a lot of organizations start to adopt the technology and evaluate it. So naturally, it is a key moment as part of the industry to consider how responsible AI directly applies to your use cases and move forward from there. Now, this being said, something that I wanted to zoom through as part of this talk is also regulatory guidelines. We are seeing a lot of very excellent efforts from different organizations and governments to define clearly the elements and compliance related items that are required for responsible AI. We have, for example, some documents from the National Institute of Standards and Technology around explainable AI guidelines and how AI systems should start to include some of these capabilities for improving the transparency of the system, so the users know what's going on with their data at a particular point in time, and regulators are able to understand, even though they may not be domain experts, what is really going on with the technology and audit it. We see very similar types of findings echoed across different regulations, including some guidelines from the European Commission, and similarly, the Singapore Model Governance Framework, as well as recent efforts from India's Responsible AI, AI for All efforts. Again, a very detailed categorization of some of these approaches that is work in progress in order to distill what needs to be done in the space. Now, all of that being said, a couple of critical elements here as well around how Internet of Things starts to come into play to relate back to that continual learning example, where here IoT devices are one very interesting example in the AI space that are enabling actions that are made by these intelligent AI agents. They are allowing AI algorithms to consume and produce data at a massive scale, and then also now starting to have very interesting implications from the responsible AI perspective in terms of what can or cannot be done in the space. What is the prioritization of resources that we allocate to a particular model during an edge deployment use case, and how do we do checks such as quality assurance checks and runtime checks on the edge and in the cloud. So it's a really big challenge of translating these elements back to the pipelines, and putting it all together. Some of the elements that I mentioned previously, things like accuracy, resiliency, explainability, safety, all of these elements have their own unique definitions and ways of applying to particular use cases as part of AI workflows. What I've done here, taking this problem of translating the elements, I've created a very simple pipeline diagram here. And let's see, that will jump to here at the end of the slide, that attempts to simplify this process and is essentially allowing for deeper translation of the different elements. And again, something to provoke the audience, see if you can get a couple of ideas from this as well as you consider applying responsible AI for your domain. But a couple of these intercepts include items related to privacy, where we are starting to look at data protection and security intercepts at multiple different stages of the AI pipeline, as well as elements related to fairness and transparency, where you're starting to get evaluations of bias at multiple different stages end to end for AI pipelines, including at the data, model, and output stages as well. Finally, I think concluding in the last few minutes of this talk, in terms of the relation back to the semiconductor industry and what do we actually do in this space to tie it all back together, there are a couple of key things that are starting to emerge here. There is computational complexity of enabling ethical and responsible AI operations is a very big trend here. Those mechanisms I related back to on data drift and concept drift, they can be at certain points in time very challenging to scale. Similarly, the technical mechanisms that you would incorporate into AI algorithms to enable better explainability can also be very computationally intensive. So this is a key next trend for the industry as we see it, as well as academia and the organizations who are involved in developing these platforms. Similarly, transparency and end-to-end security is a very big topic as part of the field, and one of the best next steps to enable compliance of AI algorithms, both from the use of responsible AI perspective as well as responsible use of AI perspective as well. Here we are looking at intercepts around quality assurance of AI models, as well as also being able to take some of these algorithms that are very private and secure and then say, okay, let's validate this and say, are the claims that are being made really being substantiated? And if so, how? And how can we protect the algorithms during runtime and as well during the training process in a way that meets stakeholder expectations? Finally, something that is very challenging to consolidate in this short amount of time, but something I'd like to emphasize to this audience is also differentiated levels of trustworthiness, where it is not enough simply to just claim a generic definition of these different attributes, or even a very quick summary and then move forward. We really need to do deep dives on the specific elements and start to see how they apply to our core machine learning pipelines and influence society at large. I would like to conclude in the last few moments with the approaches that Intel is taking in the space. So here we are working on our framework to build trustworthy AI systems and have a couple of exciting announcements that have been released both at this point in time as well as scoped out for the future, where we are proposing that we look at responsible AI from a technology development perspective, not only from a software kind of idea or element, speaking to some of those attributes that I shared, but also from levels including foundational platform security, trusted compute, model IP protection, all the way to the software, more software-focused elements such as data protection and trustworthiness. So it is a full end-to-end perspective that we need to start to emphasize on. And we have a couple of technologies that we have put forth to help our customers identify and start to apply and distill this very challenging field of responsible AI into, again, your current pipelines. That being said, the last couple of steps around takeaways for fostering coordinated and cross-disciplinary innovation in the space, being able to work with AI teams more closely as a key takeaway to this audience to help address your needs and the needs of the partners and customers that you're working with for responsible AI technologies. And finally, being able to build a very strong community around this for mindshare, more elaboration on technical definitions, and being able to debate and see where we go from here. So that was a very quick introduction to the responsible AI space that I hope was helpful. I didn't get to cover the amount of detail that I had expected, but I hope this is a good launching pad for this audience to then consider their own exploration and digest the talks later today in the context of this mindset for technology and AI algorithms that impact both the way that we do engineering and the AI landscape at large, but also impact society and the way different stakeholders are impacted by the technology. Thank you so much for your time.
Ria, this was amazing. Thank you so much for an exhaustive session. Actually, you were telling that you have not covered extensively. Trust me, you have covered very extensively, but we would have loved to have more time to listen to you. And there are a few questions. We will direct them to you, to your email ID. Thank you so much, and the very best.
Thank you so much, Sridevi and team. Thank you again for the opportunity, and I appreciate all of your time.
Thank you.
Thank you.
So our next speaker is again somebody who has been on a path-breaking journey in the semiconductor space, Mr. Ramesh Singh, who is the Executive Vice President and General Manager of VisionQ Business Unit. Mr. Singh is a successful entrepreneur, has co-founded and grown multiple companies in the computational imaging, vision, and video markets, as well as mobile communications. Most recently, he co-founded a fabulous semiconductor company focused on edge-based vision processing and perception solutions. He also founded and successfully scaled multiple startups, including Eglistor, founded in 2015 and acquired by T-Second in 2020. Netra Imaging, founded in 2004 and acquired by Imagination Technologies in 2012. And MediaQ, founded in 1997 and acquired by NVIDIA in 2003. That's quite an achievement. Throughout his career, Mr. Singh has held various senior management positions and roles in public companies, including Imagination Technologies, NVIDIA, S3, etc. Mr. Singh currently serves as the board of directors for several technology companies, including as the chairman of board of VVDN Technologies, a leading provider of vision-based artificial intelligence and machine learning solutions company. Mr. Singh holds a master's in electrical engineering from Southern Methodist University in Texas, and bachelor's in electrical and electronics engineering from University of Kentucky. With not much ado, I would request Mr. Ramesh Singh to address the audience. Morning, sir.
Thank you. Hello, everyone. It's a pleasure to be part of this exciting AI summit and an honor to introduce ME Semiconductor. I represent the VisionQ business unit, where the business unit is dedicated to providing vision-based AI system solutions. These are things like we're initially focused on cameras being implemented in cars, such as rear view cameras, front view cameras, surround view cameras, even e-mirrors, and addressing other applications like driver monitoring system or occupant monitoring system. And all of this, our goal is to eventually lead to fusion of multiple sensing solutions through its unique approach to the software perception stack. As the focus of AI adoption in the India auto industry increases, it's equally important to create comfort in adoption by the consumer. After all, the end goal is for the benefit of the consumer and to have a better experience and overall greater safety. We've seen and heard AI is everywhere. AI will drive our lives. AI will make our lives better, safer, more enjoyable. Well, how do we address that? That's what we'll delve into deeper today and share thoughts on how the deployment will create a better user experience. As you can see, this AI summit has many prongs, and we'll focus today on what I've coined as AI adoption with complex distributed compute, addressing enhanced safety regulations. As Indy sees, products being adopted for this distributed compute, it also sees, progressions of features and functions that eventually will drive, the adoption of these functions that truly enable advanced capabilities in sensing. The next generation of automobile platform is driven by, a huge SAM of $40 billion and more, and adopting the mega trends ahead of us. And what we see today is these mega trends, addressing the autonomous enablement. India has a significant edge on the competition because it has already delivered so many solutions to the marketplace, and being dedicated and completely focused on the automotive market, it creates a barrier for others to really impact. We've also reached an interesting inflection point where you see much higher silicon content in every car. And this addresses the need for the user experience, the safety systems, the EV adoption, and the growth and connectivity requirements. We see that growth year over year of these adoptions are really creating a much higher silicon content for us to play with in these automobiles. The silicon content we expect, are going to grow 10 times over the next 3 to 5 years, driven by one key trend, that is the higher compute requirements to handle the many more sensor modalities. I mean, here you see today going into the future where you see the content of, the silicon growing 10 times. So this is where Indy has seen the scalability of its product shipments to address the mega trends, while it continues to develop innovative solutions to address the growing requirements. You can see we shipped many millions of units, and the OEM penetration per vehicle is scaling very aggressively. The fundamental reason why I'm trying to give you some background on Indy's performance and ability to deliver to the market is it gives the competitive edge in its feature-rich products to help deliver, engagements with leading OEMs and tier ones. And we see similar growth opportunities in the coming years with AI, and where AI becomes much more pervasive, addressing the mega trends we're talking about. And this again creates that, differentiation that people are looking for. And when we, speak of mega trends, I think today we see the three primary areas where we talk about ADAS, and we talk about the connectivity, the user experience. We talk about how do we, get more and more developments addressing the EV side of things. I think if we look at these three mega trends and the computational requirements and then the AI enablements along the way, you'll see a significant uptick on the adoption of AI. And while we address these mega trends, the one common theme is how to support multiple sensor modalities in hardware, in software, and applications, and the overall handling of a unified, what we call the perception stack. Again, software is going to play a major role in these progressions. An example is here, and I'm showing, is Indie's focus on LiDAR, radar, vision, and the goal that these sensor modalities are eventually fused in both hardware and software subsystems, providing a complete sensing solution to the OEMs and tier ones. I mean, this subsystem requires a tremendous amount of integration from all the hardware layers to the application layer. And these applications will be developed over years. And as a key value proposition, the innovation not only comes from the folks like Indie, but also the OEMs and the tier ones have been evolving these algorithms and these sensor modality integration techniques over the years, which eventually lead to safety and better handling of how they address the regulation requirements. The challenges for systems, in the sensing and addressing the sensing solutions is that they are major bottlenecks that you will see in the current vehicle architecture. And simply throwing more and more compute, or in this particular case, MCUs and more hardware, become cost prohibitive and require much, much more power. Here we're seeing 50 to 70 MCUs in a mid-segment car. That's just, and the demand for AI increases that. And there are limitations in how you grow these requirements. Proprietary architectures, limit the ability for the tier ones and the OEMs to have multiple solutions. So on one hand, you want to drive standardization, but on the other hand, you want to drive, the abilities to address safety functions and regulations around the world. It just becomes a very challenging task for everyone involved. And we'll see sensing needs are going to scale with the vehicle platforms, whether it's an entry-level, mid-level, or higher end scale of the automotive options. What happens is the combination of the varying computes will play out to where these multiple sensor modalities, the complexities of the software grow exponentially, and it has to be balanced with the appropriate compute in each one of these applications. This is, where the cost, the prohibitiveness of compute and data transport, how it gets addressed with having a distributed versus a centralized system. This is where a combination of varying compute requirements and then the central compute will not address the growing requirements of the AI functionality. It actually wants more and more throughput, but yet there are certain bottlenecks in a unified system like this that you just can't overcome. And what we're seeing is, how do we address the challenging of these sensing solutions that we just brought up? As we discuss these challenges again of sensing systems, what we're trying to do is really look at something very, very scalable in hardware architecture, software architecture. We have many software-defined functions that start coming to play as well. And so as we look at those kind of capabilities, we see cost, power, actual data throughput, really the varying level of complex use cases will help define the architecture. And the ability to have what we call edge and zonal-based compute are going to be the next wave of adoption. And the central compute, there's multiple players vying for that, and we see that is the architecture today that the adoption is driving for. But we believe that for the right AI level compute elements that we're trying to bring to market over the next few years, we'll need a more distributed set of requirements, and thus edge and the zonal processing, we feel like will play a major role. And this also addresses different levels of automobile, basically the lower end and the mid-level will be able to take advantage of the edge compute much more nicely when it comes to price, performance, and feature set. And so that in itself right now is driving the AI adoption. We feel of the higher level down to the camera level, down to the fusion level. These combination of things will really play a major role in the decisions of safety and functionality for us. Now, if you look at eventually the scalability and the distributed compute we talk about, it's provides much more efficient hardware compute, software enablement, and then the application software playing a total solution game. And as you can see, if you distribute and then eventually basically bring together the abilities of all of the computation and have a system that eventually is overall software less complex. And as software, this is both the embedded and the application, takes more and more of the solution into the AI aspect and becomes a solution in itself to address AI functionality and computation, which eventually people are trying to actually drive standardization of how the software works independent of the hardware, so that there's an abstraction layer that really plays a bigger role. Now, if you see this, the ability for each element to be playing a role, whether it's a image processor or a GPU or even a perception engine that's dedicated to run certain algorithms, that's what scalability will enable in the edge compute to the zonal compute. And these elements become much more compute intensive as we go through the hierarchical architecture. And what plays well into a unified processing architecture is a lot of customization, obviously, but these customizations have some balance of standardization as well. What we see here is that if you look at the hardware platform and how the software has to address the performance of the hardware, and then eventually you want to create a tool chain and an ecosystem for developing and leveraging the hardware software platform, that eventually becomes a architecture that's driving towards a standard, but where we see AI becoming more and more pervasive and easier adoption into the different automobiles. And so when you talk about perception, image processing, video processing, radar processing, LiDAR processing, and the fusion of these sensor modalities, you'll see the pervasiveness of the AI becoming easier to be adopted by the tier ones, the OEMs, and then giving the consumer the ease of use. So we talk about computer vision, we talk about AI, we talk about machine learning. They're all integral part of the automotive safety requirements. And what we see is things are developing very fast and impacting the automobile industry very cohesively, but it's eventually defining how the customer experience, the consumer experience will come about while addressing the safety needs and how the society views these safety functions. If you look at the AI impact on the auto industry, it's huge. It addresses the gaps and in general, the safety regulations. The industry is facing an onslaught of regulatory and technological challenges. And how data security, aggregation of the data will be handled, and the security aspects are becoming bigger and bigger aspect of controlling the data, who all gets access to the data, and so forth. We've all seen the attribute of taking control of a car that the user, the consumer's in, and somebody else takes control of it. You don't want that, right? The connected cars are going to be the future, but it also needs to help with real-time experience in a positive fashion, and then give you the safety functions with less latencies, that the applications can execute too. If you look at, how all of this pervasiveness of safety functionality, addressing the regulatory requirements, and with respect to fundamentally delivering solutions that are AI enabled, we have to bring, many things together, and standardizations will not get there in the next few years, even though the trying is there. And what we see as Indie, a leading provider in the key automotive sensing solution, is that if you have the computation, distribution of the distributed compute with edge compute and zonal compute, and then eventually the central compute, this will drive optimal solutions for eventually the sensor fusion aspects, and implementing a unified software stack and perception stack to meet the increasing demands of the safety regulations. India itself has much to gain in adopting these AI capabilities. Our goal, India's goal for India automakers, is to have them participate in adopting the sensor modalities to make driving fun with all the safety functions as well. I hope we were able to give you some insight in our views, and not only will it play in the worldwide view of things, but also how it plays in India. We really believe the AI growth, the AI platforms, the AI ecosystem will help functional safety for cars, will help the user experience to be much, much better, and the ease of use as well, while giving the overall performance and the ability for the automobiles to be safe for the consumer. Take care, everyone. Look forward to making this partnership between Indie Semiconductor and India's automakers an everlasting success together. Thank you. Thank you.
Yeah, thank you, sir. Thank you, Ramesh Singh ji. Amen. I really wish what you're hoping for happens. Next, we have a power-packed panel discussion on AI's impact on the automobile industry. We have with us Mr. Abhay Rai, Mr. Vishwanath from Volvo, Mr. Abhay Rai from Indie Semiconductors, Kristin Slenina from Velodyne Lidar, Ramesh Shanmughan from Ignitarium, Lakshmi Prasad from Veoneer. This is an amazing panel to discuss impact on automobile industry. Let me introduce you the chair, Mr. Abhay Rai, Senior Vice President of Indie Semiconductors Vision Q Business Unit, who is responsible for developing and industrialization of automotive computer vision and sensor fusion solutions. Prior to joining Indie, Mr. Abhay was the Global Vice President of Marketing for Visteon. Markedly under his leadership, Visteon had one of the most successful show experiences to date at CES 2020. Successfully launching over 17 new product introductions on the show floor. Prior to Visteon, Mr. Roy was head of automotive marketing for Sony and was responsible for establishing Sony's presence in the automotive industry. He advanced product and technology developments in the automotive sensing, which ultimately led to multiple design wins for Sony's camera on many ADAs and AD vehicle platforms. Mr. Roy earned his MSEE from Colorado State University and Executive MBA from UC Berkeley Haas School of Business. So I would like to take this opportunity to welcome all the panelists. Over to you, Mr. Abhay.
Well, thank you. So I was also in process of changing this to virtual background, but thank you, and let me welcome my fellow panelists on behalf of IESA AI Summit. I'm honored to chair this panel, and incredibly humbled to see that we have such a rock star panelists as part of this panel. I think each one of us are thought leader in our own way, and hopefully this is going to be very interesting session today. So let me share a presentation to guide the discussion flow. Moreover, this is just for the purpose of guiding the flow. And as I go along, I'll ask questions to panelists. But let me first set the ground rule. I just want to remind everybody that this is not a marketing platform. Since the panelists are thought leader, I'm expecting that we are going to bring a major viewpoint, and it will generate light, not the fire. So I'm hoping that as we go along, each panelist will be able to add something on top of others. So let's make it interactive. The flow is I will ask each panelist to introduce themselves very quickly. Then I will go through some of the key trends. It's very interesting time in automotive. And then we'll go through where the AI is today and where it's headed. Then I'll call audience for the participation. It would be nice to see everybody's viewpoint. And then in closing, I would request each panelist to give a very short 1 or 2 key takeaway from the discussion. So we are 5 of us. Vishwanath heads the India Center for Volvo, which is near and dear to my heart, specifically in the recent year, what they have done to maintain their market leadership in the technology space, and also what they have done in the Polestar and Polestar 2 architecture. Christine, she's a dear friend, and she has been in the middle of transformation. She has, in fact, contributed handsomely for the transformation of automotive industry. So these 2 people are from the OEM side of the world. Ramesh has very interesting background. So he comes from services and semiconductor delivery. I have been in mix of all of this. Basically, I worked in the technology space, also worked in semiconductor space. And Lakshmi, he heads the ADAS part with Veoneer, one of the market leaders in front sensing space. So without further ado, let me start with Christine. Christine, if you be so kind to introduce yourself, that would be great.
Hello, thank you, Ade. So I have actually started my journey in automotive when I was co-captain and driver my senior year at MIT. And those races that we did were so much fun that I hired into Ford after I got my master's in mechanical engineering. So started in engine engineering, and it sort of evolved into strategy and planning, advanced technologies, and at the end, defining Ford's blueprint for the future of mobility. So really looking at how autonomous, connected, and electric could play a different role, and with those technologies, what new business models and what's the role of an OEM in those business models. And as of July, I am a board member of Velodyne LiDAR as well. Thank you.
Thank you, Christine. It's such a pleasure and honor to have you on this panel. So with that, I will invite Vishwanath to introduce himself, please. So Vishwanath, I don't know if you are on the call. If you are, probably you are on mute. Okay, let me go to Ramesh. Ramesh, if you can introduce yourself.
Hey, hello, Abhay. Am I audible?
Yes, absolutely.
Hey, thank you, Abhay, and thank you, IESA, for giving me the opportunity to be part of this panel discussion. So I'm Ramesh Shanmugam, co-founder of Ignitarium Technology Solutions. So my background has been as a VLSI designer. I started my career and have been part of developing this ARM-based automotive system on chip for various automotive applications like the airbag controllers, the ABS, and the chassis controller kind of an application. So even in Ignitarium, we focus more on the automotive side. So my passion has been on the technology towards this automotive side. So thank you, and hope I can share a little bit of wisdom that I have with this audience.
Very nice to have you on the panel as well, Ramesh. So with that, Lakshmi, if you would be so kind to introduce yourself, please.
Good morning, everyone, and good evening, because of different time zones, I say it. So my name is Lakshmi Prasad. So I work for Veneer India Private Limited, and I have around 23 years of experience in various industry fields like defense, telecom, and automotive industries. But majority of my experience come from automotive, and that too in the active safety product development. And currently, I'm heading the autonomous driving assistance system department at Veneer. My core competency includes like development of software, hardware for active safety products. Specifically, you can say it as a camera or domain controllers. Not only that, my competency includes of integrating these active safety products into the vehicle, basically to evaluate the active safety features, performance, and generate KPIs. Also, like I do perform certain kind of a benchmarking of the several active safety products against the competitors, and also participate in the RFQs, customer RFQs, and give demonstrations to the local and global OEMs, majorly to bring the business for the company. So that's all overall the high level my competency includes for the active safety product development. Thank you.
So very nice to have you on board as well, Lakshmi. So welcome everybody. It's past midnight for Christine and myself. So I think we are not in our best. Probably we are drowsy. Ramesh is half drowsy as well. He's 1 hour behind us. Hopefully we'll try our best. So let me just start with the high level couple of megatrend and where industry has been heading. Very interesting time, first of all, in automotive industry. It's at the cusp of being disrupted in a big way because of for first time ever, 3 simultaneous megatrends are synchronously hitting the automotive industry. So what happened is, if you look at on the left side of this chart, if you look at the vehicle composition in 2015 in Europe, over 51% of the cars sold in Europe were diesel engines, and 44% of the cars sold were gasoline engines. When the Dieselgate scandal happened, right after that, because of that Dieselgate scandal, the composition completely changed. And majority of the cars sold were petrol. And as we know that CO2 emission from the gasoline engine is much, much higher. So as a result, if you look at the right side of the curve, what happened to the CO2 emission in Europe, it went to skyrocket in 2018. So as a result, European Union swung into action, and they made a mandate that by this year, all the automakers have to meet 95 gram per kilometer CO2 emission. Otherwise, there is going to be huge fine. So as a result, what we did, we saw that industry completely shifted in Europe. Daimler announced that they are going to completely stop ICE development, and they're going to move towards electrification. VW did the same thing. And what we have seen in Europe, I mean, basically, electrification is a massive undertaking. So what we saw is GM partnered with Honda, and a lot of other things have happened in this space as well. Now, this is going to be further detrimental because rest of the world has to also converge to 80 gram per kilometer by 2030. And that's why we see a lot of behavior, right? So on this curve, you can see that China is being very aggressive because they have to also get from one point to where they have to dramatically cut the CO2 emission. US actually went back in the Trump era, and they have to correct as well. So we will continue to see development in this field. So this brings me to my first question. I picked Christine because I want to go top down. And Christine has a very interesting background. I don't know if people picked this or not, but she developed she was actually responsible for developing the internal combustion engines at Ford. And over time, she also perfected it. Like when regulations were coming, she was linearly improving those engines. And last year, she was responsible for Charge Across America, which was basically driving electrified vehicles all the way from East Coast to West Coast. So, Christine, I would maybe request you to kind of highlight that a little bit. Also share your journey, what you learned that way. And then if you can also answer my question, basically, I see a trend that if you look at OEM supplier panel composition, basically OEMs are not sending all the RFQs today to the supplier panels. Some of the RFQs are directly going to the technology providers. So please share your experience, and then also if you can highlight how the supplier panel composition is going to transform in 2030.
Yeah, thanks, Abe. So you're right. It was so interesting that, 30 years ago, being part of the solar car team while at university, it was all about, we could even see back then that things were going to change, and we literally wanted to change the world. So it is interesting that I hired into engine division. I spent 23 years in the OEM world and learning about engines, and of course, the whole engine system, the powertrain system. So a big part of that, of course, is the emissions that you have. I learned a tremendous amount. And then as we start shifting to EVs, I mean, you're right, like the race across America, what I wanted to do is stress test the system. So I'm right now Chief Innovation Officer at Park My Fleet, creating these new future mobility ecosystem hubs for electric vehicles. And I thought, what better way to really understand the current state and what's possible, but also what opportunities do we have to transform in the future for mass production than to do this myself. So I personally drove a Tesla Model Y from New York to Los Angeles. It was a 3,300 mile stretch that was outlined, and had it professionally filmed and watched 5 other teams, so 10 other people, use the non-Tesla infrastructure. And it was just a fascinating experience, one, to compare the differences of the systems between the two. And it gave me a lot more insights about how we need to transform differently in the future. So as you look at, the supplier-based panel, I mean, obviously I know a lot about the engines and powertrain systems. Now we are going over to electrify this. And So the OEMs are already have been starting, you know, that transition and changing their organizational structures as they have, you know, it seems like almost every week we get new announcements about investments in electrification from the OEMs themselves. And the suppliers are really keeping up with that as well, because they're looking at how do they start shifting then from the ICE structure into the electrification structure, and the differences in the components and the skill sets and expertise needed. So I would say actually there's been a war on talent in terms of the OEM world, and what that looks like. There's a shortage.
So that's a great point, Christine. So let me ask a follow-up question. So as the industry transforms from internal combustion engine to electrification, the number of parts needed, I mean, no longer you need 30,000 parts to build a car. Probably you are good with 3,000 parts. So how do you see that as the industry keep moving along, how the value chain will transform? Per se, what I'm trying to say is basically there is a very successful business model with the ICE. And then there is going to be a new business model which needs some kind of capital infusion and basically very, very different value chain. So how are OEM going to manage that transformation, and how the value chain itself is going to transform?
Yeah, and you know what we've also started to see many different companies working together. You know, this is a very expensive endeavor when you look at batteries. We also have the whole materials question of it, right? So do we have enough of the materials of our current, you know, lithium ion battery sources? And I know that that has been a big question as the OEM. So there's a lot more collaboration, I think, happening now in the ecosystem. We're seeing more partnerships to co-develop some of these expensive systems, as well as the infrastructure part. And remember, the infrastructure is a really important part of this new future because it didn't exist basically not that long ago. And you know, I like to look at history to help guide us. When you think back to the early 1900s, there were not any gas stations. How did people get their fuel, right? They actually would buy it at the hardware store, the pharmacy, like in bottles. And then we had a transition period when you looked, I would call it a 10-year period where it just completely flip-flopped between the horse and the carriage and gasoline. And in the early 1930s, there was like approximately 100,000 gas stations then in the US, which equates to about where we were the first of this year in January 2022 in terms of electrical stations. So it's interesting how we're now starting to get some of the infrastructure there globally. We are starting to get, you know, the people are starting to better understand the differences in driving an electric car. And as we showed across that race, it is certainly possible today, but there are issues to overcome on this. In terms of the supply chain side, I do think that having different OEMs work together is going to be a good thing. Co-investments are going to be key, especially as the skill sets. They're very different skill sets, right? And the OEMs are, I think, navigating what it means to have, you know, we're really now going to an electrified and software kind of platform. So they are needing to make sure that they work with the supply base very well as the supply base transitions into this new world of electronics and software. And, you know, and we also have questions about long-term battery durabilities, right? And the battery stuff, the battery itself there's lots of changes happening in the battery itself, which I think will enable us for longer range, lighter weight. So I think we're going to see a transformation in that space as well. A lot of innovation I see coming around the corner.
Well, thank you, Christine. So let me invite Lakshmi to see if he has any comments. So Lakshmi, you are in the middle of it, right? You are part of the supplier panel at a lot of OEMs. From your side of the world, what changes do you see?
Yeah, Javi, thanks for that. So as a supplier, because now a lot of vehicle architecture changes, because nowadays the OEMs are coming up with centralized computing architectures. This has a bigger impact on the Tier 1 suppliers, not only for Tier 1 suppliers, but also for the semiconductor chips providers. Why I say it, the impact is both on the hardware and the software side. Let us take, for example, the current scenario, whatever it is running on. Most of the active safety products, if you take the active safety products as an example, most of the perception and the features are running in the smart sensors, like in the camera module and everything. But which process a lot of big data for image processing algorithms running the camera sensor module, which provides both the lane and object information. And this information will be passed into the domain controller, where majority of the fusion will take place, and which will finally control the lateral and longitudinal movement of the vehicle, basically to support level 2 and level 3 features and everything. But because of the introduction now usually the camera smart sensors, usually which process the majority of the perception algorithms in the sensor itself, it has a bigger, it takes a bigger form factor. It occupies major space in the vehicle when you fit in the vehicle, the entire sensors in the vehicle. So nowadays, what they're doing is they're making these sensors as a satellite sensors, basically in the sense, these raw data will, the satellite sensors are capable of sending only the raw data to some ECU which is present in the central computer. Basically, this central computing, the majority of the perception and feature algorithms will be presented in this central computing architecture. That increases a lot of high-end process to be implemented in this centralized computing architecture issues. Basically, like high SOCs, and there's a bigger impact on the SOC side also, which they need to change their roadmap to provide such kind of a high performance-based. They should be able to execute the algorithm, the perception algorithms or feature algorithms in the less time, lower power dissipation, and also concentrate on the functional safety requirements. Basically, most of the SOCs should have the SLD compliance as per the customers, OEMs demands, and also the system ability to withstand the cybersecurity threats. So this is a bigger change of the hardware point of view. And there is also impact on the software point of view also, in which majority of the perception algorithms in the previous cases sometimes, as of now, till now, most of the image processing is done in, like, for example, if you take the camera sensor, the perception algorithms are basically the conventional image processing algorithms. But now the trend is moving to the artificial intelligence, making use of the deep learning techniques, where they try to process the image data using the deep learning techniques that provides the object and classification information of the objects that are detected. So both impact on the hardware and the software is there on the Tier 1 suppliers and also the SOC. The main goal of the Tier 1 suppliers is to develop a scalable hardware architecture and scalable software architecture to support the different levels of entries of the vehicle platform, whether coming from the entry level to the high-end level of the vehicle platforms.
Yeah, and I think just to add to that too, I think there's also sort of maybe not a struggle, but just an opportunity of the OEMs deciding what they have in-house versus what they give to the supply base as they develop these new complicated software systems, connected vehicle systems, and the over-the-air updates.
Yep.
So very good. I think you guys are stealing my thunder.
Yeah. So as a Tier 1 suppliers, we as a Tier 1, we have a bigger challenge. What SOC we had to select to satisfy all the needs of the OEM, whether it is a high-speed manual features or low-speed manual features like AB, ACC, which are considered to the high-speed manual features, and traffic jam assist, park assist also, automatic park assist, which many of the OEMs are asking for that. And it's a bigger challenge for us, and the too much pressure coming from the Tier 1 are again shifted to the semiconductor companies too on this part.
Yeah, so two key summaries actually. listening to what Christine, you said, and what Lakshmi, you also said. So one of the boldest statement that Christine, you just made is now OEMs are looking at more and more insourcing of the features and software. And
right, they're
Lakshmi,
starting to develop software organizations in-house. Yeah.
Absolutely. And we see that in big way, right? Bench, OS.R, we look at the Cariad and all of that. And Lakshmi, your point is also very interesting. And I think I'm going to come back to that point and expand on that a little bit more. Saying that automotive-centric compute is kind of lacking in a big way. And as a result, kind of this is prohibiting from OEMs to go and implement a horizontal software that can scale across the vehicle platform. So I think I'm going to move on to my next topic, and then somewhat related, right? So if I dial the clock back and look at what one of the statement that Enzo Ferrari made, he said that I'm in the business of making engines. And I just put the car around that because I want something to hold that, and I just give that to people for free. What essentially it means is for several decades, OEMs differentiated on the engine, and basically they linearly perfected it. And Christine, you are a perfect example of it, right? You drove that revolution. But because of this regulation push, now that differentiation is gone. I mean, as of 2022 itself, we are going to see 63 new EV launches that are going to happen this year. And as a result, OEMs are really trying to figure out what is going to be their next differentiation. So if you look at the first picture on the bottom, that's basically the hyperscreen image from the Mercedes-Benz. There are already big monolithic displays taking place in the automotive. So OEMs want to differentiate at the cabin level, also the exterior sensing and the user experience and connectivity. And in order to control that experience, they want to do the insourcing of software and electronics, as Christine was just mentioned. Now,
and that is a really good point, Abe, is then if the engine used to be the heart, what is that new heart then in this new system and world? I think that's a very good point.
Absolutely. And so that's the ambition. Now, if we look at what has happened in the last 2 years, the right side picture shows basically the number of MCUs being used. So basically, automotive industry evolved as a mechanical industry, and when electronics started making its way into the automotive, it grew without much thought. So like if you have to put telltale information and the drive information, let's put a cluster. Let's put the collection of meters and we'll put it there. If you have to figure out tire pressure monitoring, then let's put something and then put an MCU around that. If you have to do the body control, let's put an MCU around that. So these electronic functions started growing like a mushroom. And you can pretty much see that all these architectures are legacy architectures, and all these architectures point to top 3 players highlighted in the bottom. Now the challenge is, these are very, very old and proprietary architectures. So if you want to dual source, for example, if the Renaissance part is not available, which is a PowerPC architecture, and if you want to go to NXP, you cannot take your code base and port it to it. So in last year's problem, if you can see any car maker that made the car, but they could not ship it to end consumer, and the car was waiting in the lot, you can pretty much point to every single problem to these 3 suppliers and one of their MCU. So that's the problem, right? So architecture has to evolve in order for OEMs to control their user experience. And this is a question that I was going to ask Vishwanath, but he's not there. And I think, Christine, again, I will ask this question to you, and then I'm going to go to Ramesh. So There is one ambition that OEMs want to create a horizontal layer, and they want to control that user experience, or they are in search of that new heart, as you said. So how do you see vehicle architecture evolving, and how OEMs are going to maintain their differentiation?
Yeah, and that's a very good question. Like, as I was working earlier on Ford's Blueprint for Mobility and looking at the potential future of having autonomous on-demand transportation, you know, when you call like an Uber or a Lyft, you really pick a type, right? Like, I'm going to pick either economy, I want to have the extra large, the XL. I could easily see in the future that we have branding such as that, where you have your luxury offering, your economy, maybe your family, and that it really doesn't matter per se about the brand if we are not owning the cars themselves, and if we're leveraging more kind of autonomous on-demand transportations. So I think there's an interesting question about when is that going to really come into play? And as we electrify these vehicle platforms, where is that differentiation? And I think you're right, it is about that full experience. As I drove across the country, I can tell you that the Tesla experience that I had on the system, because Tesla's designing the vehicle and they're designing their charging as a system. And I did not have a single problem with my charging as I did the whole 3,300 miles. And also the in-vehicle software was fantastic. I had downloaded a lot of different apps on my phone, and I didn't even use it. I would just put in my destination each day into the computer in the car, and I followed exactly what it told me in terms of which supercharger stations to go, how long I would charge, and I had no issues. I saw a different story with the non-Tesla infrastructure, and I think it's a complexity when you have different OEMs. We don't really have consistent standards, and I think that that's something that really has to be done, because the system effect then of the OEMs, the EV OEMs, and the different products that they have working with the charging infrastructure honestly doesn't really lead to that full consumer experience that I had in the Tesla network and system. So maybe I'll pause there and let maybe some others chime in as well.
Very good point, Christine. And I'm going to ask a follow-up question, but let me invite Ramesh if he has any comment to make.
Yeah, as Christine mentioned, we are evolving from engine to electronics to software now, right? So the vehicle architecture is also evolving day by day. And today, let's take the case of some of these complex features that are being supported by the OEMs, right? For example, the AI and perception, the autonomous driving, even car as a service. Now you need to have you need to enable the users to actually program like a computer. Now the vehicle should be treated as a computer, where you need high performance compute platform, which is a centralized processing engine, wherein we develop more and more applications, and it should be very dynamic, because it is very hard to predict what a customer needs today, because it is kind of a very feature rich. Feature rich is the vehicle has turned out to be a very feature rich one. So the architecture need to evolve to support different applications and how easily and how scalable they are, and so that is what is going to determine this vehicle architecture change. So both from a hardware and a software perspective.
Yeah, absolutely. So, Christine, I'm going to kind of expand on where you stopped. I think the single biggest strategy decision that Tesla made several years ago is to use the LTE modem in their vehicles. And because it was electrified car, the architecture was much more simpler, right? Basically, the high voltage system on one side, low voltage system on one side,
Right.
a controller to control, and basically the low voltage function has two different kind of processor architecture, one to take care of the driving policy and the sensing that truly enabled basically the AI outside and inside as well. And same thing for infotainment. So as a result of it, as you were saying, that the car can really understand that what is the outside temperature, what is going to be battery health. It can continuously monitor the charge status and also the depletion of charge, and it can tell you whether you are going to, I mean, it's very interesting. 2 years ago, when I went to pick up my car, it started telling me that you need to go 65 miles an hour or below if you want to reach home without recharge.
I know,
So,
wasn't that brilliant? Yeah, that came up too in the race, and I thought that was very smart to let me know that.
yeah. So, so share your experience, right? Basically, what did you feel about the evolution of AI inside the cabin and outside the cabin as well?
You know, it's incredible because when I started way back 30 years ago in engine division, you know, the whole discussion of AI in the car did not even exist, right? It's incredible when you look at the last 10 years and the changes that have happened in that. So as we start getting to, you know, connected car and leveraging that data, I think it's going to be extremely important for really understanding these nuances in this new structure, such as electrified platforms. And where is the battery longevity? What are the effects of driving styles, temperature, usage patterns? And I think we're going to learn a lot more. So when you look at the whole AI and the connected vehicle, that is now ubiquitous, you know, and their different OEMs are in different stages of how well they're actually leveraging their connected vehicle data. I think Tesla has done a fantastic job with being the forefront of that, along with their over-the-air updates and managing that as a system to really get the information about the usage, the longevity, and that optimal battery life. So the AI side, when I look at how we better manage these systems in the future, I think the AI side can help us with optimizing, especially when you look at fleets, or if you're having, like, let's say, an autonomous on-demand robotaxi thing, or electrified fleets of transportation, such as, you know, UPS, FedEx, Amazon, that are shipping goods across country, that the AI and analytics really will help improve and optimize the routes specifically for EV, and looking at the charging, the driving styles, and what is actually needed then in terms of the energy that day, so that they can really better manage their fleets on an optimal basis, and even using those systems for charging, right? Maybe vehicle A needs a fast charge because it's going to be going immediately, and vehicle B doesn't need to leave for the next 5 hours and can have a different kilowatt level charge. So I think that the software, the AI, and those analytics and predictive analytics can really help us optimize then how we use electric vehicles in a very different way than with gasoline.
So interesting, right? Because traditional automakers still rely on making the connection to the external world through the telematics control unit. And Christine, why I say this, because if you look at BMW app, I mean, you and I have looked at it several times. When you try to lock the car, 9 out of 10 times it fails, and 10th time, if it locks, we just go there to physically check whether the car has locked itself or not.
Right.
And if I further that argument, I mean, when Tesla enabled the sensing cameras, they first enabled them in shadow mode. Only the front 50-degree field of view camera was enabled. Every other camera was driving in the shadow mode. And once they started collecting the data, they started enabling that. So that's the power of true AI in Tesla. On the other hand, as Lakshmi was saying, that if you look at a traditional car, it doesn't matter. It can be $30,000 car, can be $120,000 car. Front system is Mobileye, and there can be a DMS system inside. There are 2 or 3 providers. And both of these systems use computer vision, but they are traditional computer vision. So there is a big gap between what some of these new emerging players are doing versus what rest of the industry is doing. And of course, the rest of the industry is trying to go where Tesla is there. Like I can pick another example, which is GM. So GM has two classes of vehicle. All the entry and mid segment still use Mobileye, where it's a traditional computer vision. And then on the Super Cruise and Ultra Cruise, they have their own AI-based sensing systems. The challenge with that is basically you need to have two different platform development at software and hardware stack both. It's a big cost of development. You cannot use one platform and port it to the another. And basically the code of quality, the software quality code is really poor in this case. So let me start this with Lakshmi. Lakshmi, how do you see how some of the traditional OEMs are going to cross over and really going to use the power of AI to enable true exterior sensing? And then how are they going to connect it to interior sensing, or basically interior safety and user experience together for a well-rounded user experience for a driver and passengers? What's your thought on that?
Yeah, Ravi. Just now, currently, what are the conventional, traditional, as you said, the image processing algorithms? Now, most of the suppliers, tier 1 suppliers, are moving into the AI-based architecture platforms. One example I'll tell, which we have recently got some requests from the customers. So most of the tier 1 suppliers, when they develop these AI models, that, for example, you take for the exterior sensing, that's the front-looking camera. Most of these tier 1 suppliers currently, they are concentrating mostly on the developed countries like US, Europe, and everything, which they have certain environment and everything. But recently, one of the local OEM from India, you know that Mahindra has come with XUV Sam 00, where they have launched the Sam 00 with the capability of the feature of one vision and one radar capability solution on Indian scenarios. So I'm pretty much interested, okay, the traffic conditions of the global countries is different from the Indian countries, and how they take the data and how they satisfy all the Indian requirements, which is a big challenge for tier 1 suppliers to satisfy all the scenario conditions of the Indian road conditions. That is the biggest part, how they need to do the supervised learning, take the data from the different scenarios, train them, after bring the model into the finally train the model entire system based upon the Indian scenarios, and use that model for the classification object detection of the system for Indian scenarios. That's a big challenge for the tier 1 suppliers, and with respect to the exterior sensors for the AS using the deep learning techniques and everything. And that's what I see with respect to the because for each of these training these models, you require a lot of effort for the labeling of each of these objects in the Indian scenarios, and that increases the cost on the tier 1 suppliers too. Okay, so this is what I see it like a bigger challenge for tier 1 suppliers to handle most of the things as the suppliers are moving to the AI technology and supporting all the needs of the customer requirements.
Yeah, so I think, Lakshmi, to summarize, what you're saying is AI-based solution will be able to provide much more efficient and effective, cost-effective, and also feature-effective solution.
I can say it is I can't say it's a cost-effective, because more sometimes like to handle the difference. So let's suppose you see one scenario, it's satisfied, the model supports very well. But in some scenarios in which customer says that I found some issues with this scenario, but it is up to the supplier how you have to judge and whether you have to support those false cases or not. And it involves, if it is a false case for the end customer, okay, failing for certain scenarios, again, you have to train the entire model And that is a lot of effort also. It's cost-wise, it increases more, but it's an effective solution, I can say it.
Okay. Yeah, no, I think I agree with you. So one scenario that I came across talking to Mahindra a couple of years ago, India is very special, right? Very diverse country. For example, you go to Hyderabad, a young boy, Muslim boy probably, wearing white kurta pajama and also wearing white skull cap. There is not enough contrast for a conventional computer vision algorithm to detect that boy, no matter how many times that type of frame is available. And only way to do that is basically to have full or high confidence detection is by using CNN.
Yes.
So yeah, I think I'm fully on board. So let me just move on to another problem where left side of this, what I put is, if you look at the software development complexity inside the car, and if I baseline it to a digital instrument cluster, when I go from there to infotainment, it's 5x more complex in terms of implementing this in software and also in the number of resources required. And recently what automotive industry has been doing is it's moving towards the domain controller. Lakshmi, you mentioned that in the opening dialogue as well. One of the first adoption of the domain controller was in the cabin where, and Vistian championed this. So this was near and dear to my heart as well, where we put very powerful compute, put a class 1 hypervisor on top of that, and then that allowed 2 independent operating systems to run on it. Like, for example, cluster is a QNX domain, and infotainment, at least now, is Android domain. So that also allows inter-domain communication. However, the complexity goes 10x. And now if you go from there to level 3 ADAS, it goes 100x more. So that's one challenge. On the right side, if you look at compute required for sensing, I mean, for example, if you have 2 8-megapixel cameras running at 40 frames per second, then basically each one of those pixels are going to have 12-bit compended data. I'm not even talking about 20-bit data, the HDR data. And then you have the surround view cameras, and then you have mirror cameras, you have CMS cameras, fender cameras, and all of that camera configuration in the below. Then there are 2 challenges. Number one, transporting the data from the satellite cameras, as Lakshmi, you were talking about. And satellite cameras means only sensor is located in the camera head, no processing element. Raw data is transported through the serial link. Transporting that data itself is a big challenge. And we saw that, right? Mobileye came with the IQ5 3 years ago. And even with GMSL2 or FPD Link 3, there was not enough bandwidth available to transport that data. So the data transport is one challenge, and that adds to cost and weight of the vehicle. The second challenge is you need this massive central compute to process the data. And it's very interesting. I think, Christine, probably you remember this. About 4 years ago, I went to General Motors to see one of their electric cars. And there was a coolant leaking. And basically, I was like, this is an electric car. Why the coolant is leaking? And they said, yeah, because we need the coolant to cool down the compute. So that's a massive challenge. Now, that's where basically the problems are. In my opinion, where industry has to go is basically, it's already fragmented among 3 platforms, entry, mid, and high. Entry is basically a low cost passenger car where sensing systems will be dictated by the strong regulations. So for example, if you look at the Ford Focus type car, that will have 3 cameras, one looking in the front, 50-degree monocular field of view, one DMS camera looking at the distracted and drowsy driver, and the third one is the rear view camera. Each one of them will have sensing function, and 2 rear-looking corner radars for blind spot detection. And as you go from there to mid-end, basically rear view cameras will get replaced by surround view cameras, because that's where the differentiation is. There is going to be radar fusion, because OEMs can charge for highly advanced parking, so on and so forth. And as you keep moving, more and more sensing functions will get attached. So that's where industry is headed. And Ramesh, my question to you is, when industry is moving itself from the legacy manual drive architecture to basically highly automated driving architecture that can also scale across the vehicle platforms, does it make sense to consider the service-oriented architecture? And what are the ways basically that can hardware and software can be unified? And what are going to be the implication of it?
In your previous slide, it's good that you stopped the complexity at the L3 ADAS, right? When you get into L4 and L5, it is unimaginable number of the times that we have to look at in terms of the complexity. So as we know, in the past, like OEMs have been using a signal-oriented architecture, which is the classic AutoSAR, where the software components communicate over CAN or FlexRay, where like you have, we are talking about megabits per second kind of a bandwidth. But with AI and the autonomous driving, the enormous possibilities of very complex functions pose a major challenge to this kind of an architecture in terms of complexity, in terms of scalability, and the dynamic nature of adding new applications or enabling new applications for the consumer. So even AI, it is not even at any not at a matured state, and it keeps evolving over time and time, right? So one of the key aspects that's where that whole service-oriented architecture is very much needed to support the scalability part. And especially in this kind of an architecture where like you have a functional clusters which are all defined as software service components, where applications can access these components and dynamically or even during a runtime, and then they can actually enable more and more applications in as simple as a smartphone kind of scenarios. So definitely the service-oriented architecture, which has already been adopted by most of the OEMs, and I would say we need a hybrid kind of an architecture, because we cannot undermine the use of a classical AutoSAR, where like a lot of real-timeness is needed, and which is more secure when it compared to service-oriented architecture, where like even if it gives the ability to scale, again security concerns, I'm not sure what level it has been addressed today, because it can be dynamically accessed by the applications. Now, so I just split these two into two different one as a service oriented as well as the unification part, right? So when it comes into unification, so every OEM, as you have said in the earlier slide, OEMs have multiple brands, and in the past, every brand has been designed by a separate team for the hardware and software, and they work on silos, right? There is no reusability across different brands. So it actually, it is very inefficient way. And I think today that the OEMs have realized, and they started using very unified hardware and software architecture within the OEM brands. So I think you already mentioned about CARIAD. They have a scalable software platform by Volkswagen. So which is actually they invested into a separate company altogether. I think it has been So much of focus and effort and money has been spent to develop this kind of a platform, so which is very much needed in this today's AI world. So by having this unified architecture, definitely it will help in configurability and scalability. And before I conclude, I just wanted to add one more point regarding the optimization. That is where I kind of even thinking how a unified architecture will really address this kind of a challenge. Because if you really look at AI, which is again changing every now and then, and there are many semiconductor vendors, like the top tier 1 semiconductor to startups, have different types of different AI architectures, and everyone claims that that's their best AI architecture available, right? Now, the second issue is the AI software tool chain. And now, how do we integrate these AI software tool chain into these kind of vehicle architecture is a question that we need to address. Even at Dignitarium, we get a lot of customer queries to optimize or even develop custom neural networks, optimize the neural networks through pruning, quantization, and even optimize it to a particular hardware, right? If that kind of a challenge has already been faced by a customer, is there a way to have a very modularized way of optimizing it through this kind of an architecture is still challenging one. And I hope while this unified architecture is definitely needed, but addressing AI problems, you still need some bit of customization, and also how do we integrate this AI software tool chain into this one, because like today every AI accelerator company has a different tool chain today. So that is one of the things that I just wanted to highlight in this context.
Yeah, so Ramesh, there are three kind of compute problems in the car, right? And I specifically asked this question to you because I wanted to focus on the infrastructure software, which is like AutoZar of the world. And basically, so there is a compute needed to, so first of all, I 100% agree with you that there is a immense need to have a horizontal operating system or a software layer that can go across the vehicle lines, and that's missing today. And a lot of people are in search of this, whether that's going to work seamlessly or not. It's a massive undertaking, and basically different vehicle platform groups have different political powers. So basically their own internal organizations are the problem, including CARIAC. However, looking at the different compute need, basically the in-cabin needs are very different. Exterior sensing need is completely dictated by computer vision. And the vehicle level needs are dictated by the infrastructure. So do you see anytime soon all of these needs converging together, paving the way for true AI enablement, where basically the vehicle can become a massive compute platform, and vehicle can be driven by the computer? And that was the main reason why basically I stopped at the level 3.
Absolutely. I think today vehicle is considered as a data center on the wheels, right? So definitely you need a very high compute, as well as you need not only processing, like even the neural networks, when we look at it itself is evolving, and there are, today we are talking about supervised learning, and the next in another few years we start talking about unsupervised learning, right? So there is a lot of complexity is being there. So it will evolve over time. I still think there is a lot more way to go to get into a very stable multifunctional features getting implemented in the vehicle is what my view is.
Perfect. So let me just move to, anybody has any comment? Or
just adding to the point of Ramesh, what you said. So because we can't have a common model of the artificial neural network for all the features. every feature will behave. Let's suppose you take the traffic sign recognition and object detection and everything, or otherwise lane detection information. So the model has to be improved to support all these things. So it involves a lot of training mechanisms to supervise learning of the mechanisms to train all these models and finally come up with a proper model that suits for all these applications. That's a bigger challenge for the most of the tier 1 suppliers who are developing these kind of artificial based intelligence applications. So that is what my point here with respect to the AI systems. Having a common model for all the features, that's a very big challenge.
Excellent point.
So, Lakshmi, I don't know if I fully agree with you or not. My main point here is there is one way where basically you can run multi-class object detection. The other way is you can have multiple CNNs. Like, for example, if you are doing the lane detection, that same model doesn't need to do the multi-class object detection. You can, if the hardware allows you to do the context switching without losing the frame, that can be done as well, right? So there are different ways, and I don't know which way is going to win. It completely depends on basically the level of its cost benefit analysis, right? Any opinion you have on that?
So what we feel is how your model is trained against your ground truth reference. That is more point here, actually. And there are a lot of challenges. If the ground truth reference is not perfect, then your model will not be perfect, right?
Absolutely.
Yeah. So most of the times we face as a tier 1 suppliers when we train a new model, okay, now if you see the traffic sign recognition in entire frame, it will be having a certain region of interest, and lane information will having a certain region of interest, and object detection will have a certain region of interest in the entire one image frame. And fine-tuning all these things and everything, yeah, I agree to your point that you can have a multiple neural network models and everything, but our approach is to have a common model. It is very difficult. That's what I see it as a different way.
Just to
yeah.
May I add a bit? Yeah. So one point to
please.
add, so as AI is new to every market segment, it is like not only to automotive, right? It's everywhere. It is getting, the evolution is happening. So for example, you would have noticed there is a low code, no code platform available. Now, when there is a low code, no code platform, which there are certain places where it can work. That's what our experience has been. Let's say in a manufacturing scenario where you are detecting certain aspects where it can work. But if there is very dynamic video frame or image, this kind of platform is struggle to get the optimal result. So that is where this customization and customization comes in play. And as Lakshmi said, I still agree with Lakshmi's point that the one problem can be addressed using various types of neural networks. Now, even finding the best neural networks which suits a particular application, that itself is a complex problem. Because we have experience in solving some of the problem. We have to try close to around 15 odd networks, and then we figured out, okay, this network works for this particular condition under this lighting conditions, right? So that's the issue with all these imaging related problem statements to this one. So I just wanted to add this point. Yeah.
Absolutely. So I'm hoping that we have at least a minute to ask to see if somebody in the audience has one or two questions. Can we entertain that? And then basically I'll go to the panelists to just do a 10-second conclusion.
Actually, we have a lot of questions from the participants, Mr. Abhay, but unfortunately, due to paucity of time, we may not be able to take them. But I'll redirect those questions to you. Maybe we can address them individually at a later point. I would request the panelists to just give a conclusion.
Absolutely. So let's again go back to Christine. Thank you. Let's go back to Christine. Christine, what's the parting thought here from you?
You know, so I'm just really excited about how we're going to evolve this whole industry. And I think that there's just so much tremendous opportunity in this new space.
Very good. Thank you. Thank you, Christine. Lakshmi, please share your thought as well.
Thanks for this very interactive session and everything, Abhay. And I think it's a good experience for me to interact with the Christine and Ramesh, the experts. And thanks for that.
Absolutely. And Ramesh, finally, last but not least.
Thank you, Abhay, and again, IESA. So it is good to be part of OEM and be tier one. So it is a very interesting discussion. So hope, I really enjoyed that discussion, and I hope AI will evolve, and AI in automotive is a reality, and it is a long way to catch up.
Yeah. So automotive is a massive innovation platform, and I'm personally hoping that in our lifetime it's going to become a massive compute platform that impacts our life in a big way. So with that, I really appreciate all of you for being here, especially Christine, you and Ramesh for kind of burning your night. And Lakshmi, I have to be nice with you because you are my customer. So with that. Thanks to each one of you. And with that, I think I'm going to log off. Thank you, everybody.
Bye, everyone.
Thank you.
Thank you, everyone. Thank you, Abhay, for leading this panel. That was an amazing session on impact of AI on automotive session. We have amongst us a leader of edge computing with us, the next speaker, the keynote speaker, Mr. Dinakar Munagala. He is the CEO and co-founder of Blaze. Mr. Dinakar brings 23 plus years of experience onto the table. He has successfully built and led global teams, developed game-changing products rooted in silicon and software architectural innovations with recognition for technical excellence, new initiatives, and result focus. Focused on creating a more energy efficient computing architecture to meet the needs of a new generation of AI computing workloads, Dinakar leads the Blaze vision of delivering a transformational AI compute solution. The Blaze vision includes the democratization of AI via a combination of its novel processor architecture and easy-to-use software, empowering people and nations to tap the value of AI. Mr. Dinakar, sorry for keeping you waiting for such a long time. We are looking forward to listen to you.
No worries. Pleasure being here. Let me start by sharing my screen.
Yeah.
Are you able to see my screen?
Yes.
Okay, great. Hey, thanks for the opportunity, and it's great being here at the conference. I'm Dinakar Munagala, co-founder and CEO of Blaze. We are an edge AI computing company, and today I'm here to share some of our views about edge AI specifically, and how we see the market opportunity and some of the challenges, right, in realizing this in real production settings, making it reality, and how we at Blaze are doing some work to help the cause. With that, let me start off. So AI, as we know it, is massive, and it's come up initially deep in the data center, what we refer to as data center or centralized processing or the virtual world. So this was the first instance of AI, right, or AI 1.0, where largely, AI is all driven by more data, and data is the fuel for AI. So the obvious place to start was deep in the data center, where there was a lot of data and a lot of compute power. And this is where all the FANG companies, especially the Google, Facebook, etc., sitting on massive amounts of data troves, put this to use to realize the value of AI. They applied it to use cases like e-commerce, advertisement, and et cetera, et cetera. But to give you a sense, right, the centralized processing in the virtual world, roughly about 10 petabytes of data that is running, that's generated day on day, every day, roughly, in these Google, Facebook kind of companies collectively. So that's the size of data. Now, when we look at what AI can have as an impact to the society outside of the data center, that's even more. That's tremendous. That's huge. See, what you have here on the right side is real edge use cases in the physical world, be it healthcare, mobility, smart cities, education, agriculture, industrial automation, and so on and so forth. The amount of data that's being generated here is roughly about 70 zettabytes. It's roughly about 1 billion times larger. So 1 million times greater amount of data is being generated day in and day out. Hence, the opportunity to actually put all of this data to good use for these various industries is also that much more, right? So just to contrast it, the deep data center versus outside in the edge, we're talking about 1 million times greater data and hence the impact. And this part is just about beginning, right? There are a few use cases that are sort of early pioneers, be it like mobility, automotive, and so on, but or video analytics and so on. But really, it's coming to all of these use cases that you see on the right. Just to dumb down AI a little bit, right, and translate it to a simple example, how it's different than traditional computing. Many of you know this, but just to contrast it in a simple example, when one of my favorite cricketer and a living legend and one of the world's best batsmen, Virat Kohli, but when he started off as a kid, right, he probably went to a park and was playing cricket, and his parents or somebody were teaching him just throw the ball and just get the bat to hit the ball. That's it, right? So just make connect, make connect, hit the ball was the first instruction, and do it over and over and over repeatedly till he became good at it. Then they observed that he was good, and then they put him in a coaching school under a coach, and then there he learned more skills, right? How to hit better, correct better, maybe different strokes, right? Front foot, back foot, etc., and so forth. Then he went to start playing in tournaments where he learned, got more experience, right? Different types of bowlers and so on, different kinds of pitches. And then he started playing domestic and national and international, and learned more and more. So at every step, there was an element of learning, new things from his environment, and that helped him improve his skill. AI is very similar, right? It's all about the journey. It's not a one-time build a solution and deploy and forget. It's the opposite of that. It's rather you deploy a solution out in the field, and then there's a continuous learning mechanism as the solution learns more from its environment. That is fed back to improve the model, and that helps the solution become better. And this is for the lifetime of the project or the product, right? So the whole continuous feedback mechanism is a key aspect. And more data that's generated, the richer the model, the better the use case, and it's continuous. So it's very similar to Virat's journey. Now let's drill down a little bit into the kind of demands of the compute horsepower, right, that's required, or the software that's required for edge AI. A few decades ago, right, Apollo 11, the big the space craft that went to the moon, the guidance computer and the software on top, roughly we're talking about 145,000 lines of code, which at the time was big, and the chip, the guidance computer, was about a few thousands of transistors. Now just fast forward to a modern car, right? We're talking about level 3+ kind of autonomy. The complexity of the code, the software to run, the application demands it to be about 100 million lines of code, right? That level of complexity. And the compute horsepower required is billions of transistors. So a modern day car has that much compute horsepower requirement and code packed in it, probably 1 million times greater than what was in a space rocket just a few years ago. So that's the level of compute demand and the progress that is required. Fortunately, Moore's law from the chip world, etc., is making all of this possible. But also continuous improvement and different styles of architecture are required to solve the problem. Now, just to again bring this to a couple of real life examples, how AI is a journey and how it's used. One is a retail example. So what we have on the right side is a smart retail store where things like Amazon Go store where you do automated checkout. You just take a product and you walk out. Automatically your credit card is billed, right? If you go back and see how it's built, there are roughly about 3 phases. I've simplified the process. The very first one is data ops. It's all about getting really good photographs, images of fruit or a vegetable or a commodity, anything, right? And then applying AI techniques to learn, right? You're doing what they call model development, where you're applying it, learning what the object is. And then the next phase is actually deploying it in a real store. And as you deploy it to the store, based on different conditions, lighting conditions, this and that, anything that, either the recognition works or not, and you're trying to get that back, the full feedback loop, so that you improve the model, right? Hey, it's in this lighting condition, doesn't work, make it better, and so on and so forth, right? So that's roughly the 3 phases. And we're part of many such examples as a company as we engage with various customers. Another example, and this is to show how AI, when you actually simplify it, can help people who are not the technologists to begin with. For example, we're working with a doctor. He was an eye doctor and wanted to recognize and detect a rare condition in the retina. And he has massive amounts of data, right? 20,000 images and so on. But he wanted to do it on his own, to build a model, recognize this, and then create a simple application so that his staff in his office could actually use it, right? So again, the same 3 phases: the data phase, collecting all the images, applying a model, and then deploying it so that people can simply use it, and then any learnings that he gets from the field, feed it back. So these are the simple phases at a very high level, simplified it. But when you dig deep, it's really, really complex, right? Again, this is just an eye chart to break down the phases into more complexity, just to show that it is a complex problem, and therefore a solution that truly simplifies this whole journey is required for AI to actually happen in the edge, is what I was trying to get to. Now, in spite of all of these advances in computing and software, 87% of the AI projects roughly are not, they do not make it into production, right? They fail along the way for some reason. And the top few reasons are, firstly, data availability, good quality data and good quantity, right? Both of them. That's one of the first reasons. The second reason is the combination of explainability and bias. If you, for example, right, recently, this was a few, I think, years ago, like a couple of years ago, Apple started a credit card program, Apple and Goldman Sachs, and they had AI kind of predicting how much credit to give a person for the credit card, and somehow the algorithm automatically had some bias built in. So the founder of Apple, in fact, Steve Wozniak, he and his wife both applied for the cards. Steve got a different credit rating, and his wife got a different credit rating, a different amount of credit. So this was kind of unexplained, right? They didn't know why this happened. Although both are in the same household, they pay the same taxes, so they should have identical limits, but it appeared different. So the explainability is a key aspect, right? And because from that comes the trust. When you deploy an AI model into a real life setting, that you should be able to trust that it is going to do the right result, and that's a key blocker right now, or and why AI is not in some of the projects. The third one is the skill set. As you saw, right, there's AI coming to every walk of our life. That's the opportunity. But to actually make that a reality, you do need skilled team members to make it happen. Combination of data scientists, machine learning engineers, Here's an interesting article that I saw that in IIT, one of the professors wrote this, is that the IIT courses, they did an elective course on machine learning and deep learning. And these were as hot as Rajnikant movies, first day, first show tickets, just going off the shelves. So there's massive, there's learning that's happening at universities, but compared to the size of the demand, it's still small. And it takes several years by the time these students graduate and they actually are able to come to the point they're working in the industry and solving problems. So having, there needs to be a solution how to bridge the gap, right? The massive amount of opportunity to the available talent, and how do you make it actually, that's another reason why AI, some of the projects are not taking off in a big way. Now, jumping into, we contrasted sort of the physical world, but within the physical world now, the kind of edge computing that's needed, and through the examples that we've seen, is all about how an edge learns from its surroundings. What you have, prior to this is the notion of an edge computer, which is acting, sensing, and processing, but there's no learning element, right? Most of these are closed systems, limited connectivity. There's no ability to understand what's happening in surroundings and incorporate that to become a better computer. So the future of the modern AI edge computer that exists has this element addressed, right? It's about understanding your surroundings and knowing different data as it's produced, incorporating that to make the software model better. And that's the loop, and it incorporates the learning to make it better. As an example is a Tesla car. So there are about, I think, 2 to 3 million Tesla cars on the road, right? And as you know, Tesla is really like a smartphone on wheels, effectively. And as a driver is driving the car every day, it could be for different road conditions, different climate conditions, how the battery charge discharge is optimized, various aspects of the car. It's continuously monitoring this data and feeding it back to a Tesla cloud. And that learning is improving the car software. And overnight, there is an upgrade to the car. So the next day you wake up, your car has some aspects of the car improved because of a software upgrade, right? So this is all about the learning and then improving the actual, the edge, in this case, which is a car, it could be a camera, it could be a phone, but the same concept holds. So having this aspect is critical. So a little bit about some of the work that we're doing at Blaze, right? How to solve the problem for the physical world and bring real edge AI to life, right, into production settings. We firstly believe that it has to be a full stack solution. It's not just a chip or just a software, but having the combination of a really good processor architecture suitable for edge AI, a software too easy to use, and then a knowledge to enable different projects and use cases. And that is what is required to form a real physical world, decentralized, intelligent edge computer. So the technology stack that we built as well has these aspects. At the core processor level, we have an innovative processor that's very suitable for edge AI. And we stuck it in form factors like accelerator cards and so on, which can go into industrial PCs, into servers, behind cameras, and what have you, or chips inside cars. And then, in order to solve the software problem, to make it really easy, we have, of course, SDK, but also we have a no-code, low-code platform called AI Studio, which makes the entire life journey end-to-end, all the way from data to actually building the model, deploying it, and the ML ops, getting it into production, setting it, and improving it continuously, everything into a platform called AI Studio. And it's completely code-free, so that the doctor in that example could easily use his images to build an AI model and deploy it, right? And having on top of that a marketplace to have some pre-trained solutions. So if you're from a different field and you want a certain solution, you can start from somewhere, right? Somebody else's work, rather than starting from scratch. So to help improve, the overall time to build a solution and deploy it. So this is the full stack that we built, and what it enables is, if you see on the right side, there are various industries, right? Be it Industry 4.0, smart cities, agtech, mobility. Having first of all, having really good hardware out in the hands of customers and in the field improves within the cost, power, thermal, form factors. That's something, that's the big value that we bring. And then having this whole AI Studio platform, right from the concept, right, to having a connectivity to public marketplaces or private marketplaces, getting data and models for a certain solution, easily deploying it. And then as the solution is producing more data, having the whole production setting lifecycle management in a software platform so that you can understand that and influence your complete solution to be better is something that our software stack brings, right? So the end result is, for a customer, they're, of course, really good hardware and easy to use software. It brings down the time to realize an AI solution into their production setting all the way from a couple of years down to a few days, and that's the big time to market or time to solution advantage. So it reduces capex, it reduces opex, and also makes this whole AI journey very seamless and easy. So that's the big benefit that we bring. Talking a little bit about India, there's of course a large amount of AI projects that are happening in India. Government is very supportive and announced many initiatives. For example, healthcare, right? We're talking about everything from AI being applied to imaging, drug discovery, disease prediction, and so on. India is a massive country that has lots of data. So being able to use all of this data for people's benefit is something that could be really useful. Improving remote healthcare, right? Having assistive technology so that maybe a junior doctor in a tier 2 city can provide the care to the tier 2 city citizens, which is very similar to a super specialty doctor, right? Because he or she has an assistive tool is something obvious. And there are startups out there which are trying to make this happen. Smart cities, government announced about 99 smart cities, and everything ranging from better traffic control to energy, grid efficiency, smart lighting, identifying free parking spots. All of these are use cases that are identified that could potentially impact. AI plays a big role here. Agriculture, another key area. India, as we know it, is agriculture is pretty big. In India, it's the backbone of the country, and improving crop yield, limiting the yield, limiting pesticide use, and so on. All of these are big use cases that are possible. So just a couple of examples, and then I'll conclude. Is this is a smart city example, and this is actually happening in some parts of the world. So today, when you have like a traffic congestion, be it a small accident or whatnot, the traffic just backs up, right? And you just have to wait. What they are doing now is having intelligent cameras that are connected to the traffic signals, monitoring the traffic flow, everything. The moment any kind of congestion or an accident occurs, real time, and this is connected to all the other traffic lights in the city. First of all, of course, first responder services, right? Important, right? If there's an accident, call an ambulance or whatever. That is done. But also, how do you actually divert the traffic real time, right? Connected to other posts and saying, hey, there's an accident in this area, so let's divert the traffic to go through another area so that the congestion is relieved. And doing it, first of all, over a small area, then a wider area, and then a much wider area, so that overall the traffic congestion is relieved. and then having good notifications along the way saying, hey, there is an accident along the way, expect delays, take another route, whatever it is, right? So this is a use case that comes to life because of camera network and connected camera network across various traffic lights in the city. Another use case is smart agriculture. Again, in the context of India, hypothetically, let's say there's a weed that is identified somewhere in North India. A farmer could just take an image and there's an AI database that recognizes which pesticide to administer specifically for that weed, right? And that is given. And once that is solved, then sharing that, so they just do that and go and get on with their work. And this is shared across other farmers potentially across all of India, right? And then maybe even rest of the region. So the benefits are immense, right? Having something like this, and this productivity improves, crop yields improves, and so on. And these are a few examples, but really AI is massive, especially as it comes to the edge, and lots of use cases. Happy to address any questions, and if you have, we're in Hyderabad local, and there's anything that you're interested in, please drop us a note. Happy to work with you. Thank you.
That was really amazing, Mr. Dinakar. There's one question from the audience, though we are running short of time, but I would request you to take this question. What are the fastest growing areas for AI adoption at the edge? Non-auto based, please.
Oh, I was going to say automotive, because automotive is one of the fastest. Right. But in reality, there is, there are about a billion cameras shipping every year. And there's this push to make every camera more intelligent. So whether it's in a factory floor for worker safety, whether it's behind a smart city infrastructure, the one that I showed you, or video analytics in public safety and so on, right? Detecting that, hey, there's a person with a weapon or whatnot. These are all use cases. So camera analytics is probably the low-hanging and the number one use case that we're seeing as we engage with customers.
Thank you. Thank you for answering this question, and thank you for your time.
Thank you.
On behalf of IESA, I would like to thank you for your valuable suggestions and time, sir.
Thank you very much. Pleasure being here. Bye.
So now for a power-packed panel discussion on AI in healthcare diagnostics. So leading this panel is Mr. Varma Konala, and other participants, other panelists are Dr. Ambuj, Vice President of IKP Knowledge Park, Dr. J.V. Rao Garu, Director AIG Hospitals, and Geeta Manjunath, CEO of Niramai AI. I would like to introduce our chair, Mr. Varma Konala. He's an Intel veteran. He spent around 25 years in Intel. In the first 5 years, he was part of design, testing, and validation, followed by 20 years in all facets of marketing, that is tech, product, planning, ecosystem enabling, and business development. He is currently on deputation from Intel as the CEO of IoT and AI, the Applied AI Research Center at IIIT Hedge, which is a public-private collaborative effort between Intel, IIIT Hedge, PHFI, and the government of Telangana. So I would request Mr. Varma to lead this conversation. And
Thank you, Sridevi. We keep meeting virtually. I think we should meet for real one of these days.
Yeah, sure. We met last year, I guess, virtually.
Yes. Thank you, and good morning, everybody. So, there were a lot of panels and sessions right over the past 1.5 days on various domains, and here we're going to focus on AI in healthcare, right? Compared to other domains, right, the requirements are a lot higher here. If you take, say, a search algorithm, it can give you bad results. That's okay, you search again. If you take a recommendation algorithm, if it's recommending red shirt instead of orange shirt, that's fine, right? You can do it again. But in healthcare, right, you can't have mixed diagnosis or a false negative, right? So the bar is very high, right? So we'll look into where the state of things are, right? And I have three very accomplished panelists here. So let me quickly introduce them, then we'll get into the gist of it, right? To start with, Dr. Geeta Manjunath, she's the founder, CEO, and CTO of Niramai Health Analytics, and she's led the company to develop a breakthrough AI solution for detecting early-stage breast cancer in a non-invasive, radiation-free manner, right? She holds a PhD from IESA and a management education from Kellogg, Chicago. Welcome, Dr. Geeta.
Thank you very much. It's a pleasure to be on this forum.
Then we have Dr. GV Rao. He's the director of AIG Hospital here in Hyderabad, and he's also the chief of surgical gastroenterology, minimally invasive surgery, and transplantation services, and in charge of the surgical gastroenterology training program. He's trained over 100 surgeons in gastroenterology. So I guess he's a surgeon of surgeons, right? And there is a huge list of associations. I won't go through all these where he's a member. So welcome, Dr. Jiva. And then the third panelist we have is Dr. Ambuj. So he wears a lot of hats. I won't mention all the hats. So he's the senior vice president at IKP Knowledge Park. So he's also a clinician by training. And then after hands-on experience across multiple specialties, so he moved on to the management side and spent the next decade with the medtech industry. So he was at Johnson & Johnson and Medtronic. And at IKP, he currently leads multiple verticals, but the focus has been on the digital healthcare space. And lately, he's been focusing on the primary healthcare space, right? Applying the digital technologies in that space. Right? Welcome, Dr. Ambuj.
Thank you so much, Mama, and a very warm greeting to GV Rao, sir, and Dr. Geeta. I think we all, at least I'm connected to both of you through different means. So Niramai and IKP and Rao sir has always been there. I mean, right from J&J days. So yeah, pleasure to have both of you on the panel.
Nice to meet you.
So good. So folks, as you can see, right? I mean, all the three panelists, bring three different perspectives, right, to AI and healthcare, right? And we will start with the, the general opening comments on their views on, whether it's diagnosis, screening, or, specialist assist, right? And then we'll get to a little bit more specific topics that we have in our title, maybe reliability, liability, and explainability. So Dr. Geeta, if we can start with you.
Sure. Good morning, everyone. Again, as I mentioned, it's a very apt topic of trying to see how AI can be used in healthcare. As the previous speaker, or actually you yourself mentioned, the difference in using AI for other applications in healthcare is the criticality and the impact of error, right? When an AI application makes a decision. So personally, for me, I've been spending almost close to a decade on using AI for different healthcare problems. What I have seen in terms of the maturity of the AI algorithms, the data availability, is that definitely when we look at healthcare, there are multiple segments and categories in which AI can be used. One is generally the applications which improve the operation excellence in a hospital, right? Maybe getting the data right on time, correct data to be visible to the patients, doctors, all of that, and then trying to reduce the waiting times at different departments, getting the report on time, all of those sort of applications which improve the operational efficiency, which are pretty much similar to other AI applications in other domains. There's a second category, which is mainly when AI is used for clinical decision support systems, and that becomes pretty challenging, and we need to make sure that it is well regulated and well tested, and we have clinical studies and so on. Personally, again, at Niramai, we have developed this new method of detecting breast cancer, where the AI is actually analyzing not so used modality called thermal imaging, and converting and bringing up by a combination of thermal imaging and artificial intelligence, we have actually brought up a new way of detecting abnormalities in the body, is what I feel. And using AI is extremely critical because thermal imaging cannot be interpreted, with bare eyes and so on. It requires computational efficiency and computational models to do that. So in terms of the application piece, I feel for India particularly, AI can be a boon to both the urban and the rural ecosystem, right? In the rural ecosystem, we have severe shortage of doctors and experts availability there. And so an AI model for certain kind of critical diseases or certain common diseases as well can be developed to triage the patients, to bring people who need the care to the hospital. Whereas in the urban ecosystem, right, the doctors are really swamped with patients, because everybody is coming to the city because obviously very few experts in certain areas. And so in these cases, AI can be a tool to improve the productivity, reduce diagnostic errors, and overall scale up the solution both in urban and rural areas. So my sort of, pet statement, which I myself have created, is that AI can bridge the healthcare gap between urban and rural ecosystem and developing the developed world.
Thank you, Dr. Gita. Well, you've been at this for 10 years, so right. So you have to be right. You're pushing the barrier in there, right? So good. So Dr. Rao. So maybe then now, as a practitioner, and you can give us a view on how much you see adoption, right, in the various domains that you practice today.
Yeah, thank you so much, Verma. At the outset, let me thank all the panelists for having me here. As a clinician, as a surgeon practicing in urban city is totally different from a clinician practicing in a rural setup. We've been going through this artificial intelligence for more than a decade. Actually, everybody is fascinated by this artificial intelligence, and everybody wants this into their clinical practice, be it for operations, be it for clinical usage, or be it for telemedicine. Actually, these are the applications that everybody keeps talking about. I might sound a bit, it's this thing, but actually the biggest drawback that we have in our place, actually, all of us would like to have a Tesla in the operating room. You understand that is, everybody's fancy to have that, but the biggest drawback that we have is data. We have huge data, but the problem is in India, there are few centers who can upload your data, use the data, but still we are long away to use that huge data to translate into reality. We all want to go from subjective evidence-based management to an objective evidence-based management. We all would love to do that. But somehow, actually, I don't know, Ambuj will agree with me that, we have all the algorithms are written in India. The data is all from the West. Unfortunately, we need Indian data, Indian algorithms, and to upload this huge data. Everybody is doing bits and pieces in the thing and spending huge amount of money. And as the previous speaker has said, only 87% seem to be translating. Billions of dollars is being wasted because everybody is doing their bits and pieces in their own thing, and everybody wants to project their this thing. Ultimately, the translation is what is important. Actually, Ambuj is doing a great work there, actually trying to coordinate that and minimize this loss that we talk about, actually. But as long as centers, we are very far away from EMR. You take, in India, maybe about 50-60 centers maybe have this, actually, even though they are not practicing this. Now, where do we have this data, actually? You understand the data is the most important thing, unless and until the government comes in a way and then they're not able to do this on the public sector. Private sector, some centers are doing it. But whatever we have information as in today, we have bits and pieces, very fascinating thing. We are also involved in it. Actually, again, bits and pieces of the thing we're involved in. Indian Institute of Science, Indian Institute of Technology. And then we are doing our part of job, but I don't know whether this is going to generalize and then, what is I practice in my, we are phenotypically, genotypically totally different from the West. We cannot translate this entire thing, whatever data that you're getting, and then put it into the internet, time to dump it. Same thing happens for medication. Everything that is tested on the West is brought and dumped on India. Unfortunately, we are doing most of the work. Algorithms are written here. I know most of the algorithms are written here, but the data is not from our side. Unless and until we, redo the entire thing for the Indian data, it's going to be very complex.
You understand? I think litigations are going to come in unless and until we use this very diligently and very properly. I mean, that's my take on this actually. But we are very fascinated by this concept. I mean, just like I'm telling you, I want to have a Tesla in my operation theater, in my hospital. I want to have that actually. That's a very, I mean, very novel concept. But to upload data, nobody, I mean, as of today, I can tell you, there is no Indian data. Few centers are doing it, but that is absolutely insufficient.
Yeah. So Dr. Raghuram, thank you. Actually, at INI, that's one of the mandates we have. So, that's one of the problems we have where we need to have a really good Indian data set. We'll talk about that a little bit, right? So let me go to Dr. Ambuj. So now, we have Dr. Geeta from the solution side, right? And then, Dr. Rao from the consumer side, and then Dr. Ambuj wears both the hats. So Dr. Ambuj, on to you. Right?
Yeah, thank you. It's actually a privilege to be speaking by Dr. G.V. Rao sir's side. So yeah, so I mean that being said, I'll give whatever kind of insights I've derived over the last 20 years. So I was on the consumers. I was the one who was using deploying the medical devices and technologies, which I then went on to go on the commercial side. So I went on to selling them, then the marketing and then I went on to the R&D side where I was building them along with my team. So we had a team of 230 engineers at MAIC Medtronic, and we used to build stuff in country for country. And now I'm on the side where I'm looking at the overall ecosystem. So I can give you multiple perspectives. See, one of the things about AI, and this is something, which has come up, and because I have a background in neurosciences, so I keep on looking at intelligence with multiple hats. So intelligence is not simply the IQ, the intelligence quotient piece. There are a lot of other aspects of intelligence that we need to cater to. So there is emotional intelligence, there is social intelligence, there's a host of other sets of. When you look at natural intelligence or human intelligence solving problems anywhere, including healthcare, there is a component coming in from all of those different facets of intelligence. That's the first thing. And so therefore, when someone talks about NI or HI versus AI, you need to understand that AI still is solving only one bit of the entire set of processes that the human brain does. That's one limitation. I'm not saying that limitation can't be solved, but one needs to be cognizant of it. So you need to be humble about the applications of AI. The second piece is, the data that Rao sir was talking about, which is that, you get, see, data is everywhere. The human brain is so aligned to seeking out that data from different sources. That's one of the evolutionary developments that we've had over 3.8 billion years of evolution, right? And that's what we are a product of. So for example, right now, when I'm in this conference right now, I have my whiteboard by me. Now there were points that came in from Dr. Geeta. I'm noting them down. So I'm constantly, I have a bed of intelligence, whatever I've gained. Now I'm acquiring data from my co-panelists and from the other speakers. The previous speaker, it was an awesome discussion that you noted, and I was noting down points. I'm now going to process it based on certain rules. I'm going to get some insights, and then I'll deploy it. This is the entire span of intelligence. Now, and so therefore, I'm seeking intelligence and data from multiple sources. This is another upside of human intelligence over AI. AI, you need to feed in data. There will come a time when we'll have sensors which will do the same as what human brain is doing, but it will take time. And so therefore, with this background, now you need to understand that the entire concept of deploying AI or all these technology tools into healthcare will need to have a finite timeline. What we developed over 3.8 billion years of evolution cannot be constricted into 3.8 decades. And so therefore, once you have that thing in mind, now when we talk about what is the role of AI currently, it solves three things. Any technology intervenes in three phases. It assists, then it augments, then it automates. For AI, it's still in the assistive stage. And even there are still issues of adoption. I'll come to that adoption thing in just one line. What happens is when you have devices, and this because I am also, I love to study history. So I'm studying the history of technology. How does it work? We look at devices. It used to be typically the doctors who used to say, look, I've got a problem. Can you solve this for me? The pacemaker for Medtronic came like that. Dr. William Lillenhigh, cardiac surgeon, lost one of his patients because there was a power outage, said, can you give me a battery operated thing? And next we know Earl Barkin does it, and Medtronic is born. In software oblique hardware, at least in the software world, and specifically in the AI world, what's happening is that technology is racing ahead. So instead of doctor asking technology saying, hey, look, I've got this technology, can you find me applications? Now the doctor is saying, yeah, there could be applications, but then you got to work with me. And there are some awesome solutions entities out there which do that entire doctor, engineer, whatever, coming to matchmaking. A lot of solutions, that relationship is not strong enough. When you don't have a strong relationship, what happens is you've got these siloed insight from both sides. मैंने कुछ कहा जो तुमने नहीं सुना, तुमने कुछ सुना जो मैंने नहीं कहा. And what happens therefore is you get this half-baked product, which is very, very amenable to the principal investigator. The PI loves it. He or she was part of the, but the moment you get into the market, you hit a stall. Because the other people are saying, no, this is not solving our problem. And so therefore you have all these. So while you have promise, you also need to be cognizant of the limitations as of now. Will we surmount it? Time will tell, but I am an eternal optimist, it will. But you need to understand, unless these two disciplines start to converge and actually start working a lot more closely, we still are some distance away.
Thanks, Rambuj. We will get into a little bit detail, right? Maybe I'll pick up first on the data thread, right? I personally, like 2 years ago, when I was at Intel, trying to develop a AI marketplace, I interacted with most of the startups, mostly in India, but in, worldwide too, Singapore, Israel, UK, and all that. And all of them, especially India, had this. The single most important problem they had was proper data. We don't have proper data. We have to spend so much time, right? I mean, that's one aspect of it. The second aspect of it is even the data they have is Western data, right? As Dr. Akita was saying, especially if you take genomics right now, you see the available databases, 99% of it is Caucasian. I mean, how is it? I mean, especially genomics, how is it going to help Indian population, right? So maybe Dr. Akita, I think, you developed this solution over the past decade. Maybe you can relay your experience on what challenges you had on the data and how you had to overcome that.
Yeah, Nirama is 5 years old, but I agree, the challenges that, were very well brought out by both Dr. Rao and Dr. Ambuj. It also feels, I can recall the challenges that we faced on how we had to surmount. It really requires persistent efforts in order to solve these challenges if you really want to make it happen, right? So in that sense, yes, we started off 5.5 years ago with not much data on thermal imaging. Of course, the problem itself came in because I found very close people in my near family, dear ones, lose their life because of breast cancer. So then I decided, we'll try and do something in this area. And I didn't want to use the same data as in the same method which has been used for 30 years. Then obviously we cannot make any major change, such as mammography, which has limitations on women with dense breasts, and that's the reason why many people are also dying, right? So when we decided we are going to use a non-standard modality to start with, obviously we start with zero data, right? So that is thermal breast imaging. So I almost, first 1 year, obviously we were just collecting data. Obviously this collecting data has to happen through a very formal process. So we had set up clinical trial, clinical study protocols and, going through the ethics committee and, getting approvals and also putting in our own funds to actually get the data, right? With formal collaboration with hospitals. So every bit of data that we've collected and used so far for building the model has been collected by us explicitly by putting the processes for data collection and training people. Of course, there were a few doctors, especially actually only one in India and a few in the US, who had used thermal imaging for breast cancer. And so that data we used just to make sure that we are going the right direction, to see how the data looks and so on. But every data point that we have used now is collected by us. Yeah, so now we have almost 55,000 into 2.5 lakh, images.
Okay, I think you're probably here. I think because you had to do from scratch. I think you had to do what you had to do anyway, right? So you didn't have a choice.
But yeah, so maybe a point well taken. For other like standard kind of thing, for example, we worked on chest X-ray analysis, right? So there, as Dr. Rao said, most of the data that's available, was completely from NIH and NHS, basically US and UK data, and we built the model starting with that. And there is a process called transfer learning, right? If you have a new set of data, population or new data that you collect, you could actually make the model work on the newer population with some, whatever is the adjustments that are needed, can also be modeled, right? Because it's a different population distribution and so on. So then, yeah, of course, we had to use Indian data to do the further refinement of it. So there are techniques to do it, but definitely the hospitals and the doctors are extremely busy. They need to have kind of an openness to try out new things, and then allow the technologies to start experimenting without hurting the patients. And I think this research mindset is more I see in outside India than inside India. So that is also something that can change. And absolutely right, both technologists and doctors should come together to build this, AI models for healthcare, for sure.
Yeah, I mean, if I just have a question for Ambuj and also Verma.
Yeah,
see, we have actually, I'll give you an example. Actually, right now we have a thing called the Barrett's esophagus, which is recognized by some algorithms. Now, as in today, we have about 10 algorithms which are published from each different hospital or different thing. Each one claims a sensitivity anywhere ranging from one data says 80%, one data says 90%. Now, tomorrow it is like something like me going out to the market and trying to purchase either Maruti car or a Tesla car. Now, which algorithm do I buy? You understand? Ultimately, suppose my hospital has to buy some software. Which one do I buy? But I mean, you understand what I'm saying? Or I have to develop my own this thing. Or suppose, I mean, tomorrow it's like going to be a marketing gimmick from the artificial intelligence, the entire society, wherein they're trying to push, saying that, okay, you have artificial intelligence in the hospital, it's a marketing gimmick, like what we have for robotic surgery right now. So I'm slightly confused about this because, see, it's a great concept, but we're not trying to see how the whole thing can get integrated. For agriculture, seems to be the government is doing a huge thing. Yeah, they have a standard protocol. I think that is a great thing that is happening on the agricultural sector because government is involved into it. But here, so many private players are involved in it. Actually, I mean, because we have about 4 software. Everybody comes up and says, use this in your hospital for detection of this. So it becomes slightly complicated as in today. And I mean, see, especially if you have to answer to the patient population and the insurance coming in a big way, I tell them, this is this sensitivity, this is this sensitivity. I mean, you understand? There are a lot of loopholes which need to be planned before we can introduce this into Edison.
Thank you, doctor. I mean, Ambuj, maybe, so, I mean, you've been at J&J Medtronic where you guys were doing devices certified and set. But now you have these algorithms. Okay, FDA is certifying some. CDSCO has a mandate. But first of all, what is good? 80%, 90%, 99%, right? And who makes the determination? And then the algorithm will keep evolving. I mean, this is a complex challenge, isn't it?
Yeah, this is a complex challenge, and the way it works is, and at IKP we are trying to solve it by actually setting up. And this is what we are in the right now. We are in the thought. We're going to brainstorm in next week. We want to actually look at some sort of certification labs of sort to be able to do this. But here's a larger question, and not the larger point, meta point, so to say. Reliability. So I started my career off as a clinician. Now I'm half an engineer. So I talk in mathematics. So reliability is reliability is equal to AX plus BY plus CZ. Okay, where the A, B, and C are So A is from the people side, which is represented by knowledge. Okay, how much knowledge they have, the people who are building that, how much knowledge they have. B is the product. What is that product? What are its performance features, and what is the safety parameters that the product brings in? And C would be the system that is certifying it, the integrity, the credibility of the system. Okay. Now the AX plus BY plus CZ will then tell you how reliable this design is. So for example, there was this So no name. I keep on evaluating startups day in and day out. So there are too many of them. But there was this they were working on cardiac. They were working on cardiac diagnostics. They said, sir, we have an AI algorithm to detect 21 disease conditions, 21 cardiac conditions. I said, awesome. Patient data set kya hai? 1,000, sir. With 1,000 data set. You know what? They secured awesome funding, by the way. Okay. So now what is happening is you have people with this kind of knowledge, but a system which is also not able to evaluate. And now you have a compounded problem. I talked to my friend and one of my colleagues, ex-colleagues in Mayo Clinic. They're building something, they're building a platform for AF, just atrial fibrillation, 1 million patient data points. So who will you trust, this system or Mayo? So now you know. So therefore, knowledge, when you want to evaluate, so if server saying, there are these 8 different people, you will just evaluate on 3 parts. People, who are the people who are building it? What kind of knowledge they carry? What kind of teams they have? What depth and rigor of knowledge do they have? B, how safe is the product and what kind of performance features is it claiming? And C, who has certified system integrity? And once you get those 3 things in place, I will not go to what is that exact value. I'll leave that to each one of you, but that's where the equation is. I hope that kind of at least answers some part of it.
Well, I'll go to Dr. Geeta on that. I won't ask her the exact value, but maybe she can tell us where she had to get her system before, clinicians start adopting, right? And where they are at with their solution today. Right?
Yeah, I think very well put up, the actually AX plus BX, BY plus CZ you mentioned, Dr. Ambuj. I think absolutely right. All the 3 things have to be, for example, of course, I have a PhD in AI. I solved, hundreds of AI projects, not just in healthcare and others. And I used to head AI research lab for Xerox. Having said that, when I started breast cancer, and last 6 years, any book I read is about breast cancer, trying to read, all the oncology books, medical. I attend so many of the cancer conferences just to sort of understand things that I don't know. Obviously, many things. First year, I was just noting down unknown words and Googling, and then going back to my doctor friends and partners to sort of, So now I'm reasonably able to converse with oncology. So I think the knowledge about the domain is absolutely critical. Well said. The model performance testing is super critical. So what we did was initially, of course, you will see, okay, 5 years, how many installations? First 3 to 4 years, we didn't even sell any. The solution was not sold to anybody, obviously, right? Though, of course, it is definitely much better than hand examination. That is the standard for breast cancer screening today, But yeah, so that was a starting point. Definitely, can it be better? So if there is a symptom, please take them to a hospital. But if they're not, use our tool. And if we say there is a problem, take them to a hospital. So without hurting the patient, by enabling additional methodology for early detection, we actually helped many people, and that initial positioning was definitely accepted in the first few installations. We were working with Karnataka Cancer Society to screen a large number of patients, mostly from rural and urban poor and so on. And then in the same positioning, obviously, if mammography is already being done, comparing and collecting data of what the thermal imaging output gives versus mammo, ultrasound, and biopsy output. So more in a clinical research setting to build the models and label the model with, we have in training, you need to have every data and then the class label, right? So the class label coming in from diagnostic, which is like really the ground truth of cancer or not. So we had to spend quite some time in ensuring it is really the golden ground truth and not if mammography said no, we didn't take the label as no, because what we were attempting to do is to build a complementary modality or supplementary modality to mammo, which is able to detect things which mammo was missing so far. So that for that reason, we had to do multiple tests for on patients who are coming in and label our data set with biopsy, which is the most superior way of creating ground truth whenever possible. Obviously, if she's positive, only this possible. So that is one other second part. Third part is really working with reputed, doctors and organizations. For example, I think I just named Dr. Sudhakar sir, who is the breast imaging expert, who is and the top in HCG Bangalore. He's fully specialized in breast imaging. Initially, when I went to say that we would like to try this out, and said, yeah, I mean, this is not in practice. I don't know if it will work, but I'm okay if you want to. I'm okay to sort of participate in this research. I really thank him for being open about it. Obviously, you're not harming any patient because it's a non-invasive, just measuring temperature from 3 feet. And then I'm not going to give your diagnosis to the end users. That is just going to be like in yours. So I'm not harming the patient as well. So obviously, with patient consent and ethics committee approval, we set it up. Now, after 5 years, he's very much now regular consultant to Niramai. He has done 3,000, 4,000 scans with this, and he's super convinced. We have published together and also individually almost 11 international publications with peer reviewed, and that's a very, very important thing, right? Who said it is 8? I know Dr. Rao sir was saying, right? Somebody said 80%, some 88% sensitivity. That's fine. So when you do the testing in a lab, we may get different answer. But doing it in a prospective setting where it's almost like a final examination, we put the machine, we train somebody, and we come out. And every person who is coming for mammography, before doing mammo, they were taking our test and then going for standard of care. And at the end of the trial, you compare the two. And we are not comparing. There is a third party CRO organization who does this data management. And if you have such a very clear protocol for evaluation, once the results are out, those results can be, need to be reviewed, peer reviewed by, by really experts. So we took the option of only publishing in international journals because we didn't want to say Indian innovation, Indian journal. So we actually published in ASCO, American Society of Clinical Oncology, which is one of the top platforms of oncology research, and RSNA and things like that, where, so all of these, getting it published in a very top journal means obviously there is authenticity to the data. And finally, and last but not the least, definitely, we also went to regulatory bodies. So of course we got the Indian regulatory clearance, otherwise we couldn't do many things, but we also got a European CE mark, as well as recently US FDA as well for one of our devices. So with this, I feel doctors, we are already seeing many doctors very confident about using our solution, providing it both in India and abroad as well. Obviously, when I go to US or Europe, they say do it on my patient because most of the data is Indian patient, unlike other cases. And so they say, why don't you, test it out and on a study on European patients and US patients, and that we are doing. So, so the bottom line is proving clinical efficacy in a scientific, systematic way is absolutely critical. With a third party, validating it is important because everybody loves their own product. So we don't want to have any error in output.
Absolutely. So I mean, Dr. Ambo earlier was saying assist, augment, and automate, right? I think it obviously plus the assist. So in terms of augment and automate, I think, are you at the stage where clinicians are ready to use it as sort of a primary diagnosis tool?
Oh, Niramai test, yeah, it is now installed and available in more than 120 locations of hospitals and diagnostic centers in 25 cities in India as well as Africa. We have commercially available. There are many centers who are providing only this as a part of their health screening. And if the person is positive, she is actually sent out to positive in thermalytics. She's sent out to a diagnostic workup, which would be ultrasound followed by biopsy.
Okay, then let me go to two other topics, right? We had liability as one of the thing. So the question is, I mean, in terms of, this is about again how the doctor is using technology, right? This is yet another technology for the doctor. I don't think we're at any stage where, right, this is replacing the doctor or anything like that. In fact, a lot of times we say AI, I mean, doctors using AI will replace doctors not using AI, right? Just like in any other thing, right? So you think there is any liability issue right now that is hindering adoption?
for me only.
Yeah. Even take your device, right? Was there any liability question at all in terms of adopting?
Yeah, so we work with lawyers, and obviously any report has a disclaimer at the, even if you take a mammography report given by the doctor, there is a disclaimer, right? Clinical correlation recommended and all that. And our report, basically, yes, the interpreted output quantifiable report goes to a doctor for, we have a panel of doctors who will certify and then put in their signature on that as well for diagnostic usage. For triage, it is basically, like I said, hand examination is the default. So there it's an automated triage output that is given. But yes, so we need to have the disclaimers, and we need to, the report can only be given with doctor signatures.
Congratulations, actually, Dr. Geeta, for that excellent work that you've been doing. Actually, we at our center also started some of these trials on pharmacogenomics, and then some of these testing on inflammatory bowel disease and some. So we are working on a couple of these things. Actually, we hope that this gets translated. Congratulations to the beautiful work. As rightly said, the reliability is still going to be there because still, I mean, so far we have not had any litigations that are filed in the court or the consumer forum about this as in today, because as rightly said, because basically we're not totally dependent on that. We're just using this as an aid, as Ambuj has already said, told you, I think, but we just have to wait and see whether anybody is going to file a litigation.
Yeah. So what will happen, and so I'll give you a little meta level answer on the history of tech. So what is liability? Liability basically in principle is about accountability, but there is an angle of penal action associated with it, which is that, you know, if you're doing a job, that's something you're supposed to do. If you're not, then there is a watch or a monitoring over you. And if it harms, or even if there's a potential to harm, there is a penal action associated, which basically increases the rigor for the tech developer to be able to put that. Now, we had this unfortunate event. There was an aircraft crash. You know, I think it was Boeing or Airbus, I don't remember which, but just a couple of years back. The plane stalled midair, and it was because there was a software glitch, that just one software glitch that actually did not let the aircraft respond with the adequate angle at that specific, and it stalled, went midair, lost its thrust drag ratio, fell down. There was a big brouhaha, and I was trying to follow that because I wanted to understand who is going to be liable for this software glitch. And at the end of the day, it came down to some Indian company out here, some specific vendor out here, and they zeroed it down, and then the matter went under the carpet. Liability is going to become a very big issue as AI starts to progress further from the assist to augment to automate state. As long as it is in the assist stage, the liability will still lie with the clinician, because then in that case the tool is claiming legally that we are a decision support mechanism, we are a decision support system. That final call still is the doctor's call. Right? As it starts to move into the augmentative state, where it is now enhancing the capabilities of the doctor to actually, now here this is the gray zone. This is the gray zone where the liabilities, we've started to get this kind of issue within, say, robotics, for example, where we are run out. Is it the surgeon's mistake, or is it the robotic arm? And there were some unsavory incidents that happened a couple of years back with one of the key manufacturers out there. The moment it goes into automotive, the liability rests with the tech developer. So when you're at assist, it's a doctor. At the automotive stage, the tech developer. It's this augmentative stage, where you will start to have, and there is going to be a lot of mix and match happening. And as we know, when you look at policies, depends on who's lobbying stronger.
Just, Geeta, I just wanted to have one hypothetical question. Suppose in your machine, just a hypothetical question, because this is what happens in my clinical. AI says it's a malignant lesion. You take it out. The pathologist says it's a benign lesion. You understand? But ultimately, the patient progresses for malignancy in it. See, these are the things that happen. Now the problem, has anything like this happened in your clinical listing? I mean, just because these are things that are likely to happen, because
Absolutely. So basically, one of the things that we do is we optimize on sensitivity. That is, we do not want to miss any cancer. We actually, our publication in ASCO JCO, Journal of Clinical Oncology, with a formal clinical study says we have 100% sensitivity with about 8% false positive rate. So what can happen is, yes, thermalytics will say yes, but it could be an abscess. I'm saying the false positive part. Of course, if it could be malignant. I know that's the reason why we are in this business, but it can also be an abscess or sometimes an atypical fibroadenoma. If these two are the case, so that is the reason why we never recommend the intended use is not that after thermalytics go and do a biopsy. No, that is not. So there is an ultrasound which is done afterwards. So the good news is that because the tool automatically generates the annotations on the breast, saying whether it's in the upper inner quadrant, 10 o'clock position, whatever, the exact position, and the marking is done on the images. Now the ultrasound can focus on the marking, the lesion, expected lesion rather. So if the ultrasound is negative, we do not force them to do an ultrasound, biopsy, in current case. But we put her on a high risk mode so that she can repeat the test in about 6 months too. And basically it's about detecting early stage breast cancer rather than waiting for a third and fourth stage where it can be 10% survival rate when you look at 5-year survival versus 90% survival if you can do a stage 1, right? So definitely it helps so many people detect cancer which they would have missed. Just I think it was last Friday in Chennai. I won't mention which hospital. They actually became our partner just a few months ago. And they were doing regular health checkup. It's now thermalytics is part of their regular health checkup. So on Women's Day, I guess, yeah. So they came in, a few days before Women's Day. The lady came in, she's 51-year-old. She took the test and with thermalytics said BIRAD 4, like it is basically cancerous or likely to be malignant. And she went for ultrasound. It was confirmed malignancy, right? And then obviously they are trying to solve that. She actually had a small lump also. It's a symptom, but this woman had never mentioned about her lump also to anybody. So I'm saying this is already symptomatic. They didn't now, but when you actually do a technical test like this, right? It catches. I mean, for us, you don't need any complaint, anything. We just look at the imaging, figure out what is the physiological condition, where is a higher thermal activity happening, and then it gives the report. Now, it is also possible that the ultrasound will be negative, but still, we have made sure that something looking abnormal is tested once. So this kind of a gate is something that we are putting to ensure that there is no additional risk involved to the end user.
Okay, good. Well, we started a little bit late, so I don't know how much more time we have, but I have one more thing, and I think we'll talk about it and maybe we'll wrap up. I hear a lot of conversations nowadays on explainability, especially in the context of the healthcare. My search algorithm, like I said, my recommendation algorithm, who cares how it works, right? But when a clinician wants to use an algorithm, it can't be a black box, right? You got to explain, right? So if you of all three can give your views on that, right? Start with Dr. Geeta.
Okay. So I just gave a full 1-hour talk on explainability and how in healthcare it's important, how we are doing in cancer last week. In a forum with ICMR. So I didn't realize it was explainability. So we went and showed to the doctor, sir, she looks to be malignant and please do some follow-up tests. Tell me why, right? So that was the initial question. Then we said, okay, couple of things. Of course, we generate scores and the score gives the probability. That is when we started working on marking the lesion. So once you mark the lesion, they are able to make an action of, we are explaining that there is some abnormality here, they can take action. Second, we also have additional classifiers to see whether it is abnormality is because of vascularity, abnormality is because of thermal signature, abnormality is because of ductal issue. So we have different classifiers. We try to explain the answer, why somebody is likely to be positive, right? I think in medical imaging, particularly, though, of course, the explainability in healthcare in general is still under research. In medical imaging, annotation of the image is a very, very important part of the explainability process, explainable outcome, right? And if the doctor says, no, in this position, I did not find, then the feedback of the doctor can also go in to have a better model next time. So I think, and also we have some scores, for example, I can go on and on, but maybe I'll just keep it for 1 second. So you can use deep learning and it gives like really non-understandable or whatever numbers like 0.0007. What is that? Like even as a technical person, I won't know what it is because these are learned features. So we innovated there as well, right? Several things we have done. We have 26 granted patents. I mean, all of them do many things. Like one of them is basically how do we take these non-explainable numbers in deep learning features and convert into a 1 to 10 scale. So the doctor can know that 9 means high, 1 means low, right? So this kind of a scaling for different features also was very helpful. But it's a very important problem still under research. It's extremely domain specific and application specific output.
Exactly. There is so much role for context building out here. And so while Dr. Geeta is talking on the quantitative side, so she was talking about, let me give you a flavor of qualitative side. So when a doctor takes a decision, it is not just based on the theoretical knowledge or the clinic-based knowledge. There is a lot of intuitive understanding, and it grows with age and experience, right? There are doctors, even when we were in residency, after 2 to 3 years of constant working in the wards, and you start to get a sense, yaar, ICU mein ye patient jayega. You start to get that sense, right? There is an intuitive understanding that happens. So I was at Symbiosis about 2 weeks back. I was giving a talk, and one of them said, "Sir, AI doctors, AI is doing everything right. They are taking all they process faster. Why are they not able to beat the doctors at it?" I said, because 70%, and just cooking up this number, I'm just trying to, but 70% of a doctor's decisions are subconscious. Only 30% are on values. I mean, in my surgery teacher, Dr. M. Bapai, BJ Pune, he used to say, don't treat the values, treat the patient. Now, when the meaning of that statement is there are so many intangible markers around the patient that subconscious, and that is also part of learning. Unless AI reaches that level where it is able to catch those subconscious criteria and parameters from a doctor, it will not be able to reach that level. Now, why is it not? Because every good surgeon cannot be a good trainer for an AI tool. Being a good surgeon is a very application based. There's a lot of skills based thing involved. But there are surgeons who are very good at operating. You ask them to explain, and they will not be able to. And then there are people like, say, for example, Dr. G.V. Roy, he wears multiple hats. So I've seen him in innovation. I've seen him talking, and then I've also seen him practice. You need to have that entire wider spectrum of activity to be able to share that insight with an engineer on the other side. And then the richer that surgeon's intuitive and explaining capacity is, the better the platform will be. That's where I think we'll have to move next.
Thanks so much. Well, I guess you're saying we need to clone Dr. G.V. Rao and maybe Dr. Ragisha Reddy Gari also, right? So we'll get there, right? So Rao Garu, I think you can have the last word, and then we'll wrap this up, right?
All I want is actually, I hope Ambuj translates this entire thing in his kingdom, what is built up right now. I'm just waiting for Ambuj to translate whatever Geeta has been doing. And whatever,
yeah, I mean, yeah, it is something where we actually need lots of stakeholders around. But yeah, I mean, I'm sure I'm an eternal optimist. We'll get there, sir.
We need Ambuj cloning a kit. So somebody has to clone multiple Ambuj to translate this thing.
Okay, thank you, everybody. Sridevi, I guess we need to wrap up, right? So any time to take any questions? Any questions from audience?
We have few questions, but we will share those questions to you, Varma Garu, due to the paucity of time. Thank you so much, panelists, Dr. Geeta, Dr. G.V. Rao, Dr. Ambuj, and Varma for leading this panel. Thank you so much. It was very informative.
We can go on, but I guess we'll have to stop. So thanks a lot.
Thank you.
Yeah.
Thank you.
So once again, we are back with our startup showcase, and we have an amazing startup founder amongst us. That is the founder and CEO of TensorGo Technologies, Mr. Srini Chilkuri. Srini is a serial entrepreneur and an expert in cognitive innovations and emerging technologies with extensive experience in developing cutting-edge products for leading global organizations like Verizon Wireless, Orange SA, NASA, and others. Before starting TensorGo, Srini was the founder and MD of FlexAI and Hypercat, which built the first IoT standards recognized by BSI. Srini is also the producer of some of the top best-selling games in the world, such as Mortal Kombat and Xbox Kinect games like Dance Central and Joyride. So welcome, Srini. Srini Chilkuri, are you there? Can you turn on your video, please? And audio. Hi, Srini.
Hi, Sridevi. Yes.
So thank you for sparing some time today and being with us on behalf of IESA. I would like to thank you, and the floor is all yours now, please. We're looking forward to know more about TensorGo.
Thank you, Sridevi. Just give a minute.
Yep.
Hope you can see my screen.
Yes, we can.
Well, excellent. So, so thank you for providing this opportunity to tell about TensorGo, what exactly we're doing and how we are actually disrupting market for it. So, as you know, the computer vision is actually disrupting the AI market as we see it. Okay. Until now, the computers were able to can work on the audio part of it, on the text, but actually the video is something that's actually going to change the way as we live in. Just imagine that the human is not really having a kind of vision to see anything else. So what happens is, like, you can now see what's the color is that, how far is that, what shape is an object, or any of those things. So now, as we see that, there are kind of a lot of use cases where people are working on, the vehicle and model detection to the license plate recognitions, the emotions, face alignment, scene parsing, and many things. Okay, the videos are increasing across the globe, and so as the inferencing and bring the results is actually are also kind of increasing about it. The most big, the problem that you see, the challenges that you see across the companies is that in terms of actually solving this computer vision widely at an enterprise grade level is in terms of the people, the infrastructure and the data sets, the availability of the right skill developer people is going to be very expensive, and the infrastructure is all has to be running on the GPUs, and the data sets is not so easy to be available either. It takes months and years to develop and actually bring it to an enterprise grade level as well. The testing and maintenance of this is going to be very expensive as well, and so as a custom neural networks, which requires a very predefined kind of a skill set of it. So what we are doing at TensorGo is that we have a kind of a low-code platform for the developers to integrate, the APIs, which are about like within less than 20 lines of code into your applications, and build these AI or deep learning kind of applications. So imagine that there are different buckets, the objects, the faces, motions, emotions kind of thing, which are having a different kind of a models in plate. And these are continuously served at a speed and a scale over an enterprise grade platform. And somebody can mix and match these APIs and build the healthcare monitoring kind of an application, or a driver and distraction kind of an application part of it. So the way our platform works is that we integrate a kind of various frameworks, the layers, building our configuration, it tends to go as a platform. And with the configuration layer, we expose our APIs, whether it's the computer vision, NLP, whether it's going to be anything that's related to the AR, VR, or any of the services in it. And now it allows the developers to directly integrate to the presentation layer. Either you can actually use this kind of a raw data and build your data visualizations and have it up, or you can save everything else in your data layers that you may have it up. So that's how we actually make the things much more easier. Now, let me give an example of something. So somebody wants to build a kind of an emotions kind of APIs and applications to integrate it with any of them, right? So we're talking about a 50 billion market value by 2024. So now I'll give you a kind of a science behind this, okay? This is a brain that you see it, on screen here. There are two components that we're going to focus on. One is hypothalamus and the one is motor cortex. So this facial nerve that's actually coming over, it actually splits across the face, which provides micro nerves, which is enabling for the micro expressions. And anything that you see or anything that you actually get an impression of those things is actually stored in the hypothalamus. You override that is with the motor cortex. So we developed an algorithm that can actually understand these micro expressions and understand the hypothalamus activity of it, and provide the various kind of physiological parameters which is related to the heart rate, respiration rate, or the blood pressure or anything else, just from a normal camera itself. I'm going to show you this kind of a demo that we actually built using our state-of-the-art neural networks. So this is one of the guys that's actually sitting before the camera. Shows the person's ethnicity, the demographic profile about it. He's actually doing kind of a little bit of exercise, comes back on those things. You will see his heart rate is actually bumping up a bit in a few minutes. So 97 and 98, we're actually validating what with the oximeter. And it's 102, that's when it's going through it. And then a different kind of various emotions and the movement of the head. How is it, the direction of those things, we're doing that, right? So this is one of the examples that we put across. But now how this can be implemented, right? So now this we are able to implement on an edge device for a device distraction. The lady out here is actually driving the vehicle, and you can see the emotions of the person, the head pose of the person, where you can see the yaw and like which direction the lady is looking at it. When she's looking at down, this is getting the yaw, and this thing, the paw is going down. And the distraction, you can see the light here that actually shows the distraction. We're feeling the drowsiness, we identify drowsiness too. So all of these are different kind of an APIs which will be integrated to building an application. Where, for example, there is an automobile companies there that would like to integrate this kind of features. They don't have to really have a kind of a huge deep learning team doing the research and working on it as a differently working on it. So we can actually, can provide the APIs where they can use and build an application. So now the lady is using a mobile phone. You can see that this mobile phone has been highlighted. There's a kind of warning that's coming through it, along with the heart rate. So now this goes in extension of not only a basic emotions, but we can actually go in terms of identifying whether the person is confused, how cheerful the person is, whether joyful or not, how confident the person is to a lot more. So now there's a very interesting use case that we actually work for one of our customers is in terms of identifying the deception. They would like to can implement an AI technology in terms of understanding whether the person is lying or not over an investigation process. And what we did is that we actually can build an algorithm that can actually act on the facial features and also how the speaking, and also do some kind of a deep learning analysis of those things, and then actually provide a kind of a linguistic marker relationship with an analysis in terms of identifying the person is a deceptive or not. And our algorithm works over at a percentage of 85% of accuracy as compared to polygraph. So you don't require any kind of a hardware in it, but you can just come before a camera and the subject is being investigated. You can always say that the person is deceptive or not. And this is one of a great innovation that we carried out, and it's actually almost in the production stage for one of our customers. So we are beating up the averages of computer vision to the next level of it. This is one of those things that we work for one of the customers in terms of actually they would like to know the examination monitoring. If you see the last guy that's sitting at here is actually providing the gestures. I can like what is the answer for 2, 3, 4 kind of fun, and people are actually picking to either directions on those things. There's an exchange of paper that happens. You can identify it. If there's an investigator that's coming in, sitting there or standing there for a little while, then the invigilator is also been identified with it. So we can actually provide the alerts who is doing what activity or in real time on an edge device as well too, and multiple things. So this is another use case that we're. So what I'm saying is like there could be a multiple number of use cases, but actually could be one platform that can provide you a different kind of an APIs, which our customer network can grow and scale at enterprise grade level. This is another use case that we work for one of the customers where we will identify the brands, how many times the brand impressions are actually shown or a match. So now we're actually changing the way in terms of actually you're displaying an ad for a few minutes of those things. Instead of that, you actually pay as per the impressions that happens in it. So if there is a kind of a brand that's been actually displayed over a jersey, then you can actually identify that brand as well and say like, hey, this many times impressions were there too. So at that level to a pothole detection over the roads. Now the Google provides and various other ones provides the traffic on the roads, but we can actually provide the the quality of the roads. Now you can compare the quality of the roads with one city to another city, and which can be done at the edge level as well too. And there was a time where IoT systems can use to provide the parking spaces where it has been parked or not, which is called a smart parking. It's just a very difficult time because you need to have a magnetometers where you drill on the floor and then actually place the magnetometers connecting back to a gateway and then to a cloud and do it. But now the things have been changed where the computer vision is actually replacing a lot of IoT sensor devices as well to a greater extent. For now, if I see this is one of the places in Hyderabad where where we can actually can place in this kind of virtual fence out here, and where the vehicles are coming and actually been stopping, the parking in these kind of regions are actually identified as an unauthorized parking, and it can provide the alerts as well. Not only that, we can actually count the different kind of vehicles going in each direction and what time and how we can do a lot of analytics on top of it too. Now it goes to another level of it, where we can identify even the food that's been served over a plate and what are the calories of the food as well. In a food as well too. So now we're moving a use case from from emotions to the transportation part of it to the food identification to a lot many varieties. And this is another one which is providing from a satellite image. This is not even a drone image, it's basically a satellite image where we took it off it and we can able to identify where the buildings are. Now if I take this image, this provides a kind of a variety different of an image, which is how a city looks like in India. And you want to know where the roads are, where the buildings are, it's very difficult. Now we're actually segmenting the roads, and we can actually segment. It's very barely impossible for a human to identify where the roads are, but our algorithm is able to clearly identify where the roads are, even if there are kind of shadows, and also the road plantations to the road buildings covering the roads as well too. So this is how it looks like. And where do we stand in the market? We're kind of a tiny mini in terms of market presence, but we actually compete with our algorithms and our platform as compared to various other platforms across the globe. If you see that Tensigo has the right capability and the ability in terms of actually competing with one of the major companies across the globe. Now, if you see this, there are companies like where I just compared with a few of the companies like Google, Microsoft, and AWS, and Clarify and Choose, which are predominantly in this market working on it. And the way where we actually can make a bigger impression is in terms of the enterprise level. Ours is actually scalable, comes at a much more real time on those things, and you can mix and match any of the APIs and build your application at the level what you want it. So that's enterprise grade level it goes to it. And custom neural networks is something that if the customer comes back and says like, hey, we like to have a very specific use case, we want to work on something else, can you build it? So that comes onto a kind of a premium model where we actually build it, but nobody can really build on those things. And one of those things is that a very recent one is a Deception One. This is a financial institution where they would like to build a kind of a lie detection just from a camera investigation, which they cannot really use any kind of hardware, but we are able to build it and able to deploy it on our enterprise grade solution. And we provide an edge level, but not other organizations can provide it. Though AWS provides an edge level, it's kind of very expensive solution, cannot work on it. So one of the some of the verticals that where we predominantly work on is the manufacturing, education, transportation, sports, analytics, and also the governments, which in terms of solving the image processing and the particle detections of the scene parsing and surveillance and data labeling and various other ones. So this is where you do that. I'm happy to can answer any questions if anybody has about it. Thank you.
Hi, Srini. It was very extensive, your session. I would like to understand more about the competitors or the landscape as far as your competitors are concerned, because you have too many use cases. Maybe one or two you can give us the competitors.
Okay, so basically the competition comes from more from the platform, because we are more of a platform as a service kind of company. So what happens is that if somebody wants to really build this kind of a deep learning algorithms, okay, whether it's a hardware provider or probably more of a software kind of thing, they want to build it. You require a bigger set of the team that's actually working, researching and developing those things. It's kind of very, very difficult. And what they do is like, and they look for a kind of a, there's any kind of a plug and play kind of way of kind of an IPS that we integrated. But what you see is that more like an OCR, a simple object detection kind of ones that's available either in the AWS or probably Azure kind of marketplaces in it. But you want to go with a custom developed deep neural networks kind of thing. It's not really available, and that's where we stand a difference. But some of the companies that actually provides the platform as a service are AWS, Microsoft. There's a Chuch and also Clarify kind of way.
Thank you so much, Srini.
Thanks, Sridevi.
Wish you all the best.
Thank you.
So coming on to our next startup, we are waiting for them to log in. Till then, I'll tell you more about this amazing startup. It's called Mihoop. Mihoop is a voice intelligence company empowering humans towards a voice-enabled future using AI. By leveraging voice intelligence, Mihoop helps to understand and analyze voice interactions better in real time, thus enabling seamless customer experience and revenue growth. Apart from English, the Mihoop voice intelligence engine can process multiple Indian vernacular languages like Hindi, Bengali, Tamil, Marathi, etc. So we are waiting for the next participant to join. Just it's a matter of 2 minutes. I would request the host to play a sponsor video in the meantime. We'll wait for them for 2 minutes.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Good afternoon, all again. CTO of Mihoop has joined us as their CEO is not available due to a personal emergency. I would like to welcome Harmandeep Singh ji for IESA AI Summit. As you are aware, this is the Startup Showcase Forum of AI Summit. We would like to know more about Mihoop and how you are revolutionizing and how you're providing access. I heard your mission statement like to make technology inclusive and accessible to all regardless of their language, accent and dialect. So we would like to know more about Mihoop, Mr. Harmandeep ji.
Sure. Thanks, Sridevi, for the introduction. So I'd like to share the thing. So, okay. Is it visible?
Yes, it is very much visible.
Sure. So so I'll talk about the AVA product, the Automotive Virtual Assistant. This is our first product which got launched in Tata Motors. So we here tried to Indianize and revolutionize the voice assistant in the car. So it was a long journey, but still. So about us, Mihoop is basically we are supported by Axel and Idea Spring Capitals. So it was an R&D startup, and later we went into productions after 4 years of our journey. So the highlights about Ava is there is in the car you can have very easy communication. You can do command and controls offline without any need for the internet and in your own language. So currently our languages are also different. So we, instead of saying Hindi or English, we support English, which is a bilingual language. So that's how native users speak in India, right? So where so you can give your command naturally as you speak, like कृपया AC चालू कर दीजिए, or I am feeling cold. So mix of Hindi and English language, it will pick up. So instead of you having to struggle to speak to the system and it being the alien, the system being alien to you, so that barrier is removed here. So it feels very natural to communicate with the system. You can and all the features, they're available offline. So you can control your AC, play some songs, artists, music, make a call to some person, and we even support navigation to any address in the world using what 3 words. So you have to just speak 3, say navigate to apple, orange, mango, and you can navigate there. And so we also provide customizability for the brand. So for the Tata, there is a Hey Tata wake word that we customize for them, and also how the agent might interact with the user. So we try to fit in the business logic also. So some people might want the agent to say different things in different scenarios. We are able to adjust to that also. Overall, it gives a very customized, unique feeling to the users of that brand. And we also support multiple wake up words, so we can trigger other third-party voice assistants also. That's a additional benefit. So it's a holistic system of command and control that comes into your hands when you use AVA. So yes, these are some of the areas like communications. You can dial, you can send messages, you can read messages that come to you. And this then cabin controls, so AC and FATC controls everything. Your FM tuner in entertainment. You can play any song from USB, tune to any frequency in FM, save your own presets. All this via voice commands. You can get weather locations by fetching from cloud. And some vehicle related questions, what is the range, or some specific brand questions also can be added here. And last is location guide service. So it acts as a personal tour guide while you are driving somewhere. If there are some interesting place you are driving by, it will speak up and let you know about the history or the relating information. So it's a very interactive experience in the car. Wellness feature is there. So if you are feeling bad, or you say I am in a bad mood, or the traffic is horrible, then it can adjust the AC and the music accordingly, adjust the fan speed accordingly, and it will reply back to have a good conversation with you, so that you feel better in all ways. So it's a very good feature. Then you might feel bored also. There are some offline based games also that you can play while you are driving. So it's like head and tail, some quiz, uh, share location via SMS. When you're driving, you want to share your location to your friends or family, you can just use the command, and just like calling someone, you can even share location. It will use your SMS. And navigation via What3Words. So we've integrated with What3Words, which is growing rapidly internationally. So just by remembering 3 words about your place, you can navigate to basically any place on Earth. It virtually supports the entire Earth, even the seas. So like even ships, this can be put on ships also. It can help you navigate on the ocean also. Additional capabilities that we have added recently, one includes voice biometrics. Some particular, it's a authentication, linear authentication that can be used. Like you can certain commands, like calling someone, you want to do only when you invoke the command, not the others. So like if you say call to your friend, then it will dial. But if you someone else says the same thing while your phone is connected, it will not dial. So and it can be extended to other features like some small payments also. So edge-based learning is also another capability. So where we are able to see how you interact with the assistant on different times of the day, your frequency of use of various things. So it will and also we get touch events, the other usage events apart from voice from the system, and we personalize. So you might call someone more in the morning, so it will bias the model towards those values, and you get uh, more relevant information rather than general information. So it works with both calling and also your music and media playback. And bargain is there. Bargain means even if a command is done and the system is speaking back to you, you can interrupt it just by saying something or giving another command. It will activate in the next command again. Then there is a new feature, just talk. So certain commands of 15, 20, even 30 commands that are very common. You don't want to keep pressing the PTT button or the hit data or the the wake up button, wake up command. You don't want to be saying the wake up command again and again. You can directly say the command like this. Just say turn on the AC without even pressing anything. It will turn on, and turn off the AC, or you want to like swipe in, swipe left, swipe right. So some common commands can be catered in that fashion. So makes it easier for the user. Multi-intent queries, so up to 2 intents, you can say turn on the AC and increase the volume. So it will do those actions in one go. So like this, we are able to support multi-intent queries. So intent is basically what the user is trying to say. If the user is, like normal systems support only one command at a time, but here you can use connectors like and, or, even in Hindi or in or other native languages that we will be delivering in this year. So you can use your own native connectors of sentences, and you can give multiple commands and it will pick it up. Again, I mentioned multiple VPS. We can integrate with other voice assistants also, like Alexa, Cortana, Siri, using Ava's wake up word triggers. So say if you say hey Siri, it will be directed in Ava's wake up word only, and it will, instead of activating native commands, it knows that it needs to activate Siri. So in that fashion, again, you get a holistic system. Yeah. So wake words I mentioned already. Live streaming is so usually in cars what happens is, so you give a command and it will just execute and play back to you some, and there is some unknown time that you feel okay whether the system understood or not. So that is reduced by live streaming. So whatever you are speaking, it will start typing it on the screen. Usually this feature is only available in online voice assistant, but here we put it in the offline one also. So you get a better UX. So internally, how does the AVA work, or what are the components of AVA? So various parts, like we have some auto recorder which is able to detect the start and end of speech and margin. Noise suppression, we are able to reduce the surrounding noises of traffic, and you can give a very clear speech. It is able to get a very clear speech from you, and it increases the accuracy, overall accuracy of the system. Then learnability module, so it's like so the data, if you want to share, it will goes to it stores offline, but it then if you share it can go to cloud, and we can add your voices also, then it will become more and more better. It will so we can cover even more accents that we might have missed, but usually we deliver 95% accuracy, but even that, for improving the 5% also, which this is the way. So we even get the directly user data if they are willing to give. Then yeah, everything, so automatic speech recognition is there, where everything in our system is mostly neural network based, so it's a state of the art. Dialogue manager, so you can design dialogues, as I said, like business specific dialogues you can design. So you might want to the assistant to speak differently to some commands, so that is also possible here. And then the text to intent, after the speech is converted to text, then we convert it to intent, so to understand what the user is trying to say. And then finally text to speech system, so which is able to speak anything that you can speak out a text basically. So you can read out SMS, or the commands that, or the voice out that it is speaking, with which the assistant is speaking back to you. So all these are text dialogues that are written into the dialogue manager, and it is able to read out using the text to speech, and we provide very natural text to speech system, which is Indianized. So it's able to speak, say, Hindi, English, and even native tongue. So currently, as I said, we launched with Tata Motors in English language, right? So English, Indian English, and Hindi are covered in that. And next, in this year we'll be launching Tamil, Bengali, Telugu, and in the next year Marathi, Kannada, Punjabi, and Kannada. So these will be rolled out, and so that users don't feel other parts of users in other parts of India also don't feel alienated. So we'll be catering to them also. So and every language will be combined with English, so that whichever the user prefers, they can speak either in the native tongue or in English language. And yeah, so we are able to, overall, I won't go into details, but we support very even this is a very lightweight system which can even support on 1 gigahertz hardware is also very low utility of RAM and storage, and overall it's a very quick, very fast, and very lightweight system. So I think these already mentioned. So overall, we provide low latency, higher accuracy, flexible towards business needs, and some are core. So all the components that I shared all have been built in-house. These R&D has been done in India only. And overall, this since it is offline also, and we support very low fees also. So very low fees compared to the other competitors. So it's easy for any OEM basically. These are our customer success story. So we integrated. So the system that goes into Tata Motors was developed by Harman, and we integrated with Harman International. Right. So, and these are some of the testimonies from them. So the current production, it looks like this screen is available in many of the Tata cars, and we are now live in around 1 lakh cars overall. So yeah. Any questions I can answer? Thanks.
That was really nice, Harman. Amazing application. I have seen a lot of times the challenge of understanding English in cars, not by me, but I've seen many drivers going through that. I know in Bangalore, there are a lot of drivers who are unable to comprehend English, rather would prefer Kannada or Tamil. So I think this will solve that problem.
Right. So to even emphasize on that problem, so we're even launching launching soon with Tata trucks. So
yeah,
even
that's
the truck users which do not know English, only their native tongue, they will also be able to use the system.
And that's an amazing use case, actually. Yeah. So thank you so much. Wishing you the very best. Wishing Mihoop the very best. Thank you so much for giving time. If anybody reaches out to us about you, we'll connect them to you.
Sure. Thank you. Thank you very much.
What an exhaustive and amazing keynotes, panel discussions, and startup stories. It's exhilarating, but yet we will come back at 3 o'clock, 3 p.m. IST, that is 15 hours. In the next 2 hours, we are back. So see you then. Thank you.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with a breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation. and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation. and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where the use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation. and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012 and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where a use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You'll need a trusted partner who can help get you there. Someone with a breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools and expertise to empower you to create the products of the future. Go on. Unleash your imagination.
As AI and deep learning technology continues to evolve, we look to neuromorphic event-based processing to set the new standard in efficiency, bringing forth a sustainable solution for successful data migration at the edge by relieving reliability and processing power dependency. Presenting the Akita Neural Processor Integrated Circuit from BrainChip. An architecture designed for sustainable, beneficial AI that can completely offload the processor and DSP from all AI functions, has the capability to learn on-chip with ultra-low power consumption while running a broad spectrum of networks. An engineering masterpiece that represents the union between deep learning and neuromorphic computing, with integrated industry standard tools that make network implementation a breeze. Introducing sustainable AI implementation, capable of revolutionizing key industries. The Akita chip can run entire neural networks using as little as 100 microwatts. Find out more by downloading the Akita development environment for free at brainchip.com/developer. Unlocking the future of AI. BrainChip, Akita.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive. Feel alive. Feel alive. It's the spark that makes you feel alive.
Micron is where data lives.
Hi, I represent Ignitarium. We are a group of technologists who came together in 2012, and we enable high-tech product development. Over the years, we have enabled some cutting-edge products for marquee customers globally, spanning areas like semiconductor design, embedded products, multimedia, enterprise and mobility applications. Our leadership team comprises of industry experts who anchor each of the areas, both the functional and technology areas that we represent within our organization.
Our flagship product is Taikai, a visual deep learning based defect detection platform targeted towards industrial quality assurance. Taikai is built grounds up using advanced image processing algorithms and custom neural networks. One unique feature of Taikai is that it's extremely scalable. It can run on compute hardware that is as light as low-cost microcontrollers to low-cost FPGAs to embedded GPUs to server-class GPUs. Taikai can also operate in an offline mode where the use case is tolerant to latency but requires much more intense processing. Examples include detection of defects in civil infrastructure like railway tracks, pipelines, bridges, etc.
The future. How do you imagine it? Today, we're at the center of a tectonic shift in technology, where data, automation, and artificial intelligence inspire new forms of innovation. and opportunities we can only imagine. Advancements in 5G communications, autonomous driving, cloud, and hyperscale computing are delivering a deluge of data, offering compute challenges for those most able to adapt. Strategic thinkers are embracing tomorrow's challenges today. The visionaries, the disruptors, the architects of possibility. They see that integration and intelligence will be designed into the products of the future. They know the industry demand for holistic system design, for mobility, hyperconnectivity, performance, and reliability. The path forward will not be easy. You will need a trusted partner who can help get you there. Someone with the breadth and depth of technology to anticipate what's ahead. A company with the right combination of tools.
I think we can get started. Good afternoon. I'm Srinivas Bailey, Senior Director at Intel, and I will be your host for this session. Welcome back from lunch and welcome to the session 2 of day 2 of IESA AI Summit 2022. We had great 16 sessions so far, broadly across 3 categories, namely impact of AI in semiconductor industry, AI ML applications, and AI system level solutions, with fantastic technical topics and very, very insightful discussions. Today, afternoon session include AI in robotics and industrial automation, AI ML for EDA tools, AI in 5G, role of academia in research and talent development in AI in India. I assure you, just like yesterday and this morning sessions, today's afternoon sessions and final sessions will also be equally fantastic, interesting, and insightful by our eminent speakers. The first topic for today's afternoon session is a keynote on AI in robotics and industrial automation by eminent speaker, Dr. Roshi John. It's my honor to introduce Dr. Roshi John. Dr. Roshi John is a robotic and AI expert in Ignatium. NASSCOM has quoted him as the man who kickstarted India's driverless car revolution. Dr. John has 12 plus years experience, hands-on experience in creating driverless car prototypes of Indian road scenarios, 37 international patents in robotics and artificial intelligence. Dr. John is known TEDx and keynote speaker. 20 years of overall experience at enterprise level in robotics and artificial intelligence. Welcome, Dr. Roshi John, and over to you.
Thank you very much for the introduction. Hi, I'm Roshi John. Please let me show my screen. I think you were doing the yeah. Keep going, okay.
Dr. John,
am I audible? Hello.
Yeah, Dr. John, can you turn on your video? We cannot see you. Dr. John?
Hello, am I audible?
Yeah, we can hear you, Dr. John. We cannot see you. Can you turn on your audio, video?
Just turning on the video. I have an error which is popping up, so that's what I was just trying to fix it. 1 second. Is it visible? Yeah.
Yeah, we can see you.
Yeah, sorry.
Over to you, Dr. John. Can start.
Thank you very much. Just a second. Hello everyone, good afternoon. This is Dr. Roshi John. I'm a consulting strategy consultant for Ignitarium. I am overlooking the AI and robotics-based delivery for robotics services inside Ignitarium. And thank you everyone for this opportunity, for the speaking opportunity at this forum. Is my screen visible?
Yes, we can see your screen.
All right, thank you.
Dr. John, we can see your screen.
Thank you very much. So today I'll be speaking more about how robotics, or how Ignitarium focuses on robotics and AI related solutions, specifically for industrial level automation on the onset of using advanced AI based solutions for manufacturing applications. So these days, manufacturing applications are mostly onto the conventional PLC based automation, where the overall solution is being managed by PLCs, and the robots are being connected and handled with the help of PLCs. So it's in one sense, even though it helps in advanced automation, it helps in advanced solutioning of most of the automation which is there. Repeatability, the conventional concepts of automation is being carried out, but still we found that Ignitarium found that it is the overall solutions and can be improved. For instance, even if it's a pick and place kind of an application, there's a huge gap in the overall area of how these robots are function or should function. The huge gap is because if the PLC which controls the robot is programmed in such a way that it is mainly to pick and place an object or an artifact which is coming out from a conveyor belt. That if at all there is no artifact on the conveyor belt, still the robot would do the pick and place maneuver, because it is being programmed to do that. Because it is being programmed in such a way that the robot needs to be in this, the end effector of the robot should be in this XYZ position. When XYZ position, and the robot expects that artifact should be on the conveyor belt or on the place which is supposed to pick the artifact. There is no intelligence in it. So what we are doing is we are providing intelligent solutions for almost all the manufacturing processes. From the analytics part, where the different stakeholders of this manufacturing unit has complete view and visibility. We do have a lot of host of solutions in warehouse automation, and the elements which requires to build warehouse automation. We are working with multiple customers on the warehouse automation kind of a solution, from robotics to analytics to making systems or deep learning systems read and understand solutions from a lot of data points which is coming either from cameras or from sensors. We do have solutions in cloud-based automation. We do have solutions in complete robot automation services, where we're working with customers and multiple customers all around the world. So in this presentation, I'll be showing some of the case studies for the interest of time, and to answer a few of the Q&A which is being lined up after this presentation, what we are planning to show is some of the case studies which we have done. So today, if you see, warehouse automation has become one of the most important opportunities, and specifically in mobile robotics or automated guided vehicles. And the onset of this COVID-19 pandemic has increased the demand of online supplies and all. And there are a lot of cases where even in India, we have figured out that many of the stores has been converted to dark stores where the customers are not supposed to visit, though they access the local delivery centers or local warehouses. Instamart, Swiggy Instamart is one of the best examples, which we can see, where if you order, you don't have to go, you don't have to step out of your house, you just order with your mobile phone, with your app on the mobile phone, and these whatever you order will be delivered to your place within like 15 to 20 minutes. Which is actually in good in one terms, like employment for a lot of people who are like struggling in the time of the COVID-19 pandemic for an income. On the other hand, there are a lot of other issues with the delivery systems. One of the major issues that most of our customers facing is the issues which is caused by human error. When you are when in terms of a dark store kind of a concept, what happens is the overall because of fatigue and all, the people would be packing the wrong items to a consignment which has to be sent to a customer, and the overall time frame which you get is like really small, like 20 to 25 minutes. 20 to 25 minutes for the oral delivery of solution of oral delivery of the consignment is like it's becoming it is putting so much pressure onto the delivery the whole ecosystem. So we have come out with a lot of solutions in and around the dark store or maybe the warehouse or any of those things, which helps the deliveries and solutioning becomes much more easier. So here we have created a host of mobile robot-based solutions, which helps the stores and which forms this elements, and we are pitching up with so many customers where we have created a complete mobile robot solutions with mapping and all, so that which helps these robots to adapt to any type of stores with minimal amount of time. And the delivery is also made. This is one of the prototypes which we have developed, which uses a mobile robot platform and a host of sensory systems, including lidars and cameras and all. On the right side of the screen, you can see how this robot navigates on an arbitrary position and how well it created the map. So we have made it map the whole place. So when a customer adopts this kind of a solution, we'll be creating a custom robot solution just for their requirement. And thereby, these robots would be able to map the place. And the major requirement which would be coming is like when you switch on the robot is in a random place, and the robot has to map the place. And when we tell the robot to go from a point A to B, we have to use all these sensor systems and all, which helps. And so what we are providing is a kind of an IP as a point robot solution, which helps these robots to go from point A to B. We have created these outdoor mobile robotics, which helps these robots to be used for last mile delivery and all. So we have been demonstrating, and we are also going to demonstrate this on different worldwide forums, where we'll be showing these robots. This is one of the products which we have developed for last mile delivery, and where these robots are used for end-to-end outdoor kind of application, which uses all these robust sensors and all of the sensors and actuators and all those things which are environmental proof, which can be made available outdoors. So we also have the solution to be useful for lots of other technologies, from outdoor navigation, which can be directly used in driverless cars, specifically for confined environments, maybe like an airport or a seaport, where we can use this IP to navigate these vehicles from point A to B, even though there is so much of dynamic obstacles, or even though there is so much of uncertainties in the path which the robot is planning to traverse. So with this IP, we are showing this as a demonstration platform, and we are trying to adapt this to so many other complex applications where it can be useful for navigation in very tight situations, just like the type of traffic or the chaotic kind of traffic which you find in India. We are also planning to set up this as a demonstration platform in IT campuses where most of these may be providing a food service with the help of these robots, and which can go from the food supplier to the right to the cubicle of the employee. So there are so many solutions which we are planning, and what we are providing is the software elements which helps maybe companies to adopt this and focus on their solution much more faster. And we as a service provider would be able to help these companies to quickly adapt and deliver this as a solution. This can also be used in makeshift warehouses because in the last couple of years of pandemic, the first few months it was so difficult because the supply chain and all these things were all in a very difficult and tough situation. But after that, people or companies started to figure out how to solve these things, and how we are able to navigate through all the chaos which has been found. And now we can see that all these app-based solutioning has become much more useful. And these solutions which we are developing, which helps people to to do an error-free kind of a delivery without too much of human error which is happening. So this is one of the solutions which we are developing. I'm moving on to the next solution, which is the food factory automation. So we are working with a lot of commercial kitchens or commercial baking units, where the major challenge which they face there is the rejection ratio. So we are working with one of the customers where the rejection ratios are like they are creating hundreds of thousands of baked buns in their industrial oven, industrial the commercial size or industrial size ovens, and they are having a rejection ratio because this is being done for one of our overseas customers, where the customers, the end customers, or the people who are consuming this baked products are very particular about the texture of the baking. So with this, what happens is like the baking has to be done in a very precise and very particular kind of a manner, where they cannot afford to have over baked or burned kind of a artifact, or maybe the food which is coming out. So this is one of those perfect examples of perfectly baked buns, where the cuttings and the amount of sesame seeds which are there. I'll just play this again. Which are the customers are so the end customers or the consumers are so particular about it. So the major challenge which they faced was the conventional PLC-based solutions had a major challenge because it's supposed to bake on a particular temperature at a particular time. But what happens is like because of the density or the errors in the issues of all these kinds of things, it would end up in over baking or under baking, or the distribution of sesame seeds, and all these things are factors. And when we analyze the overall solution, there are even more solutions or even more issues to be addressed, just like the raw materials which are brought in, where there are mold in the overall kind of the raw materials which are molded, which adds up to the overall issue and causes even more issue to the even more problems to the overall addressing the overall issue. So we created an end-to-end kind of a solution where we were able to even detect in the storage. We were able to detect with the molds, the missing food ingredients, the way where some of these over-baked kind of cookies with the help of solution, and thereby we were able to provide a complete solution where we were able to provide AI connected cameras which goes through every of those raw materials and see whether the baking is done on a precise way. Conventionally, like maybe 10-15 years ago, we were talking about Kalman filters, which would help these baking systems to come up with an optimal temperature to bake a food product, let it be a cookie or let it be a bun or let it be a pizza. the pizza or any of those kinds of things. But right now, the customer demands are much more higher, and the rejection ratios have become even more higher. So which is where the customers are losing a lot of money. So we have created a solution where we have these AI connected cameras which runs our AI platform, AI solution, which is into these robots would be able to. It will be a completely industry 4.0 similar kind of a solution where the robots would be able to identify or predict most of these solutions, and all these things are based on the learnings which we have provided onto it. So the learnings becomes when you have a PLC based solution. When you have it, there is a major challenge with the overall thing, because the PLC-based solutions doesn't have this capability to capture data for us to train the overall networks so that it can be efficient. So what we did initially was to put cameras and the customers which we worked with that doesn't have enough data sources, or the objective for them was not to collect information. It was to do complete automation, and the throughput is what they were worried about or they were concerned about. What we did was we were able to place cameras, and we were able to capture a lot of sample data set which was non-existent, which is not even available in the public domain. So we were able to use this and annotate this with the data set which are collected with the cameras which we have placed there, and thereby we are able to use our machine learning team to come out with information, to come out with more insights which was not captured before by customers, or maybe it was not available in the public domain. We were able to do a complete automation of the overall solution, and thereby we were able to come out with a cloud-based solution. And we are even in a position of creating a digital twin and suggest our customers on how we can improve the production in a live basis. On one side, the digital twin simulation will be happening. On the other side, the production can happen on a live basis. And some of our customers are not ready to put the information on the cloud and then control the overall of their equipment system. But there are customers who are ready to try out a digital twin on their on-premises cloud system, on-premises network or server system, where we'll be running the overall thing. So eventually, we are able to reduce the rejection ratios and thereby save a lot of money for our customers with the help of an AI connected camera system and a packaging system for them to increase the output or throughput of the overall system. So another challenge which we faced with one of our customers was because of human error. Because I'm not blaming it as human error as such. The issue was mostly onto packaging and palletizing. So I'm just shown an image where the robot is actually doing a packaging. This is in a cement factory. This is for a different video, this is available online. So I just took this video just for showing or demonstrating it. So the major challenge which our customers faced was because of a human error. There are two artifacts which are coming out of the assembly line, which look exactly similar. The challenge that the customer faced was most of these things are packaged or packed on the same packaging. And the difference between these two artifacts which have been coming out, these two objects which are manufactured, which is coming out from the assembly line, is too difficult to distinguish. So because of human error, because of the people in the assembly line, because of human error, they would package it in the same packaging. And this is for a B2B kind of a customer application, business to business kind of a customer application, not a consumer application, but it was a safety critical kind of a system which the customer was selling. The major challenge which they faced was the customers would know only when they open the packaging for the end application. Before that, the customers wouldn't be able to understand. The customer wouldn't be able to understand. This was the major problem statement which was given to us, and we solved it with the help of a AI-based system. This is one of the prototypes which we created inside the lab, where we created an AI-based camera. In the video, you can see that there's a camera which actually scans the package which is coming in the conveyor belt, and on one side, it looks at the packaging and makes sure that whatever contents inside the package is what is written on the outside on the label of the packaging. So a two-step verification is being done during the time when it is being picked up. So if it is the artifact which is inside the packaging had a specific marking on its side, and we were able to use deep learning systems and the cameras on industry grade cameras to capture close to 100 fps. It's on it's on grayscale, where that was enough for the specific application. Where on one side it is capturing the picture of it just before it is being picked up, and then it is comparing whether the package, the label on the package is coinciding with the overall package information. So, but with such a solution, we are able to override the conventional PLC-based automation, and thereby we are able to solve this specific customer problem, where the customer was able to had this huge human error related issue which was actually coming up. So these days we get a lot of PLCs which can be controlled from outside, and thereby we are able to connect our NVIDIA based systems, NVIDIA based deep learning systems. I think we used 1080 NVIDIA GPU cards specifically for this application, where on one side it will be reading the information which is there on the label, and which is written in plain English. On the other side, it is looking at this object which is inside the packet or the packaging, and ensuring that the label and the information is coinciding. This is not possible with the conventional PLC-based system, because a PLC-based system would be, I'm not saying that PLC-based system is inferior or anything, but what we are trying to do here is to specifically let the system work or helping the humans to do more jobs in terms of the automation, and thereby increasing the throughput and productivity of the overall system. So this is another requirement which has come in for the bottling application. So one of our customers had this requirement of quick turnaround of changing bottles. So this is a bottling kind of an application. So you can see that one of the major challenges in bottling application is that all these rigs or the jigs which they have is meant for a particular sized bottle. So with the conventional automation kind of a system for milk refilling, for a quick turnaround kind of an application, what happens is, like, you have, if the customers are opting for a 300 ml or 250 milliliter bottles, and also a 500 milliliter bottle on the same assembly line, with the conventional kind of automation, because of the jigs and the sizes of the capturing mechanism, it is not possible. So this is also applicable for this bottling lid fitting kind of application, where how these lids are being fitted. If it is a smaller bottle, then they have to change the whole jig and the whole system of the whole thing. So what we did is the combination of a multi-axis robot and a holding mechanism, which we are able to solve the overall problem. Thereby the bottles are being held by the robotic system, and then the cap is being filled with the specific a kind of end effector which we have created. So this is a solution, and just like that, we are also focused on this is a proof of concept which we have done on the worker ergonomics. So to increase the productivity of the worker, it is very important to see the worker ergonomics and his pose estimate and his pose. Because if he is on the wrong kind of a pose, there will be so much of fatigue which is coming, and he will not be able to. The productivity will definitely come down. So we have created solutions which uses this pose detection and suggesting these workers to do a better pose, and these are done with cameras and 3D perception units and all those technologies which suggest and helps workers to increase their productivity and to adjust their pose in such a way that there will not be too much of fatigue which is creeping in, and thereby reduces their productivity. Do I have time? Am I just running out of the time? It's 3:25 already.
Yeah, Dr. John, I think we have next session going on, so maybe you can conclude in a minute or two.
Yeah, I will do that. Yeah. So there's another solution which we have. So it's a factory line assembly with our AI platform, Taikai. So with this, this is one of the projects which we've done for a footwear footwear inspection, where we are able to use these cameras and solutions for specifically for footwear manufacturing, where with the amount of data sets which we are trained, we are able to quickly make a solution which could identify whether the sole of a footwear which is coming as a as a raw material, whether it follows the overall criteria of being it's good or no go. This is just a sample of a proof of concept project which we done, which helps our customers to specifically do this productivity and increase the productivity and all those things in a much quicker fashion. So overall, what we are trying to say is, like, we have created so much of these solutions where we were able to help the next generation factories and next generation manufacturing application much more streamlined way, so that it gets into a more like a industry 4.0 solution. We do have the specific elements to specifically do that level of automation. Thank you very much. I'm open for questions.
Yeah. Thank you, Dr. John. It was a very, very great session. I learned a lot personally on so many AI robotic applications at one place, and the details that you are looking at, the food quality and the problems that you are solving. It's a great, great session. Thank you. And there are a bunch of questions, but in the interest of time, and the next panel is already queued up, so we'll send the questions offline. Thank you, Dr. John. Thank you.
Thank you very much for the time.
Thank you. Our second topic for this afternoon is a panel discussion on AI ML for EDA tools. Right, as the size of semiconductor chips are exploding and geometries are down to 3 nanometer and shrinking day in day out, there is a big role and need of AI ML to improve the EDA tools efficiency and turnaround. This panel discussions will be chaired by Mr. Venkat Simadri. And the panel includes Venu Puvada, Surya Prekke, Sridhar Rangarajan, Shekhar Mahajan, and Umesh Nair. It's my great honor to introduce Mr. Simadri. Venkat is a serial entrepreneur, proven executive in semiconductor industry with 30 plus years of experience in semiconductor and a Bay Area veteran. He's currently the CEO and MD of Moschip, publicly listed semiconductor services company, and focus mainly on and also focuses on IPs. Welcome, Venkat sir, and over to you.
Thank you, Srini. I'm trying to turn off my video here. Can you see me?
Yes, we can see you, Venkat sir.
Yeah. Hopefully, you can also let my other participants, panel members, turn on their videos here. So I'll give you a quick background. So I've been in the semiconductor industry, as you said, for almost 32 years. And when I started my career, we were still sitting and drawing schematics and then converting them into layouts manually to design the chips. And when we first, started using RTL and synthesis, we were all excited. We thought, we can spend less hours, go home earlier, and design chips faster. But that's not the case. The chips are getting bigger and bigger ever since last 30 years, and people today, they're designing some of the most complex and largest chips in the industry, mostly for AI type of applications that go into data centers, things like that. So we definitely going to focus on, how does the industry, the EDA industry, keeping up with this, and are they using any AI ML type of stuff to, really improve these tools? And today we are so lucky to have some of the most, industry eminent people in the panel discussion today, both from the EDA side and also from the product design side. And I think we should let them introduce themselves. I will start with Shekhar Mahajan. He is from Synopsys, and he is specifically working on areas where EDA tools can be improved using AI. Shekhar, can you please quickly introduce yourself?
Thank you, Venkata. Good afternoon, everybody. Can you hear me?
Yes, sir.
Excellent. So I have 25 plus years of experience in EDA industry. Started my career in Bay Area with FPGA industry, architecting FPGAs. Moved on to the EDA tools. And then after relocating to India, I started QuickLogic's India operations. I've been country manager for 10 years and then joined Synopsys. At Synopsys, I've been working on driving high-level synthesis and then recently onto AI ML adoption across the Synopsys. And recently, I've been also part of a team that delivered the cloud solutions for all the Synopsys tools. Thank you.
Thank you, Shekhar. And we will go next with Sridhar Rangarajan. He is from also, a EDA industry. He works for Cadence. Sridhar, can you please quickly introduce yourself and let us know what you do at Cadence?
Sure. Thanks, Venkata. Good afternoon, everyone. I'm glad to be part of this panel discussions. Currently, I'm working at Cadence, driving this ML effort in the backend space at Cadence India. This topic of AI ML in EDA is very, very dear to me. So I have around 20 plus years of experience architecting and driving tools in the backend design space, especially in placement, optimization, and routing. The past 5 years or so, my focus has been to see the adoption of ML and data analytics in EDA space to improve the efficiency, especially on the backend. I love to contribute some of my experience here. Also, love to learn from the fellow panelists. Looking forward to a great discussion. Thank you.
Thank you, Sridhar. Definitely, we're all excited here. So we have Umesh Nair from AMD. And as you all know, AMD is probably the only company in the industry right now that does both CPUs and GPUs and have a leading position in the industry in both those areas. And I like to have Umesh introduce himself and maybe quickly tell us what he does at AMD.
Yeah, I'm the Director of Design Engineer at AMD and responsible for the CPU team in India. And we also do, besides CPUs, also some of the SoCs. I have about 24 years of experience, around 18 in the US and the rest in India, and have worked in different aspects of VLSI design and driven a couple of innovations across the company here in India. So that's me. And yeah, I do look forward to a good discussion and happy to be part of this panel. Thanks.
Thank you, Umesh. By the way, I did work for AMD long time ago, between 95 and 98. And it always feels nice to, talk to another AMD fellow here. Thank you. And then I like to introduce Venugopal Puvada. He is from Qualcomm, and again, Qualcomm is one of the leading companies that does supply 5G and Snapdragon type of chips, and they are mostly used in automotive and telecom applications. So you maybe Venu, you can quickly introduce yourself and tell us what kind of chips you're designing and what you do at Qualcomm.
Thanks, Venkat. Yeah, wonderful to be part of this esteemed panel. My name is Venu Puvada. I'm a Vice President of Engineering at Qualcomm Bangalore. I've been working in various aspects of chip design and development and AI research for many years. I've been with Qualcomm for the last 15 plus years. And prior to that, I was at Texas Instruments Bangalore for more than a decade. And actually, I must say that I've been very, very fortunate to have witnessed the steady and stupendous growth in the semiconductor ecosystem in Bangalore and in India over my entire career. I'm also fortunate to have been working alongside the brightest and best of the talent. In fact, it is lovely to see all the co-panelists here. They're all from companies that are very close partners with Qualcomm. So looking forward to a lively discussion.
Sure. With that, we will like to hear from Surya Preke, and he is working for another, the leading semiconductor company in the world. It's Intel. And Surya, please introduce yourself and give us a quick background about you.
Hey, thanks, Venkata. Good afternoon, everyone. I hope all of you are staying safe and doing good. Yeah, so I'm VP of Engineering in the Networking and Edge Group in Intel. I joined Intel 19 years back from IIT Bombay. I was also CAD engineer during my formative years, and eventually I settled in physical integration. So I drove physical integration of several generations of large die Xeons across multiple nodes. I spent a couple of years in Qualcomm, where I worked on some amazing mobile products with Venu's team. For last 5+ years, I'm leading Intel's IoTG global physical design team, where my team works on IPs and SoCs going into laptops, servers, networking, IoT, auto, and various other edge products. And we do it on both Intel nodes and external nodes. So it's great to be part of this esteemed panel. Yeah, I'm really looking forward to the discussion.
Cool, Surya. Nice again meeting with you. So now let's get to the point. And the topic is, what are the most complex designs you're doing, and how do we really, use AI, ML to increase the efficiency and turnaround times. So my first question is for the, EDA users here who are really designing the cutting edge chips in the industry right now. So what is the most complex design you have done in the last, couple of years? And, where are you really finding the challenge with the current EDA tool flows you're using? You don't really need to tell us which tool flow you're using, whether it's Cadence or Synopsys or somebody else. But we like to understand at a high level what kind of challenges you are facing currently with the existing tool flows. So we will start with Surya here, and Surya, maybe you could give us a quick experience you have in the last couple of years.
Yeah, definitely. Thanks. Yeah, well, there were several large die and high performance designs that gave us multiple sleepless nights. But one of the most interesting and challenging products that I worked on was industry's first 3D IC. This was a couple of years back when the EDA ecosystem was not ready for this. And then we had to design 2 functional SoCs and different technology nodes sitting one on top of another, where we had thousands of wires crossing between the dies, comprehending all the cross-die timing, cross-die power, thermal, and the multi-physics aspects. So we, in fact, took it to the next level. You must have heard this thing called Ponte Vecchio, where there are several top dies sitting on one bottom die. So the complexity has increased significantly. EDA ecosystem is definitely getting a little bit more mature to handle this level of complexity. But this whole concept of 3D designs with TSVs, multiple chiplets coming together is something to watch out for future.
Oh, wow. Okay. So I understand where the challenges are coming from. So I will ask the same question with Umesh from AMD. Umesh, do you like to add anything here?
Sure. Yeah, so the complexity of the industry with design size is one part of it. The second part is with advanced technologies like 5 and below. There are so many parameters. And like in some of the designs, we are looking at very high frequencies, and every milliwatt and megahertz is really important. And also on the SoC, we're looking to expedite the convergence time, because the time to market has become extremely critical for all the companies as well. And to get that predictability with so many parameters getting added in different stages of the design, so the predictability ahead of time is definitely an area which is very challenging. And of course, the convergence time with all this complexity in terms of advanced nodes and design size. yeah, so these are some of the challenges that we are seeing in the latest designs.
Thank you, Imesh. Venu, do you like to add anything here? From your
Definitely, yeah, definitely, Venkat. So yeah, I worked on scores of tape outs over the years. So one of the most complex chip to date, if I had to pick, right, it has hundreds of millions of instances. So the instance count is large, billions of polygons, and over 10 billion transistors, right? Well above that. So in terms of the numbers, yeah, I would say that is definitely the most complex and the largest. Now, the biggest challenge is not really the size alone. The biggest challenge is in the wireless space. We need to get the power, performance, cost, schedule, and lowest resources all at the same time, right? It is not like, hey, only one of these is a priority and you need to make that happen. No, actually, all of them are priorities and we need to make all of them happen. So I would say, essentially, trying to do this concurrent optimization is the biggest challenge. Because if everything has to be good, that makes it an extremely hard problem for the EDA vendors.
True, Venu. I think by hearing from all three of you, the message is very clear. The complexity coming from various aspects. One is on the using these multiple dies and stacking them, and finding the right tools to address those challenges. And the other challenges, naturally, handling the size of these chips. As you said, 10 billion transistors on a chip. Wow, I mean, how many zeros? I don't even understand. It is. And then finding the balance between the power, performance, and all that stuff. And now you're relying on the EDA tool vendors and to handle all these issues. Now let's hear from the EDA tool vendors. We have, as I said, we have the two leading EDA tool vendors in this panel here, and they're constantly improving their tools to address these issues. Let's start with Shekhar. Shekhar, when you are trying to address these issues as a company, as a Synopsys, where do you see the biggest challenges for you guys?
Sure. I think our challenges cannot be different than our end user challenges. And let me replicate that. So typically EDA industry has been striving to go along three vectors: QR, quality of results; COR, cost of results; and TTR, time to results, right? As Venu rightly pointed out, what is happening now, the confluence of all this QR, COR, and TTR is creating a big challenge in terms of as we go for bigger and bigger design and smaller nodes. Because what is happening, the complexity is not only because of the size of the design, it's also because of the specific issues. For example, IR drops. We are looking at STA, we are looking at routing rules, placement rules. Just to give some flavor, if I may, Venkata, there is this chess game we have, right? It has 8x8, 64 boxes. The number of states for chess games are like 10⁻123. If we look at the Go game, Chinese version, it has 10⁻360 number of states. If we look at the placement today with the bigger design and the smaller nodes, it has 10⁻90,000 states that are there. So look at the enormous complexity that is being offered. But when it comes with the confluence of QR, TTR, and COR, that becomes much bigger. And that's where the ML AI offer a lot of good potential for not only the EDA vendors, but also users.
Thank you, Shekhar. From our colleague, Sridhar, do you like to add anything here?
Sure, Venkata. Yeah. So if you look at semiconductor industry, if you look at it, it is experiencing a renaissance, right? There is a tremendous growth in terms of 5G, autonomous driving, hyperscale computing. Some of you guys mentioned about the industrial IoT, etc. Right? So the chips are becoming complex and then bigger in size, right? So those are the things. And then the next generation chips needs to be produced smarter and faster, right? So essentially, if you look at it, this productivity and PPA is driving the tools development, right? Tools development. So one of the examples, if you look at it in the back end, especially in the physical design space, it is very iterative in nature, right? There are a lot of iterations. The state of the art, if you look at it, we take an input, run through these tools. Some of these, many of these are world-class tools, no doubt about it. But it takes 1 or 2 days, and then you get an output. And then we have an experienced design sitting there, and then going and analyzing it and manually derive insights out of it, and then go and tweaking this design inputs or tool parameters or whatever it is, and then again doing it, right? It's like a kind of iterative in nature, right? So definitely that's one area where Cadence is looking, researching, and focusing on how to improve the PPA and productivity kind of, right? So to give an example, we have a product, Cerebrus, right? Intelligent Chip Explorer, right? It's a complete RTL to GDS flow tool optimization kind of tools, right? So it's mainly, instead of manually exploring this design space, Cerebrus intelligently explores this design space and comes up with a near optimal solution in less amount of time, right? Using some of this ML techniques like reinforcement learning and other stuff, right? So that's one kind of example where there are challenges, and definitely there are opportunities, right? I mean, with the current, the way the industry is going, there are plenty of opportunities, I will say, for the EDA tools and companies. Yeah.
So again, the one thing I really, like to understand here, right, for the benefit of all the participants here, we do understand how this AI and ML helping in the medical field or something where they keep feeding a lot of data, and these things, the learning process, the tool learns how to, the AI algorithms. But on the EDA side, based on my, industry track record and experience, basically, for example, you're doing a place and route. So there are a bunch of placement algorithms, kept developed in the universities, and they kept improving on top of them. And now you take a design and feed this netlist into this algorithm, and the computer comes up with the best possible placement. So how does this AI really, helps in these type of EDA tools, and how do you actually, envision using this here? Maybe you can explain it to the audience here.
Sure, definitely. So if you look at it in a sense, how much AI can have an impact on the EDA tools, right? So if you look at it, we have several projects going on in this ML and then data analytics space, spanning across different products, right? Maybe you talked more about the back-end design space, right? If you look at it, when we talked about this iterative in nature, where how ML, some of this can help. The other look at it, traditionally, if you look at this EDA problems, majority of these problems are called NP complete problems, kind of, right? You cannot come up, you have to approximate to come up with a solution in polynomial type, right? So typically we use a lot of heuristics as kind of approximation to solve these problems, right? So definitely these heuristics are mathematical models, but that's based on certain inputs of the designers and the EDA tool. Kind of, we come up with this mathematical models, right? Definitely, this is one area where ML can help tremendously, because if you have enough data, we can have a better mathematical model and then go and improve some of these heuristics, and then we can achieve that, right? So that's definitely one area across the tools and across the algorithms we can go and look at it. The other area, if you look at it, sometimes we due to time to market pressure and other things, a lot of design is over-designed, or we do a lot of margins, leaving inefficiencies in the table, kind of, right? Definitely, that is another area where ML can definitely improve some of these efficiencies by using data analytics and other stuff. Yeah. That's typically on the back-end side. Typically, similarly on the front-end side also, if you look at verification, there are many areas where ML can help, because verification, we generate lots and lots of data. That is one good thing about verification. So anywhere we have a lot of data, ML is a ripe area to work on. So to give you some examples, coverage closure, where you want to get the same coverage with less number of vectors and less amount of time, and then coverage maximization. How do I maximize the coverage given the same number of vectors? So these are definitely some areas where ML can have a majority of impact.
Thank you. Thank you. That's a very good insight, and it gives the audience and including myself pretty good idea how you guys are planning to do this. So I will slightly switch the gears here and traditional EDA flow here, right? Once somebody wants to design a chip and they start with architecture, then do the microarchitecture, from there RTL verification, after that synthesis, place and route, and various steps. And I like to ask our product designers here, where do you see the biggest challenge in this whole flow, and where do you seek help from our EDA partners here? So let me start with Venu from Qualcomm. Venu, can you give your opinion on this?
Definitely. So I think the first and foremost thing I would say is, well, there is a lot of talk on AI and ML. I feel there are three main blobs if you're talking about the machine learning paradigm, right? One is the problem statement. Second is the data that needs to be gathered or generated. And third is the appropriate algorithm that needs to be used for the context that we are talking about. So too often we get focused on what data we have or what data we don't have, how do we generate, or what is the right algorithm. But many times I think the real challenge is in the problem statement. So if I create a problem statement that is very high level and say, I want to improve cycle time, or I want to improve efficiency, that is not going to be enough. So we really have to get deep down and come up with the right problem statements for our EDA partners or for our own research teams to actually work on. So if I have to pick two areas, right, in the entire flow, where I feel there should be a lot of focus on AI ML, I would say it is physical design and the design verification. Now, why am I picking these two? Mainly because these two teams pretty much end up defining the schedule and also the number of resources that we will have to use, the majority of the resources on a project. So that is the reason I feel we'll have to go after reducing the cycle time and reducing the resources for the chip. That is the need of the hour. So how do we do that is the question. Now, if you say, hey, come on, this is too high level, can you give like some examples in each of these domains? In the physical design, I can talk about IR drop analysis or voltage drop analysis. So right now, the dynamic voltage drop analysis takes humongous amount of effort. And we all know that generating a VCD that can actually take care of multiple scenarios is not very easy and very time consuming. At the same time, doing a vectorless approach to a dynamic voltage drop analysis can be very, very pessimistic. So this is a prime area where AI ML can actually be brought in, and we can actually reduce the cycle time from days to hours or even minutes. So that is one example, one specific example I can think of where we can deploy this. And similarly, on the verification side, how do we get faster coverage, right? Instead of just depending on random analysis or trying to depend on the human intervention to actually get to that full coverage is another area I feel we should focus on.
Thank you, Venu. It's very good inputs. As you said, physical design and verification, these are probably the most iterative processes and they need a lot of resources. And I like to hear from the other, two panel members from the product companies. Umesh, you like to add something here?
Sure. I think Venu put it well on the high-level items on physical design and verification. So going back, I think there are a few critical areas to go in a little bit of detail in these areas. So I think predictability earlier in the flow is very, very key for expediting convergence, right? So there are steps taken, but to put all these metrics together. So to quote one example, we have, both Synopsys and Cadence have design space exploration and global route to detailed route, the RDE estimations. But we need to take it a little bit further with machine learning, and where the EDA vendors can really focus on is to have a comprehensive model combining different areas, right? Like IR, incremental timing, right? 90% of a lot of the ECO cycles are spent on when the design is changing 10%, right? So can you really improve that cycle? And on the verification side, right, can there be automatic stimuli? Can we focus on areas of where there is higher probability of bugs to be found based on learning from previous designs and the nature of the bugs during the current design cycle, right? So these would be some of the areas, and there is a big, probably a huge list, but to have a model that combines these, like a placement algorithm which takes care of IR, timing, power, right? That needs to be the next step rather than isolated, focused areas.
Thank you, Umesh. How about Surya? Surya, do you like to add something here?
Yeah, I think Umesh and Venu touched upon most of the stuff, right? The bottleneck, the areas are very clear. If I look at within PD, right, there are largely three phases that we have, right? The construction, convergence, and the sign-off, right? While there are several advances in the tool, we still spend significant amount of time and energy in the convergence and sign-off phase, right? Even if I spend a few days, a few weeks more in the construction, as long as it gives us a good output for us to converge faster, it's still okay. So EDA needs to figure out how we need to left shift some of these activities into constructive phase, right? There are solutions, there are recipe recommendation solutions coming from both the vendors. There are prediction algorithms, right? Predicting PBA and GBA, predicting routability issues in placement stage, clock skew issues in placement. There are predictive algorithms. But one phase where we really need a little bit more push from the EDA system is that root cause analysis phase in the convergence section, right? How can we speed up triaging the timing violations, right? How can we speed up triaging the LVS GRC violations or FEV issues, debugging bad clock skews, right? How can we let's say auto fix DRCs? So there's a lot more to do. While there is more work on the recommendation systems and then the predictive algorithms, I believe there's a lot more to do in the root cause analysis part.
Thank you, Surya. Actually, I was hoping one of you guys talk a little bit more about physical verification, and that subject was actually close to my heart. See, a lot of times you do everything, you close timing, and the IR drop analysis, everything. Finally, you get into DRC, LVS. And now you're talking about billions of transistors and even billions of polygons here, right? And geometries. So the DRC, LVS can be a nightmare as well. And also, I'm sure the DRC and LVS, the DRC rules are a lot more complex than what they used to be 20 years ago. And because they directly, impact the DFM here, right? Manufacturability and yields. Can anybody throw some light on that? And because I thought AI and machine learning, because of these, these are all patterns and pattern recognitions, things like that. I thought they would add more value in this area as well. Can anybody on the panel throw some light on these areas?
Sure, I can take that, Venkata. So yeah, physical verification is definitely a very, very critical area for two reasons. One is, ideally, we want to get to zero DRCs. That is, you get out of your place and route, you want zero DRCs. Now we understand that is, not easy because, there are correlation issues and other challenges. But I would say that is one area that is between PNR, the place and route, and the final sign-off. How do we make sure that there is zero DRCs that come straight out of the bat? I feel that is one problem. Another problem that I feel is even more important, given that we are all in the middle of supply challenges, right? There is a huge problem in supply from our foundries, mainly because, of course, the demand is outstripping supply. But it goes without saying that if we can improve the yield alongside, then that is going to really rake in a lot of profits to all the companies. And the DFM, so if we can do something on the DFM front, I know there are a couple of startups also that are focusing on this right now as we speak, to improve yield. That is, I will give it GDS and then use AI ML. And of course, the known DRCs from the foundries, understanding of the yield issues. Can I enhance that GDS so that I can improve the yield by a few percentage points? If that is something that can be achieved in the next couple of years, I think it will be tremendous. So it will be zero DRC coming out of PNR, place and route, and the other one is yield improvement using DFM tweaks on the layouts.
Yeah, I just want to add one extension to that. Not just giving the yield improvements, but what if we have an ML or AI tool which just takes a dirty layout? You have all the good patterns, good DRC patterns and everything in the layout, and spits out a GDS, which is DRC clean, right? I know it's a wishful thinking, but it's quite possible because it's all about pattern recognitions, and we have a lot of hooks into the tools, and that's an interesting area that EDA should definitely explore.
Excellent points, Venu and Umesh here. So I kind of want to ask the EDA tool vendors here. You heard very well from our product guys, and are you really doing anything in this area? Is there any research going on? Are you making any improvements on the physical verification side?
Maybe I can take that question, Venkata. So I think I'm really glad to hear all of these challenges, either in verification or physical design, or even in the yield, as Surya pointed out, Venu pointed out, because these are exactly the same problems Synopsys has been working on and solving it. Let me give you examples right now. But before that, let me step back. What we have found is there are definitely tool-specific improvements. So one angle is we have these optimizers for power, timing, and so on and so forth for each of the tools, like let's say placement, congestion optimization, and so on. Then we have the classifiers in terms of how instead of full chip Monte Carlo, I can do the localized Monte Carlo simulation, giving significant improvement. Just to quote Prime Shield, with ML-based Monte Carlo simulation is giving 150x times improvement. Significant improvement. In some cases, we have seen up to 445 times improvements from months to few hours. On the prime time side, we are doing the prediction. Similarly, on the entire design placement and so on, we are doing the prediction for, let's say, IR drop has been discussed, so I'll talk about that. So that's one area. So there are ML-based predictors, ML-based classifiers for binning, ML-based optimizers, and then there are also smart schedulers, which look at predict hardware resources and change the flow, optimize the flow appropriately. That's one class of the problem. But the second important class of the problem is not necessarily each point tool improvement is important, as the panelist really pointed out. It's the entire flow, end-to-end flow, that's important. And from that point of view, our design space exploration uses the reinforcement learning. And it looks at prediction, optimization, classification problems for all of the entire continuum to improve and predict in many cases. So let me give the three specific examples, three specific problems that came up in terms of our entire cycle flow and how we can potentially use ML AI. And I'm really glad that Venu, Surya, and Umesh, we brought it up, because these are the exact same problems we are tackling and have tackled. So first one was verification. How do I make sure that my test coverage is good, and at the same time, while making sure that the time to complete a test coverage is significantly lower. We have a tool called Intelligent Test Selection, basically ITS. What it does is it looks at the coverage data, learns from the past coverage data. When there are small changes in the design, it looks at only which part is changed, which are the corresponding test cases, predicts it, and runs only those kind of test cases. It has been already deployed at few customers, including at Intel, ITS, and they're seeing very, very good results. Second thing that came up is on the yield side. So on the yield side, we are handling both. One is the DFM part, that is how do we reduce the defects per million, plus how do we predict the defects. There's on top of that, we are also using ML to classify the defects, essentially to have the better analysis of the root cause. So we go back looking at the different classification algorithms, find out what is the root cause, and then use that root cause further down to predict again. The third thing that came up is IR drop. When you have absolutely hit the nail, because this is really, really important as the design sizes are increasing, as well as the design sizes are decreasing and the times are shrinking too. So in case of IR drop, the real challenge as we see is at the placement level, we have to have the right kind of prediction, because as we say, 10% of the ECO takes majority of the time of the design cycle. So we have introduced predictive IR drop at the placement level, at the routing level. But the real problem comes later. That is when I'm doing the STA and I'm doing the dynamic IR analysis. These are two different tools. And then I have to iterate manually, which creates a lot of problems. We have integrated both of these. Looking at the learning models from both and prediction, we have now the solution for integrated dynamic IR drops resolution. So this kind of actually looks at the entire flow, sees where the bottlenecks are, and exactly resolves this. So IR drop is one of the examples. Power is another example where we are using the prediction tool. Let me talk about the prime time. For example, on the sign-off, there was a question on sign-off too, right? So even on the sign-off side, by having the better prediction and optimization, we could reduce the design time for many of our design. Let me quote one design, which was 51 million gates. I think it was 5 nanometer design. We have seen almost 10x improvement by meeting the same goals of TNS PPA. So ML is already happening. ML is anywhere. And if I may take Venkata a minute, beyond these tools and tool flows, where ML is being used even outside in the case of business process optimization that Synopsys. For example, when there are enhancement requests that are coming in, or if there's a query on how do I use the tool, there's a database which goes through NLP, natural language processing, figures out, okay, which are the closest clusters that are there, and it provides the pointers to the person sitting at the other end to give them the most relevant answers. So I'm really glad that you have brought up Venu, Umesh, and Surya these challenges, because we are already having the solutions or coming up with better and better solutions. Yeah.
Thank you, Shekhar. Quickly before I go to the next topic, Sridhar, do you like to add anything here?
Sure, definitely. I think these are all very interesting discussion, right? I think, as Venu said, which reinforced my point, with this verification and backend is the biggest challenges, some of the biggest challenges, kind of, right? Definitely, I think we look at this problem as we have two sides. One is ML inside, which is on the tool level and algorithmic level. Our ML and data can go and improve it. The other is on the outside, which is on the flow level and then methodology level, kind of, right? That's the way we look at it, and then we do a lot of research and solve this problem. But one interesting point came up as I think Surya was mentioning is this left shift, right? Some of the things how we can do earlier in the flow or the correlation issues, right? For example, pre-route to post-route correlation. These are also the areas definitely we are looking how ML and some of these things can definitely help in bringing the correlation better, and then detect some of the predictability issues earlier in the flow, kind of, right? Definitely, there are a lot of things happening in EDA, especially, and then we do use the traditional algorithms also, but we use ML to turbocharge them to reach the final goals. That's how I see this, how ML and AI can benefiting in the EDA domain.
Thank you, Sridhar. So I will change the topic slightly here. Again, this is more like my imagination probably. See, when I started my career, most of the EDA tools we were using, we used to buy these very expensive Sun workstations, and most of the EDA tools used to run on them, and they became pretty much extinct right now. And as I understand, most of the EDA tools run on Linux workstations nowadays. And these Linux workstations are probably powered by the high-end CPUs from Intel and AMD type of processors. But right now, if you look at the industry, a lot of people, many startups developing these application-specific AI processors and addressing different challenges in different areas. Can we come up with any specific processors type of to address the EDA type of applications? For example, as we earlier discussed, we're talking about DRC, right? It's handling billions of transistors and billions of polygons here. Can we design any processors that are specific to EDA algorithms and to improve the turnaround times here and the efficiency? Maybe I'll address this to our product guys, the guys from Intel and AMD, who are always pushing the limits of their processors here. Surya, you want to go first?
Yeah, no, definitely. Yeah. We definitely want to design something that can design itself, right? So, so one of the biggest opportunities, right? Especially when it comes to the EDA ecosystem, is how well we use the volume of machines, right? So that's where I definitely see the work needs to happen from both sides, right? One is from the EDA side, where you probably have to relook at how the algorithms are written, so that they can be multi-threaded. They can effectively use the multi-processing, the cluster of machines sitting on cloud and stuff like that. Because today, right, that's computing is one of the bottlenecks, right? It looks trivial, but that is indeed the case. Where somewhere, I mean, one of the steps is like that Andal's law, right? One of the steps becomes a bottleneck. It prevents you from using your cluster of machines, right? That pretty much decides your turnaround time. Side, we have to see how these algorithms can be rewritten to take advantage of the multi-threads and the multi-processing. The other interesting thing is, if I look at the algorithms that we have, right, we can always see how we can add, let's say, additional instructions that kind of helps the AAML specific to EDAtions, and a lot of these AAML can be classified as graph computation problems, right? Although most of them are like Sridhar mentioned, right, adaptive and heuristic oriented. But with some tight collaboration between the EDA and the silicon design teams, we can certainly come up with some additional instructions that kind of speeds up overall AAML adoption.
Sure. Umesh, you like to add something here? Are you?
Yeah, very briefly. Yeah.
Looking at any processor specifically for this type of applications?
I may not be able to comment that on this forum, but definitely I think a lot of companies are benchmarking, and ML workloads are being optimized. And especially with our large data sets and based on what the ML algorithms are, right, as Surya touched, some of the things like deep learning can definitely be optimized with custom ML processors or AI processors, but yeah, it has to be tied into the algorithm so that to fully utilize it. But definitely with the large data sets and inference and deep learning algorithms, I think there is a lot of ML workloads can be optimized, and there are a lot of AI processors and workloads being worked on in different companies. And I think that.
Thank you, Umesh. And before we open open it to some audience questions, I like to have one quick question, and then we will go from there. So during my early career days, we used to see all these exciting EDA startups. We used to have these DAC, it used to be called Design Automation Conference, and they used to come and showcase their new tools, and ultimately they used to get acquired by one of these top companies, either Cadence, Mentor, or Synopsys. We haven't seen any exciting EDA startups, at least I'm not aware of, in the last 5-10 years. Let's say if you like to see a new EDA startup that's going to come and change the game here, what area do you really like to see that? I mean, what kind of opportunity you see for? So maybe I'll open this questions to everybody. Everybody can jump in and throw sure. few seconds here.
Yeah, Venkata, maybe I can jump in and also just take the previous question first. I think in your question, in the previous question, you talked about again this huge data, right? So I feel there is a need for a startup that can come up with an AI processor that is focused on graph, data, and handling. Because our VLSI and EDA is about actually manning huge graphs, right? There are a lot of polygons, a lot of transistors. So if there is an AI processor that is actually focused on the graph, data, and handling, I think that would be great. Now, I know that may not, I don't know whether it will come under that EDA startup category, but I would say we definitely need that one. But of course, one thing I must say is Synopsys and Cadence, they never let a startup that is exciting to continue for more than a couple of years. They just go and acquire.
Well, most of the startups, their goal may be to get acquired by them.
Yeah, I would like to add to that. So I think, yeah, the EDA market has been really challenging, but however, I think there are specific areas. So one of the things is there is, these ML models are always closed, and years of designs that design firms have, right? So a startup which can come up with a combination of taking multiple things is one area, which is, and the models are configurable, and if there are APIs for the design houses to tweak that, I think that's really an interesting place. And second, of course, looking forward, these ML models and VLSI, these models themselves for our database model could become, it could create an open source model where people could use ML models and keep improving on that, right? So that's an area where, something disruptive could definitely come.
So let me add a few points. So I think from the EDA perspective, if you look at it, the next big innovation, in my opinion, is going to be centered around data, right? If you look at it, the industry has evolved, right? We started with custom layouts, and then we moved to standard cell designs, kind of some automation, and then we had these tools and flows, complete flows, kind of, right? So the next big era is going to be centered around the data. So what I mean by this is, I think some of the people already mentioned, maybe a graph-based or whatever it is. Its data is to be the key part of the thing. The tools and solutions going to be sitting on top of this data as a services, And then the data, how do you represent this data, right? Those are the key challenges which needs some amount of research and solving in this area. So definitely those are the, I mean, that space is prime for a lot of innovation, in my opinion. Yep.
So from my point of view, I think this is a very good, interesting discussion. I'd like to hear the views. From my point of view, EDA traditionally have been used on-prem. We have a set of design, multiple designers, a large set of farms, people running it on the farms. That has been the model, and mostly that has continued. What is disrupting right now is this elasticity offered by cloud. Clouds is suddenly changing the game, which can reduce the time to results significantly. And if cost of the results can be also managed very well, there is a very good opportunity and potential for startup to come up with EDA usage onto the cloud. And there are a lot of niche areas. Today, most of the EDA tools are based around NFS-based data. We have talked about, Venu, Sridhar talked about data, right? This NFS-based data creates significant restrictions on the cloud. If people can come up, and there might be some research already going on, in terms of how do I have the traditional NFS to develop or traditional NFS to other storage components offered, like data lake and so on the cloud, and have only the incremental part going into the cloud. Because typically the longer times are because of the restriction of compute at the last fag end of the cycle. If there is a spurt that can be done seamlessly at much cheaper cost, looking at the spot instances offered by the cloud vendors, that can be a good disruption with relatively low investment without having to create a lot of new IP and so on for the startups. And Indian ecosystem can play a big role. Other area which has not been as successful is HLS, high level synthesis. That is also other area that is offering a lot of good potential with AI, ML, starting with C++ or System C and going into RTL has been dream for many years. To realize it, AI, ML can offer a really good potential. So I think these two areas in the startup ecosystem can be very good disruptions. And these are finite problems, bound problems. So those can be addressed.
Yeah, I believe there's huge scope, by the way, right, to develop some of these around the tool apps, right, using the DLRL, GNN techniques, stuff like an ML-driven optimal timing ECO generation, or ML or DL-driven DRC detection, DRC correction, right? ML-driven suggestions for fixing your FEV violations, or ML-driven suggestion for triaging your CLP violations. So there's huge scope. But the biggest bottleneck for all of this is data, right? The data is very critical. So that's where some of the bigger design teams, they need to play an active role in partnering with the startup ecosystem with proper data, right? And proper problem definitions, and work with them through the whole prototyping process for some of these startups to be successful.
So in the best interest of time, I will take a couple of questions from the audience. And one question is, do EDA companies need to collaborate with design companies to get the data, and what exactly they need from the design companies? How do you really collect the data? I think that's the high level question. This is for the EDA companies.
Sure. So definitely, I think the data needs to come from the design company and then maybe foundries also, right? So there is no doubt about it. So we have several partnerships with companies. Some of the, even when we research on some topics, early adoption, we work with some of our partners for the early adoption. That way we can validate it and all this kind of stuff, right? So I think the design companies plays a big role in any bringing up of marketing or productization of any EDA tools, along with the foundries also, right? Depends on which space it is working on. Sure, yeah.
So I think one more question I will take. It is, AI ML, how far can the AI ML in EDA tools can reduce the manual interference, and where are we now on this? can maybe Shekhar can answer this maybe?
Sure. I would probably repose this question instead of manual interference. I would say, how can we enable more the human interactions?
Yeah.
So we don't eliminate humans necessarily, but we enable the humans to derive better PPA in faster time. So I think the way this race is on, as I said in the beginning, some of the design challenges are humongous with the smaller nodes and bigger designs. So essentially, at the current stage of the curve where we have definitely introduced AI/ML. We are seeing the potential. There will be soon a stage where many of the things cannot just be done by human interaction. You can't do manual ECOs day after days, months after months, right? So there will be a phase very soon we see that the AI/ML can play a significant role in enabling human designers to reach their goals from months to days, and very soon it can be even hours. So I gave the example of AlphaGo. It was predicted that it would come in 2026. It actually came in 2016. So the whole technology is going very fast. So that day is not very far where human interactions with the designers can complete the designs within a matter of days and maybe hours.
Thank you, Shekhar. I think we are almost at the end of the time given to us, and we've been having very interesting discussions here. I like to add something here. See, we always have this love and hate. Our designers, love and hate relationships with EDA vendors. We keep complaining that the tools keep crashing and buggy and they charge too much money or whatever it is. But we all need to admit that the EDA tools play a very critical role in this semiconductor ecosystem. We thank you guys for all the innovation that's happening with the EDA industry, and helping us creating these next generation chips. And we love to collaborate with you, continue to work with you, and hopefully AI/ML can make these tools more efficient and more productive, but not more expensive. and with that, I thank you all. It is a wonderful panel, and great inputs from all of you. And hopefully we will interact again in the near future. Thank you so much.
Thank you, Akita, for giving the opportunity. It's particularly dear to me because ISA, I was part of founding committee many years back, and now it has evolved into such a wonderful organization, wonderful ecosystem. It's really a pleasure to be here.
Thank you. Thank you.
Thank you very much. Thanks, Venkata. Thanks for the opportunity.
Thank you, Venkata.
Bye-bye.
What a wonderful, panel discussion by some of the eminent speakers and the experts of Indian semiconductor industry. Thanks, Venkat, Surya, Venu, Sridhar, and Shekhar and Umesh. Thanks for your wonderful discussion. Thank you. So our next topic for today is a technical session on interplay of 5G and artificial intelligence enabling new user experiences by Mr. Satish Jamadgani. It's my pleasure to introduce Mr. Satish Jamadgani. He is currently the VP and Heads of Standards in Reliance Jio. He is also the Vice Chairman of TDSI, Telecommunications Standards Development Society of India. He has over 23 years of industry experience in telecom domain. He is active in 3GPP, GSMA and ORAN, open hardware and use cases. Earlier, he was also co-chair of Asia Region Operators Group, Small Cell Forum, and was on the board of the International Multimedia Teleconferencing Consortium, IMTC. He's currently leading a few 6G initiatives from Reliance Jio. He has around 200 granted patents in the wireless domain. Welcome, Satish, and over to you.
Hi, thanks a lot. Thanks a lot for the introduction. Can you hear me?
Yeah, I can hear you.
Okay. I'm just trying to make sure that my background changes. It's a bit of a tricky thing. Anyway, I'll share my screen then. Can you see my screen, please?
Yeah, we can see your screen. Go ahead.
So essentially, in order to understand the importance of AI in 5G, one of the key things that we will have to look at is there are different ways of looking at AI in 5G. One is, of course, the compute densities needed for 5G and our base stations. And obviously, in comparison to the previous generation of wireless access networks, the 5G network needs a lot of compute. And there are certain intrinsic AI nodes built into the 5G architecture as well. So that is also something that we can look at. The other thing is we look at AI processors, some of the new AI processors which are coming into the market from the point of view of compute density and the power efficiencies that they bring onto the table. And we'll just quickly see if there is a possibility of building a complete 5G base station with just AI processors. And of course, one has to really quantify what an AI processor is, because there's a lot of generic compute which is built into AI processors these days. And way forward, one of the key things that will have to be done to proliferate AI hardware or even software or a combination of hardware and software is to invest in standards. And that is one of the key things that we look at, both in terms of open compute hardware as well as specific hardware which is relevant for 5G base stations. And not necessarily just base stations, because AI is also is getting very, very important as far as the devices are concerned. In 5G, the notion of your device is not the phone anymore. Even a camera, a security camera, is also a 5G device but has a 5G backhaul. So there's a lot of AI processing which can be done within the so-called device. That is becoming the norm anyway. So, and that is also something that has to be taken into account. So we look at the typical densities, compute densities needed in a 5G network. You have the radio access network. In LTE, for a given 20 megahertz bandwidth, the typical throughput used to be around 100 Mbps. That's still on paper. So realistic throughputs are something in the range of 70 megahertz, 70 Mbps, megabits per second. That is the typical bandwidth we see. So that is the crunching power. That is the crunching power you need at the base station. Come to 5G, if we consider per sector 1 Gbps, being realistic, you can also go higher depending on the configuration. But then 1 Gbps per sector, 3 Gbps minimum per base station, per antenna tower that you see out there. And that translates to throughout the network. So you'll have an edge functionality. There's a lot of data which comes into the edge functionality. It also depends on how much of data is stored within the so-called edge entity, what we call as mobility edge compute entity. And then you have the core network, which will have both data processing. For example, most of the deep packet inspection is done at the core network. And that requires a lot of compute. Then you'll also have data storage in the edge, which is co-located with the core network. And there can be different distributed edge. So, I mean, you can have multiple of these servers. But essentially, this is just a rough figure of the amount of compute which is needed in a 5G network. Where does AI come into as far as 5G is concerned? One is this is the second day of the session, so obviously you must have heard a lot about AI being used heavily in data processing, primarily the cloud. That is one part of the story. I mean, I don't want to touch on that because that, I guess, would have been touched by multiple other speakers. So what happens within the 5G network? One is, of course, you have outside of the 5G network, there's a lot of data consumption which happens in a 5G network. So obviously data goes into a cloud, and you have a lot of AI which is used in the cloud for big data analytics. So there are two things. One is, when you look at AI, there are two problems which AI can solve. One is big data. It is intrinsically not paradoxical. It's just the volume of data is huge, so you cannot process. You need some kind of heuristics, and that's precisely where AI comes into the picture. The other one is intrinsic paradoxes that you may want to find within data sets. That is another aspect. So within a network, there is a lot of coordination. There's a lot of heuristics. There's a lot of forward-looking which is necessary to achieve optimization in the network, both in terms of resources, in terms of quality of experience for the end user, to manage quality of experience in the end user, quality of service as far as the network itself is concerned. There's a lot of automation which happens within the network, which can be assisted by AI. So there is a ton of AI which actually sits within the network. We are not even talking about big data analytics, even in the edge. We're talking very much within the radio access network. For example, if you want to do radio resource management, that means you want to predict how many number of users might hand over into a particular cell. You need some kind of a predictive algorithm running in the network, which of course takes into account a lot of the historical data into account. Scheduling is another problem. When you have multi-user, multi-application type data which is running in a 5G network, you need a good scheduler which will, of course, part predict and then reserve resources. Now, if it is not efficient, you end up with a suboptimal 5G network. Say, what would that translate to as far as the overall throughput is concerned? Where it was supposed to support 3 Gbps in a tower, you end up on an average seeing around 2 Gbps or 2.23 Gbps. And these are the kind of figures that we have seen. I mean, if you have a bad scheduler. A scheduler is an entity which actually allocates resources to the users on some kind of a fair algorithm, but there's no definition of what fairness is. That's precisely where much of AI comes into picture as far as 5G networks concerned. The need for AI is more in 5G than in the previous generation of wireless networks. Why? Because the heterogeneous nature of the applications that you find. You have small bursty data traffic which is going, which is typically your IoT kind of data. Then you have streaming data. Then you have file type data applications. Then you have web browser kind of applications which are downlink heavy, not necessarily uplink heavy. But then again, you also have a lot of these uplink heavy devices which can send huge amounts of data in bursts, and then they're silent for a long period of time. So you need to have some kind of a predictability on the nature of data which is expected to be running inside of a radio access network. That sort of gives you a leverage in terms of the kind of scheduling you can plan for. So these are all areas where AI is essential. It's not so much of a fancy need, but it's an essential part of the story. So this is one part of the story. I mean, a lot of this is, of course, proprietary. Vendors build some of these things into the base station that they offer. But there's also a certain amount of standardization which is going in, which is there is an entity called as Open Radio Access Network Consortium, which is trying to get as much information from the radio access network into a separate entity, which is called as Radio Intelligent Controller. It's called as RIC. And there are two parts to the story, which is near real-time RIC for whatever which is needed on a much more time-sensitive manner, and a non-real-time RIC, which is long-term, slightly longer-term heuristic analysis. In the sense, you have a bucket of data on which you can crunch or you can enforce certain algorithms. That's how it works. So this is an effort which is ongoing. primarily trying to pull all the data outside of the radio access network and try to do a lot of analytics and then feed back into the radio access network. That's one way of looking at things. But traditionally, most of the vendors keep this as a secret sauce. And that's precisely where they distinguish between one product to another product. So most of the operators, there is a lot of resistance towards what can be standardized, what cannot be standardized. But then it's just an eventuality that standardization is the way to go as far as AI is concerned. We're still not talking of what the AI algorithms are. It's still a platform where you suck in a lot of data into the so-called radio intelligent controller, and then you have your whatever AI algorithms. And based on the AI algorithms, you'll also appropriately choose the right hardware platform. So the general understanding of how we build the platform, hardware platform for the RIC is you have one part a generic compute platform, which is typically your x86 kind of a platform. Another one is you have accelerators, and of course neuromorphic processors as well as AI specifically. AI chips have a wide definition these days. And there's a lot of ARM cores which can also sit in AI processor. There are neural engines which sit. So there is, when you call something as the AI processor, it's a bit you have to really quantify it as to how much of generic compute versus how much of real so-called AI processing which can be afforded in the processor. So this is a very brief and a quick introduction of what AI will do in a 5G network. And this is still trying to optimize the network. All of AI usage is directed towards service management and orchestration. So for the well-being of the overall network itself. So the network is more worried about its own health. That's precisely where much of the AI is being used in a 5G network. Not so much that I can give AI to the external world for whatever the service, AI as a service and other things. There's a lot of stuff which is getting toyed around with, but this is essentially what it is. But we come to the core network of a 5G network. There again, 3GPP, which is the standardization body of 5G, defines something called as network data analytics function. So essentially, there's one part of AI which is going to be part of the radio access network. There's another entity which is defined to deal with core network issues. Again, from a core network perspective, you have a lot of these slightly longer term data patterns which come in, based on which you can run AI ML algorithms and then try to see as an example, quality of experience of a user. Based on the quality of experience of a user that you find out, you can do a lot of optimizations all the way around. So there is multiple other entities called as operations management. So you can also feed into the operations management as to what are the other optimizations you can do based on the analytics model that you run inside of an NWDAF entity. These are all standard defined entities. But obviously, any standardization will only define a platform. They will not try to define what is the algorithms that go into these stuff. Or at most, the data structures and the schemas which will need to be defined to exchange, half-baked data. That is one of the critical entities which is also underway as far as standardization is concerned. So this is as far as a rough approximate overview of. I'm not going into the cloud. Cloud is a different ballgame altogether. But I mean, of course, a lot of data, a lot of AI can be used in the big data analytics perspective in the cloud. Now, what is a big data? Big data can be anything. For example, in Geo, we have Geo Music, Geo TV, Geo, all kinds of Geo apps. They all have their own servers. They collect a lot of data, application data from that perspective. So there's a lot of analytics which can be run on top of those servers as well, which is, of course, it's slightly relatively well understood. But we come to the next part of the story as to if really AI has to flourish. One of the key things that I understand is there's a lot of AI startups. Now, most of them do silicon. new silicon. And if one has to consume the silicon, because just about every single company has their own specification of what an AI processor is these days. If you ask them, some have more compute density, some have more neural net processing entities. Some base their AI processor on data flow architecture. Some of them based on stochastic arrays. There are different architectures which can be used. So there is a whole bunch of AI processors out there, and not necessarily homogeneous. Not. So I mean, if you pick one, never compatible with the other one. So it's a bit of a new field still. So one of the ways in which, for example, small startups which are hard on cash can really encash some of their AI work, both in terms of software and hardware, is to go through standardization. Standardization is very critical. I mean, if you talk about software functionalities, then it's best that it is all addressed within the scope of 3GPP, within a standard framework. If you're talking about hardware, then there are other different bodies which you can really. But essentially, standardization is critical for the success of AI or wider usage of AI processors, both hardware and software. Software, it has its own issues. One is from an applicability point of view. One is the intrinsic nature of the AI software itself. In the sense, if I use a particular algorithm or whatever algorithms I might use, the output data has to be defined, or metadata or whatever, some of those schemas will have to be defined so that the half-baked or whatever semi-processed information can be consumed by different other entities of software. Unless and until that is done, everything is a proprietary solution out there, which the big guys only end up winning in such kind of a scenario. Small startups have no wider space. I mean, they play around for some time and then they all disappear. And that should not be the case, especially from an Indian perspective, because there are a lot of Indian startups, Indian-owned startups, which are focused on AI hardware. One of the key things that I have seen missing out by all these guys is that their emphasis on standardization is nothing. They go to individual vendors trying to sell their hardware. It then depends on who you know, what you know, how much of deep pockets you have. It all comes down to that. So a better approach is to push on the standardization front. It's a much more inexpensive way to get things done. So just to give you an example of what we mean by AI standardization, there's a lot of standardization which happens. AI as used in the general cloud scenario, big data analytics is very different from the way it is used for telecom. I'm just giving you specific examples where, for example, HC, which is European standards body, SDO, just like we have TSDSI in India, European Union has HC. They are equivalent to our TSDSI in India. Even in TSDSI, we are doing some of these work. So they are trying to define how AI can be used within certain specific use cases. Network slice management is one of the examples. What is a slice? Slice is some kind of a provisioning of resources, both hardware and software, dedicated for a specific use case. And it spans across end to end of the network. In the sense, there is a radio access network part entity of the slice, there is a core network part of the slice, and there is a management plane part of the slice, and etc. It's a complete dedicated resource given out to some party. And this was primarily envisaged to enable much of the verticals to come and integrate into the 5G network. So in order to manage that, the scalability, the elasticity of when do you need what kind of a load and all this stuff. There's a lot of predictability which is needed. So that's precisely where AI needs to be used, and that's precisely where some of the standardization is happening in terms of what data can go into a black box, which is an algorithm, and what data comes out of such a. And there are also metrics depending on the correctness of so-called algorithm and stuff like that. Just another example where there's something called a self-organizing network in 5G. The network manages itself to a very great extent. There's a lot of automation which comes into the network management aspect. So what we call a zero-touch network service management architecture. And there is an architecture defined. There's a lot of data points which are defined Essentially, again, this is a platform where you define all the data points or the data types which has to be sucked into one particular node. Then you can run your algorithms inside of such a particular entity. So these are all areas in 5G where AI finds use. Now, there is another aspect to it. This is sometime back, I was also toying around with this. Now, when we look at some of the AI processors which are coming out into the market, they are extremely dense in terms of compute. When you look at the normal CPUs, if you look at the traditional base stations, if you look at the processors which are picked to, I don't want to name companies, but if you look at the traditional processors which are used to make base stations, in this case, 5G base station, and if you look at some of the AI processors which are coming, these are very less numbers. I mean, you have 40 teraflops, petaflops. You have AI processors which claim all kinds of numbers, extraordinary numbers. So, and also power efficiency, which is good in a sense, because and at cost points which are ridiculous. They give you cost points which are amazing. Just to give you an example, if you look at there's one classic processor which is used to make base stations, which is from one of the most popular companies. The cost of the processor is about $5,000. It gives you about it's not even 1 teraflop. It is something less than a teraflop, and it's about $5,000 for the chip. And you have I was talking to another AI processing company. They give around 20 teraflops or something of kind, and the processor costs about $500. Less than that. So it's about 1/10. And the power efficiency is also extraordinarily different. So, we were tempted to see if we can build a 5G base station just using some of these new AI processors. It sounds very lucrative, and it is doable. On paper, at least, it is doable. The difficulty comes in heavy lifting the software optimization, and that is precisely where. And also, when we talk about AI processors, I mean, I've just given 2 examples of processors here. It all depends on how much of CPU you pack into the processor, into the SoC. How many cores of generic compute ARM processing you add up, and how much of whatever else you can add up. I mean, so these days processors vary. Somebody says ASIC, one ASIC is never the same as another ASIC. So even AI processing. So we were very tempted to build this entire 5G base station based on some of these new AI processors. It's amazing. It comes out if you look at the cost analysis, if you do the cost analysis, it's amazing. The only thing is the heavy lifting of the software. That's a very tough job. Somebody has to invest a lot of time and energy into it. But if that is done, 5G base stations can be had at extraordinarily competitive prices. So its time will come. So essentially, there's a lot more to just AI processors than just AI. That's the key point here. Talking of standards, I hardly see any effort in trying to push AI processors to sit as another additional module. Of course, you have some kind of a bus on which you can load another card, acceleration card, as an AI processor, but something built into the intrinsic blade architecture of something like an open compute program blade. If those are available, if it is built into the basic blade architecture of a OCP, then that becomes easier to be consumed, because obviously it also comes with a base definition of what the software is. Software is the key here. Of course, hardware standardization is one part of the story, but then software is also one of the key aspects. If that becomes available, if that can be done, then you can use these blade servers widely in 5G nodes to realize 5G nodes. I'm not talking about the radio, except for the radio, everything else, except for the raw radio nodes, the tower, everything else, what we call a distributed unit, centralized unit, which is the baseband processing. All of that can be achieved in an open hardware with a lot of AI headroom, which is available. Of course, even for data centers, I mean, if you can, otherwise today what happens is you take a basic OCP standard, hardware standard, you do a lot of customization to add some AI processor acceleration. And then obviously you also have to manage the software and other stuff, which is the tricky part. The hardware is one part of the story. But if the hardware itself is standardized, it becomes easier to standardize the software as well. So this is what it is. AI brings a lot of promise as far as 5G is concerned. There are certain entities in a 5G node, in a 5G network architecture, where we will anyway use AI processor, some kind of acceleration, both AI software or hardware. In some sense, it's coming in a big way. But the key thing is, if there is willingness to invest in the AI standards, both hardware and software, it becomes that much more easier to be used in 5G. One does not necessarily have to struggle that much more to get 5G and AI, which both have intrinsic value for each other. Nature of the 5G business is data, so obviously, and the bulk of data. I mean, it is not just a small amount of data; it's huge amount of data flowing in. So there is a lot of synergies. Which also requires a certain amount of AI processing. If not, one will anyway use AI more from a custom perspective. There are certain vendors who can give you better base stations with better AI processing algorithms, etc. Others get left out. This is the key message. So this is key. As much as we want to use AI in 5G, the more we see standardization of AI hardware and at least the base software, I'm not even talking about the algorithms, at least the base software should allow you to slice between generic compute and AI processor. Then it becomes virtual machine, which allows you to load share between the two appropriately. Then it becomes that much more easier to consume AI processors in a 5G network. And with that, I'm done. Thank you.
Thanks, Mr. Satish. There were a few questions. In the interest of the time, we can skip question, or one quick question I can take is, there is a perceived threat of 5G at airports, and that's why they have delayed the deployment of this 5G in airports in US. What is your take on it? Number one, and number two, can AI help to solve this problem in terms of early detection, or even solving any interference problems? Your take on that?
Yes. So the interference issues with airports or airline bans were specific to US. We don't have a problem in India. It depends on the allocation. The allocated 5G bands were very close to the aviation industry bans, and that is why US had an issue. It was a specific issue with respect to US, not anywhere else. We have not heard of that anywhere else. But I mean, that is resolved because they've come to some kind of an FCC has arranged some kind of an agreement where certain amounts of the edge bands will not be used by the 5G industry, and they'll also not transmit beyond a certain power if at all they use that particular segment. So they've come to some kind of a consensus. The second part of the story is, yes, of course, one of the big areas where we use AI is what is called as beamforming. Beamforming is one of the critical aspects which will lead to narrower beams to achieve groups of users, targeted users, which does not necessarily blast the airwaves across. It's not an omnidirectional. So that way you really can, if you have the right algorithms, AI algorithms to do the right amount of beamforming, that in itself intrinsically takes care of certain amount of interference mitigation, interference issues. The other side of the story is you can have a lot of this intelligence shared across multiple users if bands are very, very close. Inter-operator coordination also becomes that much more easier. It all depends. Again, subject to a certain amount of standardization. Standardization is still weak. It is still ongoing. But then from a utility perspective, yes, it is definitely there.
Okay. Thanks, Mr. Satish, for this wonderful and insightful session. Thanks a lot for joining us today. So that brings us to the grand finale technical topic of this session of IESA AI Summit 2022. The final topic for this session is a panel discussion on role of academia in research and talent development in AI ML by some of the eminent experts of academia and industry. I would like to introduce the chair for this panel discussion, Dr. Deepak Garg. And the panel includes Professor Alex P. James, Shrikant Sinha, Professor Rajat Muna, Dr. Chandrasekhar Buddha. It is my honor to introduce Dr. Garg. Mr. Garg is a director at NVIDIA Bennett Research Center on AI, Dean at International and Corporate Affairs, Bennett University, Director of Leading India.ai, Dean of School of Computer Science and Engineering, Bennett University. Dr. Garg is leading India's largest skilling and research initiative in AI with 700 institutional collaborators. He is the chief consultant for algorithmguru.in. He holds a PhD in efficient algorithm, chair IEEE Computer Society, India IEEE Education Society. To his credit, he has 120 plus publications with 1,500 citations and Google H-Index 18, delivered 300 plus invited talks and conducted 100 plus workshops, 15 plus conferences around the world, supervised 14 PhD and 35 students, blogger in Times of India, and called Breaking Shackles. What an achievement, what an incredible bio. Thanks, Dr. Garg, for joining us, and welcome, and over to you.
Thanks a lot, Srinivas. It is a pleasure to be part of this session, and I am proud to have this wonderful galaxy of people who are at top of their own area, who are part of our session. So I will request all our panelists to start their videos. So I will just give a brief that this session is about the role of academia in the development of AI in the country. So this is most important topic today because the progress of the country depends on how well qualified their human resources are, how a country is able to educate their youth in the latest technological directions. And that also takes care of the economics, that also takes care of innovation and how a country is going to lead in the community of nations in future. So previously, the revolutions that happened, whether it is green revolution, whether it is IT revolution, whether it is internet revolution, whether it is industrial revolution, in most of the cases, our country has been behind the curve. And we became a service economy to service the IP that was created by other nations. But now we want to change that curve as our nation is now going into a different gear, so that when this AI revolution is underway, so we want to be on top of it, and we want to become the knowledge capital of the world. So let me introduce our panelists. So on top we have Alex James. So Alex James received his PhD from Queensland Micro and Nanotechnology Centre, Griffith University, Brisbane, Australia. And he broadly works in the brain-inspired circuits, memoristic systems, analog circuits. And he is currently Professor of AI Hardware at Digital University, Kerala, and heads the AI Chip Center. So welcome, Alex, and it will be wonderful to hear about your thoughts. And now we have Shrikant Sinha, who is CEO of Telangana Academy for Skills and Knowledge, popularly known as TASK. So his major role is enhancing the employability for the youth in Telangana. So he is a kind of a role model who will give us the actual practical solutions which he has personally overseen while he is leading this task. So he is also Executive Council member of JNTU, one of India's leading university, and he is also part of Program Review and Support Group at PMG Disha. And so many other things, means his bio is full of achievements. So thanks a lot, Shrikant, for being part of the panel. And then we have none other than Professor Rajat Muna, who is Director of IIT Bhilai and basically Professor of Computer Science at IIT Kanpur. And he has also led the CDAC, which is Center for Development of Advanced Computing in the capacity of Director General. So he has wonderful experience and is a perfect fit for giving the audience the requisite bits in this particular panel. And then we have Buddha Chandrasekhar, Chief Coordinating Officer, AICT, Ministry of Education. So he is also leading a very innovative initiative of AICT, which is National Educational Alliance for Technology, and Internship Enterprise Portal, AI Language Translation Project, Indian Knowledge System, distributed 450 crore free digital content to higher education students, and so on and on. So he is kind of whatever AICT does, he is one of the prime persons who delivers that thing. So welcome Chandrasekhar Buddha. So without taking much time, I will now try to give the mic to each of my panelists. So I will request them to take few minutes to make the audience understand what they are doing in context of the title of the panel, and also means how to take it forward. And in detail, then we will have question answers with each of them. So let me start with Alex.
Thanks, Deepak. I think I have 2 minutes, right? So I'll try to briefly. The area that I work is on AI chips, which is kind of interdisciplinary in nature, where you look at neuroscience on one side, on other side you have computer science, and the other side you have chip design. So very often, what I find when taking a PhD student is their undergraduate education becomes more and more less of relevance when it comes to taking interdisciplinary, because more than their undergraduate education on the specializations they take, it's more about how well they are trained to solve a problem rather than looking at a knowledge in one particular domain. So to be able to see through a problem which is different from what they have faced. So someone had a student which was a biology major trying to build chips, and they were able to do that simply because they had that idea of problem solving. In the current role, what we do is we try to create programs, PhD programs as well as master programs, which are more interdisciplinary in nature, trying to focus on AI hardware and bring in all these different fields together and giving them a lot of hands-on experience around it. Yeah, I'll stop with that.
Okay, thank you, Alex. So means from last 5 years, I am working on AI as a software, as a tool. Means this is a kind of a new area for me also. Probably we will talk long time after that and we can connect. So nice. So Shrikant, please, your turn.
Thank you very much, Dr. Deepak Garg, and thank you organizers for inviting me to be part of this panel with such a galaxy of stars. I think if we look at everyone is a leading light in their own selves itself. So Deepak, what happened is a couple of years ago when Sophie had come to India, and I was talking to the creator of Sophie, and in fact, it was in Hyderabad itself. I said, if Dr. Alan Turing and Sophie were supposed to have a conversation, what will they be talking about? And David immediately turned around and said, endless possibilities. And that is what truly AI is able to bring out today, is the endless possibilities that our youth have today. Because all the revolutions that you spoke about, there was a single technology that was making a change. But today, when we look at the fourth industrial revolution, it's a host of technologies all working together to make the change. And that's really where AI is actually being looked at today. If we see today, and the power of AI, etc., everything has to be told, because most of our generation of learners today, 60% of them are first generation learners. So you have to help them understand what are the various potential, what is this technology, how it can be used. Most of the people always think that AI is only software. But what Dr. Alex was talking about, and the earlier session also where that was happening, is how hardware also, because I think AI could not have reached this potential today where it is today in case it was not supported by the growth of hardware. Today, AI is in everything, be it in personalized education that we are talking about. Again, AI plays a part. If you are talking about, in medicine, biotechnologies, everything, AI is playing a huge part. So what we are trying to do over here is ensuring that the youth of Telangana are aware about AI. Of course, everyone should be aware about it, but the engineering and computer science students, etc., should be able to dwell deep into it, understand what the various algorithms are, understand how they can use the potential of quantum computing for quantum machine learning, etc., and see how you can actually create your career in this domain. Today, when we talk about edtech, agri-tech, medtech, everywhere, AI is integrated into everything. And our main aim at task is how do you ensure that these people, and it is not only the youth, it is also the faculty members. So we run faculty development programs, we run student development programs, etc., on AI, so that they can help and understand the potential of AI and help unlock it in the interest of the state and the country.
Great. So I take two words from you, that is endless possibilities. And I am feeling jealous that whether the whole country can also use your services instead of only Telangana. Thank you. And now let us go to Professor Rajat Moona.
Thank you, Dr. Deepak Garg. It's a wonderful opportunity. And let me first of all thank all the organizers for taking this such a appropriate topic, especially in today's context. Now, at IIT Bhilai, that's where we are probably one of the first few institutes who have introduced this notion of artificial intelligence to be a separate discipline by itself at par with various other engineering disciplines, and do a full-fledged BTech, MTech, and PhD program. This we actually started doing about 2 years back, and we will have very soon our third batch coming in. At the same time, we also work with AICTE to define and design a model curriculum on AI and data science program, which again is now being propagated at all possible institutions, and they are free to actually introduce this. Now, having said that, AI is not something which is actually a very new thing. It is a technology which is several decades old. I mean, in fact, there was a book, I remember in my own student days in 1970s, there was a book written on artificial intelligence, a very primitive book compared to today's time, but the AI was born in 70s, not today. And it has been taught in almost all top universities in the curriculum of computer science as an elective course. So suddenly what happened? What change has come in so that everybody is talking about AI today, and what has actually brought it in the major forum? And that is the thing that we want to demystify. So it's basically, when people talk of artificial intelligence, suddenly to a non-believer, suddenly to a person who has not been introduced this concept, it thinks that somehow the machines are going to become intelligent and they are going to take the role of human beings in decision making and such kind of things. So I think it's a very important thing to demystify the artificial intelligence and what exactly it is, what are the techniques in it, and how AI can actually benefit people, whether it is in manufacturing sector, whether it's in agri sector, whether it's in marketing, whether it is in share markets, whether it is policy making, whether it's in health management, or as simple a thing as Google Maps, navigation systems. So I think we are all trying to actually introduce this today because very, very relevant in the technology sphere of today. So I think I'll be talking about more later. So over to you, Dr. Deepak.
Yeah, thank you, Professor Moona. So means there are one kind of people who are known as mystic and other as demystic, right? So you are kind of demystifier. So there are challenges like explainability of AI, whether data bias or human in the loop. So Professor Moona is known to demystify. He also solved different problems while he was at CDAC and then at other national committees of Government of India, and also looking after now how to improve our voting system and EVMs. So thanks a lot. Now let us go to Professor Chandrasekhar Buddha from AICT.
Good evening all. It's my pleasure to be here. As you know, under Make in India initiative, India has received 385 billion US dollars as an investments in last 8 years, which means India is going to be a global digital talent hub. As a government of India, our job is to empower the 7 crore higher education students and recent graduates to skill and upskill them and align them with the industries. That is the key for our, our ministry. So continuous upskilling is the driving force for making India as a global digital talent hub, mainly in the future technologies like artificial intelligence, machine learning, blockchain, IoT, data analytics, business intelligence, gamification, cloud, edge computing, etc. So we have taken various initiatives and we got 2 recent Guinness Book of World Records also on training and upskilling and skilling using using various trainings on the artificial intelligence and machine learning and gamification. So very soon we are coming up with training 1 crore students on various future technologies, which I will discuss in further discussion. So the thought process here is we want to make sure every student from India will have future technologies in handy, not only one, multiple future technologies, so that they can be empowered socially as well as economically, and they can get opportunities across the globe.
Okay, great. So once I was talking to AICT chairman, then he said that why he is able to bring this revolution, because he has team of people and he named like one of them like Chandrasekhar. So thank you very much joining us. So now let us go to the next round of questions from this panel. So I will first pick up Professor Moona. So the question means how we can realize the idea of making India a knowledge capital of AI and make the manpower available across the whole AI technology stack. So this is a very kind of huge challenge in front of the country and in front of the world. So how we can lead in this sector?
Thank you, Dr. Deepak. I think I will actually put 2 points. One, we are neither the originator of AI nor the consumer of AI. We are the consumer of AI applications. And that I think must be very amply and very rightly clear. We actually have been developing AI algorithms, and large number of Indians have been developing AI algorithms, but not necessarily within Indian domain. There are not too many Indian companies, not too many Indian researchers who are actually indulging into this. So now why am I saying this? Because your first question is that how can we actually be the knowledge capital? So I'm just trying to give a complexity, saying that we are virtually starting from being a user of AI application to be a knowledge capital and giving the technologies to the world. I think it's a very big jump, very big step that one has to take. Now, having said that, I want to put people back into this framework. In 80s, India was exactly not considered to be an IT workforce. It was a country of snake charmers and magicians, okay, to the rest of the world. And from there to today, when anybody looks at Indians and say, okay, you must be a software engineer, I think we have actually traveled quite a lot. So there is no reason why we cannot repeat the same story. And in order to create that story of computer science, we have actually looked at everybody has worked together, creating computer science curriculums, creating computer science programs in various colleges, creating computer science education systems, letting people go into various places, and serve as a knowledge service provider, and therefore developing applications. In fact, the biggest application that exposed India's capability to the world was Y2K problem, where over a few months, I think the rest of the computing infrastructure and software was changed drastically, to say nothing happened in Y2K. I think to a large extent, I must actually say the credit of this goes not to IITs and to NITs, but to AICT, which literally proliferated this education from IITs and NITs and other advanced institutes to every road and every corner of the country. So many organizations started offering MCA and such kind of programs. Is it required or not required today? That is not what I want to debate upon, but it is the context in AI where the same success story could be replicated. It will be required, if not today, 2 years down the line, in this major way, few years down the line in AI space also. We need a lot of people trained in AI, a lot of people trained in using AI, and a lot of people trained in developing AI. So in order to replicate the success story and be the knowledge capital, I think we have to invest a lot of effort in training our people. And by that time, India is actually a very interesting country. It's a country full of young population, young aspirations, young dreams. And these dreams can actually be realized by giving them proper tools, training, and that is the strength of the country. Creating India as a knowledge capital in AI space is a dream that can very easily be fulfilled if we actually do right in the policy making, in proliferating the education, and exposing ourselves that we are a force to reckon with in the space of AI. And I'm sure 10 years down the line, people will not know India by AI, by computer science, but by saying that these people are actually known for the AI applications, okay, and AI knowledge. So this is, in my opinion, the way we can actually do this. And everybody has to come together. IITs, NITs, various other educational institutes, lot of educationists, lot of industries, and AICT. And I think this is the forum where you have brought in everybody together. So this is the right way of doing things. Maybe we can accelerate it even further by doing many such activities.
Great. So I think very good. So what Professor Muna is saying, that we have to do a collective effort. So that's what our Prime Minister also say, कि 130 crore जनता को साथ लेके चलना है. So means everybody will do their own task. AICT will do their own work, academicians their own work, scientists, industrialists, startup founders. So everybody has to pull up their socks and work towards this knowledge economy of AI. Okay, so thank you, Professor Muna, for wonderful words. Professor Alex, the question to you is that AI is now not only a tool or algorithm, like all of you have already said, but it is also encompassing hardware devices. And India has just started taking steps towards chip making and other things. So what do you think that should be the way forward for the country to realize this in terms of manpower and industry?
Yeah, I think Professor Mona has raised very interesting points and very valid points, and those are, I believe, the happy things. But when it comes to the hardware guys, what happens is we are often in the situation where the more compute happens, more pain we have in the hardware. So the complexity of the chips, the kind of hardware infrastructure that is required, that needs to be improved at a pace that is not seen before. So just to put things in context, if you look at in 2003, 2004, that's when we have 90 nanometer transistors. And by 2004, you're looking at 5-10 years down the line, It's 40 nanometer, and now we are talking about 5 nanometer. So what has happened during this time, look at the AI literature. If you simply like map it to the AI literature, as and when the scaling has happened, in the last 5-10 years, the amount of literature around AI has shot up like exponential level. And why that has happened is because like when you scale up the transistors, scale down the transistors, create like a lot of computing resources, you can do more and more applications, more and more things can be tried out, which was not possible before that, when the scaling was kind of stagnated for many years. And today what we are looking at, like the future of computing, from a hardware perspective, we have CPUs, we have GPUs, which in a CMOS context, like, it is hitting like the heat wall. We have limits of the Moore's law coming into picture. We have the memory wall coming into picture, which is driving us to think about like alternative ways of computing, like in-memory computing, neuromorphic computing. We are thinking about like quantum and all those things because of these issues surrounding like the scaling. And if you are trying to compare like the hardware itself, like say if it's a CPU centric or ASIC centric, we can also think about neuromorphic centric approach. And if you try to divide this as cloud and edge, if you look at GPU centric computing, you cannot put a GPU for training on a edge. This is not going to be a good idea because the power consumption and many other things like, won't help there. Whereas for inference, this may be okay. And same thing with ASIC. ASIC is also great, but when it comes to using it for edge, this is still like not as power efficient as it should be. So that's where like the neuromorphic related technologies, which are kind of pushing the boundaries of power margins, trying to really push it down, comes into picture. People spend a lot of time trying to study like the spiking networks and other, looking at the possibility of translating that to the hardware. In a way, the effort there is to bring those intelligent to all the devices, like whether it's a low power device or whether it's like a high power devices, which can be enabled by the cloud. And now a related thing is when you do this, like, when we go to the alternative kind of like computing, whether it's neuromorphic or we do like a mixed signal processing in memory computing and all those things, which are happening at the chip level, we are looking at a knowledge that is often interdisciplinary. It's not longer good that someone is trained in digital VLSI and that is enough. You also need to have an understanding about like how the sensor systems are going to work. You also need like an understanding of analog systems. So mixed signal systems become kind of like an important thing to look at. Power becomes kind of like a very important aspect, how to create systems that are power and energy efficient. That's again not just a one way approach, like where we go with the one human architecture. We are looking at like all the other different types of architecture which can be like implemented. Then again, like in digital systems, very often like we don't like stochasticity. When it comes to many of these alternative approaches like that we are trying to do today, stochastic like computing becomes like a very interesting and useful thing, which fundamentally goes and changes the architecture of many of these devices. And I think like in the previous, like before our panel discussion, the speaker was talking about standardization of AI. In fact, like the kind of AI he's talking about is narrow AI. So if you are having to move from narrow AI to like a general AI, then the kind of hardware that you need, again, is like another set of open-ended like discussions and things that are yet to happen. So there is a lot of areas to grow. And with the introduction of foundries and semiconductors in India, this is what I think would change, that we will have like an ecosystem. We could build an ecosystem where we could like enable those. we could create like all those like emerging areas within the country. Today, if you want to build a chip, go for example, 7 nanometer, we have to rely on like those foundries which are outside, and this is not as straightforward as like one would think to move a design from something like 90 nanometer to 7 nanometer and get it work, because then you're considering not just the scaling, you are also looking at like changes in the architecture that is required, and the whole ecosystem around it, whether it's like the embedded layer or whether it's like the kind of applications that can stem out of it. All of those things matter. So in short, like I think the foundries are definitely like a way to go ahead if you were to really go into the emerging part of the AI, and not just look at like AI as like being an end user of AI, but actually like creating different forms of AI from the hardware to the software. So I think that's it from my side.
Thank you, Professor. Alex has brought home the point that how important it is to have people working in the niche areas of AI. Because when we speak to many institutions, if their students just download some code from GitHub and run an AI model and say that, oh, we have got this kind of accuracy, and they feel now we are AI expert. So our institutions, their assignments, their courses need to evolve so that we have people working in core research areas of AI. So thank you, Professor Alex. Now we have Chandrasekhar from AICT. So how GUI is building the skilling ecosystem and planning to upgrade the country as a leader in the future technologies?
Thank you, Deepak ji, for a very interesting question. And I would like to thank Rajat Monaji for recognizing our efforts. And the thought process of Ministry of Education is that to provide the best of the best to our students, industry, institutes, as well as our faculty. So we are keep on working on that. And having said that, as there is an increasing number of businesses and sectors are adopting newest technologies such as artificial intelligence. I mean, it becoming the demand of AI professionals are becoming skyrocketing. I'm talking from a software point of view, not from a hardware point of view. But most of the professionals, they want to write the AI-based algorithms and trying things out. I think this is where the government of India acknowledge the need for skilling and upskilling in the field of AI and launched various initiatives in last 5 years. As you know, India is the world's largest community of developers. I mean, recently I was going through one of the GitHub article. Now we have more than 5 lakh plus recognized developers. And if you count the student as well as the faculty community, we have more than 5 million community within our country itself. And if you count the global count of Indians, including NRIs, it is somewhere around 2 million. I think, these are like huge numbers. And large startup ecosystem is also built in our country. So it is all helping together along with the strong scientific and engineering culture we have. We are very strong in maths and science. I think these all are helping because, the AI needs all these ingredients, which was already ready inbuilt in our DNA. So that is where, the resources point of view. But from the government point of view, I would like to remind that in 2019 budget, if you all recollect, the Honorable Finance Minister Nirmala Sitaramji said the government would offer industry relevant skill training for 10 million youth in India in technologies like artificial intelligence, big data, and robotics. I mean, the government identified and understood the importance of skilling and upskilling of all our students and the recent graduates. At the same time, if you see, the Indian government outlaid for Digital India to 477 million to boost AI, IoT, big data based, cyber security, machine learning, and robotics related projects. And that is not only to promote the e-governance, e-banking, e-education, e-health, etc. But we want to do more. Like example, recently we have taken initiative like NDR, where we want to digitize the entire educational institute and the systems. So I think, this kind of initiatives will happen, and we are planning to create a decision-making models out of it with help of the advanced AI, deep learning tools and NLPs. And as you know, recently we come up with one tool on the artificial intelligence where we translate the English books into 12 Indian languages using the GPT-3.5. GPT-3.5. So this kind of a models we are coming up with, and the entire student progress is getting monitored and evaluated using artificial intelligence systems. And digital e-governance, of course, the government is promoting digital e-banking, digital healthcare systems, the biometric identification, facial recognition, criminal investigation. I think, huge opportunities, including the digital agriculture. Recently, when I visited one small village, I was amazed. They are doing agriculture using drones, that too a small, very small remote village. I was amazed the kind of a technology adaptation we have in our country. So I'm so happy that the students are trying out on the real field. And recently we even come up with a proposal where we are going to clean the rivers. But instead of how we will clean the river, we are going to use advanced AI technologies to understand, and then we are going to propose a solution how to clean, what to clean, where to clean, and what is the depth of that particular river, how to use the different techniques, what kind of chemicals were involved in the water. Huge opportunities are going across through, and I'm happy to see that the Indian government come up with the artificial intelligence task force. As you all know that, they have identified 10 sectors of which is very relevance of AI, like manufacturing, because the industry 4.0 is going to occupy the entire global market. I think this is an opportunity for India to become a manufacturing hub. So manufacturing is one of the related sector, finance, technology, or fintech, what we call it as agriculture, healthcare, technology for differently abled, national security side, environment side, public utility services, retail, customer relationship, on education, of course. So various entities. Recently we started even, using the artificial intelligence technology in order to distribute our scholarships as well as the research material. I think, we are using it in a very advanced way. And at the same time, we are trying to even, take things on a research and development oriented, because the national education policy is more concentrated on developing and delivering more researchers, more innovators, more startups and entrepreneurs. So we are even utilizing the Center for Artificial Intelligence Center of Excellences. Because if you remember, sir, recently India and US, they all, along with there is some organization called Indo-US Science and Technology Forum. They launched a flagship program where we are going to work with the US government and as well as, US firms to share the ideas, experiences, and identifying new opportunities in AI research and development. So what we are doing is we are basically translating all these initiatives into a meaningful problem statements, for our students and recent graduates. And we are requesting and, we are pushing them to take it forward. At the same time, we have a National Research Foundation, which is part of National Education Policy, where we are boosting the research, which includes the artificial intelligence, and the 50,000 crores is what we allocated on the National Research Foundation. And the majority will go for a higher future technologies. So at the same time, I would like to, just close with one particular statement, because everyone say that AI is nothing but artificial intelligence, but I see AI as a advanced India, that's what I see. Because example, if you see the limited memory or theory of mind, narrow intelligence or general intelligence, super intelligence, I think, the students are differentiating, they are understanding, how this technology works, and they are taking it forward. So I thank everyone for giving this opportunity. And one last thing that we are, we are coming up with a program called Teaching ABCDs to Higher Education Students. That is nothing but A for artificial intelligence, B for blockchain, C for cyber security, D for data analytics, etc. I think, this is kind of a programs which we are planning to do it for 1 crore. So imagine the students now just finishing their, their semester. So they are free for next 2 months. We are providing them 3 months extensive training to 1 crore students. so that we are ready to create 1 crore digital workforce for our country. Thank you very much for giving time. Thank you.
Thank you. I think great words. Mr. Buddha forgot to tell one thing, that AICT, first 2 words are also AI. So, and also means when I hear so many initiatives of AICT, sometimes I feel means what they are doing means whether they are needed. Then when we see at the heterogeneity and the whole spectrum of the country in terms of inequality, then we feel that, oh, all these are very necessary initiatives. So thanks a lot.
Thank you. Yeah, let's all work together as a team and take our country forward. Thank you very much.
Yeah, so now we have Mr. Shrikant. So I don't know what question to ask him. Means I will ask him that what are the transformative characteristics of tasks, so that similar things, similar initiatives people can think of, and we can transform our country with AI.
I think today, if you look at it, it's become very, very important for, of course, as was mentioned earlier, people have to skill, upskill and reskill. Second thing, if you look at it today, we are not doing enough research in our institutions. I think that needs a focus, especially on AI, etc. A lot of research needs to be done. But having said that, the industry doesn't have time to wait for the academic institutions to do the research. Industry do their own research. But what we are able to offer in terms of accelerated research is in terms of hackathons. I think that is where you can actually bring in industry-related problems, bring it down to the students, the youngsters who have got a fertile mind, who have understood about AI, who have got the knowledge, at least the basics. They will talk about the Forester's methods, the the regression methods, etc., and try to come up with solutions. But what is also important over there is that they get mentored by the academic institution people plus the industry, and that is where I feel that as it's the best combination where a student can actually learn and practice what he's learning, get mentored both by academy plus also by industry, so that he comes up with real life solutions. I think that is what is very, very crucial. So more and more hackathons needs to be done across, and hackathons which are actually solving problems. I think the best part with us is compared to any other country across the world is we don't need to move out of our environment to come across problems. There are a whole lot of problems today, right? We spoke about problems of persons with disabilities. We talk about persons, different kind of problems exist. And all problems have got solutions if we apply our minds to it. AI is probably going to be the game changer, be it in any field. We were able to come up with a vaccine normally used to take 7 to 10 years. But if you talk to the people across various organizations, be it CCMB or Bharat Biotech or others, they will talk about only one thing, how AI-powered technology was used. You had the big data, you did analysis, but machine learning, predictive analysis, etc., everything was being used over there. What we are doing over here in Telangana is, of course, we have the Center of Excellence called TAIM, which is Telangana Artificial Intelligence Mission, which is housed over here itself, which is a collaboration between the Telangana government and NASSCOM, which is the national trade body for IT organizations, etc. So we work very closely with them. Our main aim is to ensure more and more students, more and more faculty members are aware about AI. So we do FDPs, SDPs, as I already said. We also do hackathons. A lot of hackathons, etc., are being promoted over here so that research component, etc., comes in. Just to give you a small example, one of our institutions, some of the students of engineering actually created a facial recognition system which can be used by the the ration shops, so that they can automatically give you the right amount of ration itself. Now just imagine a simple concept which earlier used to be only yes or no, a logic-based thing. Then it became fuzzy logic, then it became rule-based. And now, thanks to technology, AI has reached where automatically, machines are learning themselves through the algorithms. And that is where I think citizen services in Telangana, if I look at it in particular, the citizenship services that are being run over here, right? Be it in terms of validation of people who have reached a particular age, or in terms of various citizenship services. A lot of AI is being used over there. And today, our focus mainly is how can you combine these technologies together using AI as the powering engine. So probably AI would be the engine behind the whole thing, where other technologies come in, be it 5G, be it IoT, be it various other technologies, but the microcosm can only happen if AI and ML is the core. And that is where we feel that India can make a difference. Of course, as everyone has been saying over here, everyone needs to work together towards it. I think I would like to end by saying that it's high time that we had a program called Mechatronics, right? Today, when you look at it, everything has to be multidisciplinary. People have to come in together. A bioscience person has to work with an AI person today. I'm happy to say that as part of JNTU, we have started a program where, of course, AICT has given the concept of major and minor, but we have said a civil engineering student can also pick up artificial intelligence as a minor, because that's how future is going to be. And that's where I think, multidisciplinary, these kind of approaches have to be used, more of hands-on application. Of course, apprenticeship, internships have to be the order of the day, so that our engineers no longer only know the definition of a screwdriver or definition of various AI algorithms, but actually have used one and implemented them.
Great words, Shrikant. So I did a survey of my exiting students, and the thing they remember most was the hackathon, in which they were kind of in the night also sleeping on the floor in our big hall. So working on some problem. So means they want to do things. They don't want to listen the lectures. So lectures are available on YouTube anyway. So thanks a lot for your inputs. And I think the whole panel has given tremendous points, and if they are implemented, brought into action, so India will be definitely a knowledge capital, what Professor Rajat said initially. So I will give back to Srinivas if there are 2 or 3 questions from the audience.
Yes, thanks, Dr. Garg. There are a bunch of questions. I'll take the luxury of asking my question. So I was very attentively listening to all the discussions, very insightful discussions. So we talked a lot about creating this AI talent and AI, workforce for our country. My question is, we as a country, what can we do to convert this AI talent into our AI entrepreneurs?
Okay, so I will give this to Shrikant probably.
Sure. I think today what is most important is, and that's where the difference will be, because we should not end up being a society only of job seekers. We should also be job givers. And that's where I think the difference is. We need to ensure that in every curriculum across, today, the biggest challenge is when you go to a technical institution, you will find people with an Arduino board, you'll have people with sensors, and they would have put the technologies together and done. Now they start looking at problems. We need to put problems first, then create solutions for it. And that's the mindset that we should create in our students. If we are able to do that, just to give you a small example, we ran a program called as I4TS, which in Telugu, and the punchline over there was Samajika Avishkarnulu Sarlamaina Jivitanki, simplifying lives through social innovations. And that's exactly what it was. How do you solve basic social problems by innovating and trying entrepreneurship? So we had about 8,000 plus students being impacted through this program. So I think today it's important for us to bring these things, incubators. Everyone has used the TechWhip fund to put up incubators and labs. We need to change and bring the mindset of the professors moving in that direction, so that we get better and better people coming out. And government should support this. For example, I just took that example of that ration shop thing. The best part was our principal secretary, honorable principal secretary, was there when this was being displayed, and immediately called the Commissioner of Citizen Services and said, can we look at this, and is this something that the government can support? And that's where I think we need to encourage these people. Just being a talent pool to entrepreneurs who can further create opportunities for more and more talent pool.
Right.
Over to you, Dr. Buddha.
Yeah, so we have set up a philosophy at our institution that industry needs us. We don't need industry. So if we have that mindset, then we will prepare accordingly and they will come back to us. Probably I will
I just want to add one point, Deepak Ji and Srinivas Ji here. See, till now, the old education policy is more on the rote methodology. So we used to mug up. Okay, now we translated this into a outcome-based education. So I will give you a best example. Someone is watching this webinar. After this webinar, they will, they must answer few questions. What is the outcome? What is that you learned? Can you do it in a different model? Why, how, who? So what happens in Telugu, enduku eviti ela? So we have added this ingredient into this outcome-based approach now. So the National Education Policy 2020 is a major paradigm shift. I mean, trust me, if given opportunity, I want to go back to the college and study once again, because now it's a real fun, because you will understand, you will learn, you will experiment. I have no other option than a student than give up 10 to 15 case studies, saying that where I can use this in a real-time scenario. So what happens is it will open up your brain, it will connect your left and right brain. Your creative thought process will increase. The minute your creative thought process will increase, your entrepreneurship, your innovation, your research in your mindset will come out. So till now, our old policy was made us as a workers, which is also one way maybe good. So now we have opened up this. I'm sure we will generate more entrepreneurs in future.
Thank you. Srinivas, next question.
Yeah, I think there are many questions. In the interest of time, I'll take one more question. In fact, two questions, because two attendees have asked.
And maybe combine both of them.
Yeah. So basically, it says, when are we going to have separate department of AI and ML in IITs? And then second person attendee asks, any plans of making AI ML as a mainstream program in engineering education?
Yeah, I hope
Professor
that is,
Moona probably
that
can take this up.
towards,
Let Professor Moona take it up.
I think it's a very interesting question. The shift has already started happening. IIT Hyderabad actually created a first program of AI in BTech. IIT Bhilai created the second program among all IITs on data science and AI. And in fact, now many other IITs, Jodhpur and various other IITs have actually already started creating these programs. I think in few years' time, we'll probably see this as a mainstream program. And in fact, the choices of students to take this program is also very encouraging. At IIT Bhilai, the AI and data science program was the first choice of students, both in terms of opening and closing ranks. It is no longer the computer science. And that's a very, very different paradigm that we are, a very, very different era that we are getting into now. So coming to this question that when will we see? We are already started seeing AI, machine learning, deep learning, and data science, all these four areas becoming the mainstream education programs in IITs. In AICT is also taken the cognizance of this and has already worked out a model curriculum and already enabled various educational institutes all across the country to start AI ML, or they call it AIDS, AI and Data Science program, in various places. And I think about 1.5 years back, they publicized it. And today, already several private institutes have already started opening up BTech in AI and data science programs. So this is actually already happening.
Okay, great. So thank you very much. Yeah, Mr. Buddha, you want to add a point?
I just want to add one thing. See, the national education policy as a, it's a agile in nature, sir. So we are ready if something new is coming up, we are ready to adapt. So that is the beauty of the national education policy. The second thing is, as you know now, then one student, let's say he is from commerce, but he can take up AI. So we have given, I don't want to put it in technical terms, but, if I'm interested on, I'm an engineer, but I'm interested on a social science, I can take it up. So that kind of a model is what we are creating. So in this model, everyone is eligible to learn the future technologies like AI, ML, as well as, blockchain technologies, cyber technologies, etc. So this is kind of a model will definitely take our country forward, and everyone will be part of artificial intelligence, from technology point of view.
Yeah, Srinivas, you will like to conclude?
Yeah, sure. I think I would like to add a statement. I remember Telangana said 2020 was a AI year of Telangana state. And I remember, Mr. Jayesh Ranjan is also Vice Chancellor for JNTU. And he had mentioned that no matter what discipline of degree you have, whether it's commerce or arts, everybody should take AI and ML subject as a mandatory, right? So I think that's a great initiative by government, country, and all of us from academia and industry. That's all. That we do not have any more questions, and thanks a lot for all your time. Thanks, Dr. Garg, Professor Alex James, Mr. Shrikant Sinha, Professor Rajat Mona, and Dr. Chandrasekhar Buddha. It was a very, very wonderful session. Thanks a lot. Thanks to everyone.
Thank you very much.
Thank you very much.
Thank you. Pleasure.
With this, we conclude all the technical topics and discussions of IESA AI Summit 2022. It was a wonderful summit. It was great 2 days of outstanding, fruitful, and knowledge-filled sessions throughout. Thanks to all the attendees. Now I would like to invite Mr. Srinivas Raju on stage to address the valedictory session. I'd like to introduce Mr. Srinivas Raju. Srinivas Raju is CEO of Pi Square Technologies and part of core team of IESA Hyderabad chapter. He is also the chair of IESA AI Summit 2022. He is the man who drove this whole summit from front. He was an example of leading from front. He comes with over 2 decades of diversified experience across telecom, IT, semiconductor, education, automotive sectors, with demonstrated leadership in developing strategies. Welcome, Srinivas, and thanks everyone again.
Hi, very good evening to all of you. I take the privilege to deliver this valedictory address. After the grand success of AI Summit 2021, the core team had to put together great content, good speaker lineup for AI Summit 2022. It has been very insightful 2 days with 27 sessions and over 50 plus esteemed speakers addressed on how AI is impacting spectrum of areas, including semicon, chip design, manufacturing, future of computing, security and user experience in fintech industry, data and cybersecurity, automotive industry, healthcare and medical technologies, robotics and industrial automation, telecom, and it's evident from all the discussion, AI cuts across all the sectors and all the technology areas. And the use cases are many. Apart from deliberations on future and technology, there were also discussions on responsible use of AI and discussions on how AI R&D and talent development and the steps to be taken by both government, education institutions, and the industry to develop this talent to get the AI growth going. It would not have been possible to organize the summit at this scale without the support of all the key stakeholders. Over the last few months, entire team has been working hard to design the summit. I request all the hosts to switch on the cameras of all the core members who's been part of this activity. Krishna ji, I think you have to remove the background, Satish and team.
Yeah.
I think we should remove the background. Background will remove.
Yeah, just remove the background. Otherwise, the background is missing.
Just blur it a bit, or don't put anything. Should be better.
Yes. Remove it. Just don't put anything. Yeah.
Yeah.
I would like to firstly thank the IESA leadership team, Mr. Venkata Simhadri, the chair, IESA Hyderabad chapter, Vivek Tyagiji, chairman, IESA, Mr. Krishnamurthy, president and CEO, IESA, and other executive council members for their support and guidance. I would like to thank our program team led by Srinivas Bairi. Srinivas Bairi Intel, supported by Mr. Ajay Naini, MP, and Mr. Shashi Reddy from Qualcomm, Kamal Jain from Blaze, Sridevi Reddy from Zelpmoc, Chitra from Intel, Pradeep Vajram from Alpha ICs, Bhavna Sethi from Micron, Vikram Labe from Phytron, Muthu Krishnan, Safal Incubator, and Swami Rinki from Moschip. I think you can understand the quality of the content that the team has put together across this 27 session. The program team is responsible. I think under the leadership of Venkataji, I think we all work to bring in the best speakers across the globe, and all the team have actively contributed. And I would like all of you to give a big round of applause for all the program committee team members. I would like to extend my thanks to our marketing and logistic team led by Mr. Satish. Satish is supported, Satish from QuickCore Technologies. He's supported by Mustaq from Moschip and Sunil Acharya from IESA, Sophia from IESA, Abhinav Jain from Blaze, Hariom from Intel, Swami, Mahesh, and Uttam from Pi Square Technologies. I know how this team has worked in the last 6 to 7 weeks. I think it's become like a full-time job for marketing and logistics team. And I think an event of this scale, putting together logistics and outreach program, I can understand. A big round of applause to all the marketing and logistics team members. I would like to thank the sponsorship team led by Davinder. Davinder from IESA, supported by Sunil IESA and the IESA leadership team and other core team members who supported in getting the partners onboarded, the sponsors onboarded for this event. I would like to thank all the esteemed speakers and more importantly, all the moderators who have taken the lead to steer the panel discussions. I think without them, I think we wouldn't have had such insightful discussions. I think you would have seen the speaker lineup. I think all of them have been leaders or senior executives in their respective companies and have taken time to prepare content and share their thoughts on the given topics. Once again, thank all the speakers and moderators for taking time and sharing your thoughts on the forum like this. Thank you very much. I would like to extend my thanks to our PR team and the media partners for covering the event. And also, more importantly, I think the support from our sponsors, Micron, Ignitarium, Qualcomm, Indie Semiconductors, Moschip, AMD, Cadence, and BrainChip. Thank you all for your support and association with this summit. We really acknowledge the support that you extended in sponsoring this event. And more importantly, I think the key is all the attendees and their active participation across multiple channels, both on the platform and also on the YouTube streaming and also on the LinkedIn streaming platforms. And we will also share this content on YouTube channels and send it across to a few of them who could not manage to attend. And because of the time zone issues from different countries. I think this content will be made available to all of you. I personally thank Mr. Venkata and the Moschip team for extending all the support for hosting this summit. In fact, we have been well taken care by the Moschip team, and all of us have been hosting the event from here. Thank you, Venkataji, and your team for all the support that you've extended to us. AI Summit is an initiative from IESA Hyderabad chapter. It has become one of the signature events of IESA. With the grand success of this edition, and the bar is set high for the next edition. And I think we're all already started thinking what to do and how grand, how big we need to do for the next AI Summit 2023. Looking forward to have the next edition probably in a physical format. I think we'll have much more engaging and insightful sessions the next year. Till then, we will continue to with our efforts of our knowledge sharing web series. We will shortly announce our next set of knowledge sharing webinar series, as a precursor to the event. So till then, goodbye, and thank you once again, all the committee members for their effort, because of is apart from the regular activities, they have to put together an additional time to host a program like this. Thank you very much, and goodbye, and see you on the next event. Thank you very much.
Krishna here, Srinivas.
Sir, please.
Maybe I'm talking out of turn because I'm on the roads.
Please,
and I couldn't really hear when you prompted earlier. The connection was not good, but I hope you're able to hear me now.
Yes.
All that I want to say in the next 30 seconds is that this AI Summit has been organized and executed absolutely flawlessly by the team. And of course, leadership of Akita is there. But more than that, the entire team who worked on making this happen. And the last two summits have proven that what a chapter can do. So I'm just trying to advertise this summit not only as a successful summit that you were able to arrange or organize, but also what a chapter can do all by themselves when they put their mind to it. And from on behalf of IESA, I would like to say a big thank you to all of you. I don't want to name all of them because Srinivas has already gone through that, but it's suffice to say that you have done a wonderful work to pull this off under difficult circumstances. I was a little worried, honestly to say, when the Semicon India conference came right in the middle after we deferred it by a month, and a lot of attention and energy was getting diverted to that. I was really getting worried whether we will have the bandwidth and time to make this happen, but the way the Hyderabad chapter embraced this conference and pulled it off, hats off to you guys. And so next time, I don't think we need to do anything from the IESA Secretariat. The bar has been set that you will be able to do it all by yourself. I'm just joking, but wonderful execution, absolutely flawless. And I was very, very surprised that pleasantly surprised, so to say, that you were having something like 1,500 registrations, or even more than that. At the last count, I don't know what was the last count, but day before yesterday, I was told 1,500 registrations. and all the 3 platforms was live, including our own platform plus LinkedIn plus YouTube, and it came out pretty well. And the quality, particularly the quality of speech and the quality of panels and the speakers were absolutely outstanding. So by all yardsticks, I think this had been an extremely well executed, well planned, and well executed sessions. And if I counted correctly, there were 26 or 27 sessions all put together, and that itself speaks volumes for of the event. So once again, thank you all. I won't take any more time. You have done absolutely marvelous job. Thank you all. Bye.
Thank you, Krishna ji. Thank you, Venkata ji, for all your guidance and support. Thank you very much. Yeah.
And close it. Close it. We can switch off the video here. Then you must be